Alternatives to Positivism Chapter 1, Between Science and Metaphysics. 1. Metaphysics and Anti-Metaphysics of Positivism. Introduction. By Igor Naletov. The scientific and technological revolution which started in the mid-20th century has proved to be a serious test not only for many scientific theories, but also for a number of philosophical ideas, concepts, and even major trends. It affected, first and foremost, those philosophical schools which were, or claimed to be, connected with natural science. The global nature of many scientific problems, the high level of theoretical abstractions, the wide scope of generalizations and the deep differentiation and integration of scientific knowledge enhanced by the scientific and technological revolution have increased the progressive scientists' concern about the ethical aspects and humanistic orientation of research and sharpened their sense of social responsibility for the destinies of mankind. The acceleration of scientific and technical progress has intensified their natural interest in the latest achievements of philosophical thought and emphasized the need for a genuinely scientific philosophical theory that would make it possible to comprehend concrete scientific problems in a broad theoretical, methodological, and social context and provide a key to the most crucial issues of our time. It is not fortuitous, therefore, that of all the major philosophical trends and schools those related more or less closely to science and representing it in some form or other were the first to weather the storm. And no wonder that positivism and dialectical materialism, the two teachings that have always professed their adherence to science, recognized its great mission and expressed their readiness to serve its lofty ideals turned out, as it were, to be the two poles of attraction for increasingly theory-minded natural scientists. Which of the two philosophical schools will be able to pass through the crucible of time and provide reliable guidance for creative thought in the epoch of scientific and technological revolution? The author of this book undertakes to answer this crucial question and to substantiate the answer to the extent a task of such dimensions is accomplishable within the scope of a single monograph. Many Soviet and foreign philosophers believe that contemporary positivism, despite its professed adherence to scientific thinking, is undergoing a deep ideological crisis because of an obvious and ever-growing rift between its methodological program and the tasks, tendencies, and principles of modern science. The nature of this crisis sharpened by the scientific and technological revolution deserves special attention, the more so as there is a glaring contradiction between the actual results of the evolution of positivism and its professed goals, between its pretentious claims and the real contribution to scientific progress. Speaking of positivism and its crisis, we shall mainly concentrate on the third stage of this philosophy known as logical positivism and often referred to as logical empiricism or analytical philosophy, and make occasional digressions to the previous stages in order to trace certain current concepts to their sources. Positivism as a philosophical trend is known to derive from radical empiricism, which is one of the pillars of this teaching in all its forms. According to the program of logical positivism elaborated by the Vienna Circle, science begins with the observation of similarities and differences between phenomena, i.e. with the observation of single facts. Established facts provide a basis for initial empirical generalizations which, after an additional study of separate phenomena and events, are transformed into broader generalizations. Universality of statements can only be attained at a theoretical level, and such universal truths are regarded as empirical laws constituting the basis and the core of all theoretical knowledge. The development of science thus consists in the progressive expansion of empirical generalizations, and inductive conclusion turns out to be the main instrument of such development. Expressing the concept of empiricism in a concise logical form, Rudolf Carnap, one of the leaders of logical positivism, wrote, "Science begins with direct observations of single facts. Nothing else is observable. Certainly irregularity is not directly observable. It is only when many observations are compared with one another that regularities are discovered." The rapid development of fundamental research in the 20th century has clearly shown the untenability of logical positivism based on radical empiricism. As a matter of fact, the entire history of modern science, starting from the development of the quantum theory and the theory of relativity and ending with cybernetics, is a repudiation of the tenet of empiricism. It is not accidental that most contemporary philosophers of science reject the reduction of theoretical knowledge to empirical knowledge. They believe that knowledge does not begin with observations and sensual experience, since observation is always preceded or attended by theoretical concepts. Yet this general premise is still a long way from regular criticism of empiricism as the core of positivist philosophy, as well as from a comprehensive theory of scientific knowledge and its consistent substantiation. The actual relationship and unity of the empirical and the theoretical in scientific cognition, their concrete interaction in the history and logic of science, the passage from lower to higher levels call for a detailed investigation. Nevertheless, the development of the entire Western philosophy of science in the 1960s and 1970s is keynoted by a revision of the program of radical empiricism found to be untenable both methodologically and theoretically. And this is a very grave symptom of an ideological crisis of this philosophy. Another sign of the predicament of the philosophy of science which follows in the wake of positivist traditions is a drastic change in its attitude towards metaphysics. The struggle against metaphysics and the attempts to oust it from science and philosophy have had both positive and negative aspects. The positive effect of the campaign against metaphysics, which was a characteristic feature of early positivism, consisted in its opposition to the traditional speculative, particularly religious and idealistic, philosophy which showed little interest in concrete problems of scientific cognition and practical life. On the other hand, positivists rejected as metaphysical practically all most general and, in essence, traditional problems of philosophy as unrelated to science. These included the problems of objectivity, necessity, causality, essence, etc. Such problems, according to positivists, went beyond the limits of experience, did not accord with the basic tenets and criteria of empiricism, and were therefore declared speculative, senseless, non-scientific, etc. Unlike most pre-positivist critics of the so-called metaphysics who were not opposed to a philosophical theory dealing with traditional problems in one or another form, positivism rejects metaphysics in principle both as a method and a specific field of knowledge and declares all its problems to be irrational by nature. The negative attitude towards traditional philosophy is regarded by positivists themselves as a characteristic feature of their concept and as one of its fundamental principles. If one wishes to characterize every view which denies the possibility of metaphysics as positivistic, wrote Schlick, this is quite unobjectionable, as a mere definition, and I should in this sense call myself a strict positivist. In order to overcome metaphysics, logical positivism advanced an extensive program providing for a logical restructuring of the whole edifice of science in order to standardize the language of science, clear up its logical structure, identify the basic elements of knowledge, and reduce all the other concepts and propositions of science to these elements. These tasks, according to the exponents of the new theory, were to be accomplished through the agency of mathematical logic. At this stage the so-called philosophy of science posed as the logic of science, claiming to give the anatomy of science with the help of mathematical logic. Yet all attempts by positivism to become a pure methodology were doomed to failure. In substantiating the platform of the philosophy of science, positivism could not but proceed from a set of definite philosophical principles, i.e. from a new metaphysics of science. This metaphysics with its idealistic and anti-democratic premises gave a distorted picture of the world in which the existence of the object was made conditional on its sensual perception by the subject, the reality was construed as an aggregate of elementary facts, etc. One of the symptoms of the current crisis of positivism consists in that the exponents of the philosophy of science have renounced yet another tenet of their teaching and are turning their eyes to what they call metaphysics. Proposals are even made to start developing a new metaphysics on a more or less regular basis. The concept of metaphysics, however, is extremely broad and sometimes reflects a stable interest in the problems of materialism and dialectics. The attempts to solve such problems, though far from being consistent, testify to a search for a new methodological basis and a new system of values. Eberfagel, for instance, defends the scientific status of such metaphysical problems as the relationship between consciousness and the brain. Mario Bunge believes that the main task of the new metaphysics is the construction of scientific ontology. Mark Zwartowski writes that metaphysics represents the most general method of articulating, in critical and systematic form, the alternative conceptual frameworks within which theoretical understanding becomes possible. The heuristic force of metaphysics lies in its closeness to our primary modes of understanding and explaining. Recognizing the methodological role of metaphysics, Zwartowski, however, fails to give a clear idea of its content. Despite the obvious tendency towards a more realistic approach to the structure of scientific knowledge, to general philosophical principles and categories and to their role in the development of science, it is already clear that the philosophy of science remains and will evidently remain loyal to some basic traditions laid down by the classics of positivism, focusing on the problems of the logic of scientific cognition, the language of science and special problems of the methodology of science. Natural science in the first place. Deviating from some dogmas of positivism, it does not relinquish its claim to the title of the philosophy of science, thus determining the sphere of its interest. In our subsequent discourse we shall use this name too, inasmuch as it is associated with Western, particularly Anglo-American philosophy. It will also be in place here to define our attitude to the term metaphysics, which will be frequently used in the subsequent text. Though it has acquired a positive sense in anti-positivist literature, being almost synonymous to general philosophical problems, we shall abstain from equating these notions and use the term strictly in the sense it has in the context of the philosophical doctrines under consideration: negative in positivist philosophy, positive in the concepts of scientific realism, etc. Each of these doctrines will be treated separately and the reader will have no difficulty in identifying the context in which the term is used, thus making the inverted commas unnecessary. As regards the methodological problems discussed in the book, we shall call them all philosophical, distinguishing each time between their specific types, such as theoretical, philosophical, methodological, ontological, epistemological, logical, and others. In the already extensive critical literature on positivism, the most controversial problems appear to be those connected with the relationship between theory and sensory experience, the attitude to metaphysics, and the objectivity of knowledge. The concepts of causality and determinism, by contrast, have been relegated to a secondary plan and are usually discussed as separate issues independent of other basic problems, though the most prominent exponents of positivism have always, at all the stages of its evolution, focused their attention on causality, the nature of scientific laws and scientific explanation. There is no doubt that their views on these problems should be critically reappraised. Besides, the problems of causality and determinism are obviously linked with a number of general epistemological and methodological issues and influenced by radical empiricism, reductionism, induction logic, etc. One or another solution of these general issues, and such solutions, despite the downright rejection or dodging of metaphysics, could never be avoided, has had a direct bearing on the concepts of causality and scientific law. Conversely, any interpretation of the concepts of causality and determinism could not but affect the general conclusions of the theory of knowledge and the positivist methodology of science. Similarly, the negative attitude towards metaphysics has predetermined the rejection of causality and determinism as pseudo-problems. In turn, the positivist interpretation of causality was partly accountable for the negative attitude of positivism in general and logical positivism in particular to general philosophical problems. In a lecture delivered at Oxford in 1958, Friedrich Waismann, one of the pillars of positivism, referred to 1927 as the year of the funeral of causality. Explaining the title of his lecture, The Decline and Fall of Causality, Waismann contended that the collapse of the principle of causality was not unexpected, as it had been prepared by a long period of its general recognition. According to Waismann, this recognition dated back to the 18th century, i.e. to the Laplacian concept of determinism, which inspired scientists with a hope that the location of all possible systems in space and time, as well as their physical state, could be accurately predicted given the knowledge of their initial state. Laplace, in Waismann's opinion, became the exponent of the principle of causal determinism, which had prevailed for more than a century and a half as an ideal of scientific explanation. For all the power of human intellect, however, such an ideal was unattainable even in the realm of classical mechanics, which was greatly indebted to Laplace. It was called in question as soon as scientists found it impossible to measure physical values with ideal accuracy implicit in the Laplacian doctrine. The concept of causality was bound to collapse, as was the Laplacian ideal of scientific knowledge. According to Weismann, causality was dealt a final blow in 1927 by Heisenberg's principle of uncertainty, as it dismissed completely the possibility of any prediction of events on the subatom level. Western philosophers were not slow to attack Weismann's views, yet even in the 1960s most of his opponents stood but for a limited rehabilitation of the principle of causality. Of late, the criticism of positivist views regarding causality and determinism has become sharper, broader, and more elaborate. The opposing concepts, inconsistent as they are, tend to restore causality to some of its methodological and theoretical rights. Nevertheless, it is still hard to say which path the philosophy of science will follow in treating these issues. There is no doubt that logical positivism can be credited with posing a number of interesting scientific problems. No less obvious is the contribution made by its outstanding representatives to the development of the logic of scientific cognition, the investigation of some specific problems of the language of science, etc. There is no denying the fact that this school has helped science to get rid of fruitless speculations and dogmatism. We do not focus on the deserts of logical positivism deliberately, since our interest lies not so much in positivism per se as in the lessons that could be learned from the analysis of its weaknesses, limitations, and errors. The sharp criticism of the positivist methodology is not the only obvious symptom of its current crisis. Using Thomas Kuhn's terminology and his approach to the analysis of crisis situations in sciences, one should attach special significance to the emergence, within the framework of the contemporary philosophy of science, of a multitude of rival concepts which go far beyond a critical revision of certain aspects of the positivist methodology of science and lay claim to a new methodological paradigm. In point of fact, they strive to develop a more or less complete methodological alternative to positivism and work out a philosophical program defying positivism on all or nearly all key issues. Such alternative programs are represented by critical rationalism, scientific realism, historical trend, and other, perhaps less influential, schools of the contemporary philosophy of science in the West. Which course will the philosophy of science follow? What new theory, if any, is likely to emerge as a result of the present crisis? To answer these crucial questions, one ought to find out, first and foremost, the real relationship between the above-mentioned schools and positivist philosophy, i.e. the depth of division between them, the existing traditional and conceptual links, the ability of these schools to solve the topical, methodological, and theoretical problems of contemporary science, and the adequacy of the proposed solutions from the viewpoint of scientific and technical progress. The crisis of positivism has been brought about not only by the internal contradictions of its platform, but also by the inadequacy of its understanding of the real nature of scientific investigation, of the laws and history of scientific knowledge. We shall not concentrate therefore on the issues that preoccupied positivism at different stages of its evolution, but give our main attention to the most general, fundamental problems connected with the world outlook and methodology which are in the focus of attention of scientists, philosophers, and practical workers at the present time. What we mean is the relationship between philosophy and natural science, the nature of scientific knowledge, the objective content of notions and theories, i.e. their relation to the outside world, the role of the subject in the construction of scientific theories, the reliability and verifiability of scientific concepts, the role of the principles of causality and determinism in research, etc. The fact that throughout its entire history positivism has either been ignoring some of these problems altogether or trying to dismiss them as irrelevant to scientific investigation is, in fact, of little consequence. Willy-nilly, all masterminds of positivism, starting with Auguste Comte and Herbert Spencer and ending with Rudolf Carnap and Alfred Ayer, were compelled to come to grips with them. What is more, it is these fundamental problems and not the specifically positivist issues such as the logical structure of statements, the meaning of reduction, the structure of explanation, etc. that proved to be the main battlefield where the fate of positivism as a philosophical teaching was decided. It should be noted that the above problems will be considered in this book not as separate subjects divorced from one another and from other problems, but in their logical connection with other problems and always in the context of the methodology of scientific knowledge. For instance, the solution of the problem of the source of knowledge predetermines, to a certain extent, the solution of the problem of causality or the relationship of the philosophy to science. Conversely, the solution of the problem of causality will influence the specific form of the analysis of epistemological problems. Hence, we shall try to deal not with some random distinctions and features of this or that school or some peculiarities in the interpretation of a problem by different thinkers, but with a more or less connected system of their basic principles. We shall focus, therefore, either on the essential common features in the philosophical concepts of different representatives of one and the same school or, on the contrary, on the basic differences in the views of the adherents of different schools. Understandably, some specific features of different philosophical trends and some peculiarities in the views of their representatives will be, of necessity, left out of account. The controversy over the fundamental problems of philosophical methodology is highly instructive as it highlights their contemporary significance. Thus, the attitude to science on the part of the exponents of positivism is a logical consequence of their absolutization of the empirical methods of cognition, whereas the attitude to science of critical rationalists stems from their interpretation of the verification problems. Scientific realism as a philosophical trend regards science as practically the only source of material for philosophical analysis and for any concepts of the world. The conflict of opinions reveals weaknesses in each of the above philosophical teachings, shows how they distort the actual process of cognition and exposes their prognostication errors. The present-day significance of the problem of causality, too, becomes more apparent if we, on the one hand, find out the reason for the negative attitude to it on the part of the positivists and, on the other hand, show its revival in critical rationalism as expounded by Popper, who displays special interest in the forms of theoretical explanation and in the deductive models of the process of cognition. Highly instructive is also the collision between the concept of causality rehabilitated and revised by scientific realism in the spirit of materialism and the logical concept characteristic of the positivist approach, inasmuch as this collision highlights the specific demands of contemporary science on the means of a theoretical causal explanation and prognostication and reveals the very essence of the principle of causality. It would be impossible to define the prospects of the methodology of scientific cognition without considering the confrontation between positivism and Marxist-Leninist philosophy. The history of critical rationalism, scientific realism and other new trends in the philosophy of science runs into several decades at most, whereas the ideological struggle between Marxism and positivism dates from the mid-19th century and is in fact as old as Marxist philosophy itself. Important as they are, the old-time philosophical battles will not command our attention, since our chief interest lies, as has already been indicated, in a comparative analysis of the dialectical materialist methodology and post-positivism. As regards the problems which will be considered in the light of dialectical materialism, the author has not set himself the task of expounding in a systematic form the commonly known Marxist concepts or the views of the classics of Marxism-Leninism on these issues. Proceeding from the basic principles of their solution known from Marxist literature, the author has attempted to reveal their topical aspects and new forms of interpretation and solution in accordance with the latest scientific data and new philosophical tasks posed by the scientific and technological revolution. The book, therefore, does not pretend to an exposition of any set of truths, but rather underscores the need for a further investigation of the problems of interest from the methodological positions which the author believes to be the most fruitful and promising. It is the author's conviction that the mutual understanding of philosophers investigating the methodology of scientific cognition is more and more becoming a reality. Chapter 1. Between Science and Metaphysics. 1. Metaphysics and Anti-Metaphysics of Positivism. By Igor Naletov. There is hardly any trend or school in Western philosophy that could compare with positivism in the depth and durability of its influence on society, particularly on intellectuals. Since the first half of the 19th century, positivism has suffered many ups and downs, and the interest in this teaching has alternately risen and subsided. Its founders have had the greatest of triumphs a thinker can dream of, and sunk to the depths of the bitterest humiliation and derision that may fall to the lot of an unlucky philosopher. The powerful grip of positivist philosophy on intellectuals' minds and the periodic tides of its universal popularity can only be accounted for by its sincere devotion to, even worship of, science. However biting today's remarks about the destiny of positivism as a philosophical trend, one can hardly question the sincerity of its intentions to enter into a firm and durable alliance with science. Born in the atmosphere of universal ecstasies over the successes of the natural sciences, positivism has preserved till nowadays its romantic faith in the power of experimental investigation, its appeal for realism in cognition, and genuine interest in the scientific analysis of everyday experience and language. In the light of contemporary science and philosophy, which have gone far ahead in the understanding of the laws of scientific cognition and the effectiveness of the interaction of natural and social sciences, a number of its concepts appear now to be naive and sometimes even ill-matched, the more so as positivism, like any other philosophical trend, assumed different forms in the works of its exponents. John S. Mill earnestly strove for accurate applied knowledge without realizing the fatal narrowness of his concept of such knowledge restricted within the bounds of the bourgeois world outlook and system of values. Bertrand Russell hoped to find strict logical rules for solving philosophical problems, including those in the sphere of ethics. Rudolf Carnap made persistent attempts to resolve the growing contradictions inherited from the previous forms of positivism. In positivism, like in many other philosophical schools, one should always distinguish between the ideas of the classics and their followers. The former, representing progressive tendencies in science, can usually be identified, first and foremost, by their profound devotion to the goddess of philosophy and, alas, by sometimes no less profound delusions. Unlike the wholehearted founders of positivism, their numerous mediocre imitators lack the necessary critical spirit of trailblazers in science and, instead of exploiting the success of their forerunners and rising to a higher level, fall to aggravating their shortcomings and debasing their fruitful ideas. For all the delusions of the founders of positivism, we cannot but pay tribute to the noble endeavors of such outstanding scholars of their time, scientists in the proper sense of the word, as Bertrand Russell, Rudolf Carnap, and Ludwig Wittgenstein, who did everything possible to bring closer together science and philosophy even at the expense of their personal self-disparagement. Indeed, there is something unnatural about a professional philosopher contending for self-destruction of philosophy, its abrogation and dissolution in positive scientific knowledge. People usually regard this either as cunning, or as reprehensible folly, and are apt to overlook the possibility of the scientist's utter selflessness in the service of his goddess, which goes hand in hand with modesty and complete indifference to scientific degrees, honorary academic titles, priority, and material benefits. Such selflessness may induce a true scientist of outstanding erudition and talent to be content with the role of a humble clerk in attendance on an endless flow of scientific papers, the meaning of which will always remain unknown to him. His devotion to science may even cause him to assume voluntarily the function of a cleaner of scientific Augean stables and become, so to speak, a scientific scavenger. In the 1830s, when German classical philosophy, with its pledges to explain nature by itself, to penetrate the very core of the universe and establish eternal control over its mechanism, seemed to be at the summit of glory, the challenge of young positivism and its promise to rid science of quackery, whoever the genius behind it, came as a gust of fresh wind and deserved every respect and recognition. Positivism was indeed a tree planted for the benefit of science and intended to promote its greatness and glory, however bitter the fruit that was eventually borne by it. The rapid development of experimental science in the 18th and early 19th centuries, The natural attraction held out to scientists by the empirical methods of research gave rise to an illusion that all problems of natural science and social development could be solved exclusively by empirical means, and that the techniques used in the natural sciences should be broadly applied to social research. Practicism and utilitarianism, characteristic of the way of life in the developing capitalist countries of Western Europe, Britain, France, later Germany, and still later the USA, gradually became a standard of scientific thinking. Referring to this feature in early positivism in the first half of the 19th century, one of its founders, Herbert Spencer, said that the wish to possess a practical science which could serve the needs of life was so strong that the interest in scientific investigation not directly applicable to practical activities seemed ridiculous. Enthusiasm over the new methods of scientific investigation, naturally, went side by side with growing skepticism towards the knowledge which did not conform to everyday experience, could not be obtained within the framework of the empirical approach, or had no direct practical application. Nevertheless, the ideology of positivism contributed to some extent to the development of natural science, particularly experimental investigations, and helped science to free itself from the fetters of the religious world outlook and various speculative doctrines and artificial, not infrequently mystic, concepts and theories. Positivism as an embodiment of this tendency has served as a good purgative. In the 1830s, while still in its cradle, positivism came out with a demand to oust idealistic philosophers from science and subjected idealism and religion to sharp criticism, regarding them both a product of the mythological stage in the development of human spirit. According to the positivists, metaphysics had very much in common with theology and differed from it in form only. Both of them represented different systems of world outlook and, as such, were outside the limits of scientific knowledge. Auguste Comte, another founder of positivism, repeatedly stressed the affinity and, in some important aspects, even the identity of the theological and metaphysical methods of thinking. In his opinion, the basic distinction of metaphysical concepts consisted in regarding phenomena as being independent of their carriers, and in attributing independent existence to the properties of each substance. He considered it immaterial whether these personified abstractions were later turned into souls or fluids. They came from one and the same source and were the inevitable result of the method of studying the nature of things which was characteristic in every respect of the infancy of human mind. This method, according to Comte, inspired originally the idea of gods which were transformed later into souls and finally into imaginary fluids. Comte rejects metaphysics, i.e. everything that goes outside the limits of science, and proclaims the ideal of positive knowledge and, accordingly, a new philosophy. Yet metaphysics, according to Comte, is not entirely identical with religious thinking. Moreover, it prepares mankind for a transition to scientific thinking. A metaphysical thought is, so to speak, an intermediary between the theological and the scientific ways of thinking, and performs simultaneously a critical function in relation to science. Owing to imagination which prevails in metaphysical thinking over observation, the thought becomes broader and is prepared unostentatiously for truly scientific work. According to Comte, another contribution of metaphysics to the emergence of positive science consisted in that it performed the vitally important function of theory until the mind was able to develop it on the basis of observations. Philosophy in its traditional guise is identical with metaphysics. Its existence can only be justified as long as science is unable to solve certain general problems. Hence, philosophy is only destined to pave the way for science and ceases to exist as soon as science takes over. It is only within this brief lifespan, measured off by history, that philosophy contributes to the emergence of science. Its cognitive value is limited to the preliminary formulation of problems. The social task of philosophy consists in attracting the attention of the broad masses, even amateurs in different fields, to these problems, but their solution should be the concern of the positive sciences and narrow specialists. Despite the long evolution of positivist philosophy, this understanding of science and of the relationship of science to metaphysics was shared by all exponents of positivism. The problem of demarcation between science and metaphysics, in some periods just implied, in others posed sharply and uncompromisingly, was one of the key issues in the program of positivism at all its stages and even the main driving force of its development. In the 1920s, logical positivism, starting from the investigations of the Vienna Circle, continued its struggle against metaphysics from the positions of empiricism, though less radical than that of Auguste Comte, John S. Mill, Ernst Mach, and Richard Avenarius. According to the principle of verification first defined by Moritz Schlick and further generalized by Ludwig Wittgenstein, the truth of every scientific statement must be ascertained by comparing it directly with the evidence of the senses. In a later version, Alfred Ayer described this principle as follows: the criterion which we use to test the genuineness of apparent statements of fact is the criterion of verifiability. We say that a sentence is factually significant to any given person, if, and only if, he knows how to verify the proposition which it purports to express, that is, if he knows what observations would lead him, under certain conditions, to accept the proposition as being true, or reject it as being false. If, on the other hand, the putative proposition is of such a character that the assumption of its truth, or falsehood, is consistent with any assumption whatsoever concerning the nature of his future experience, then, as far as he is concerned, it is, if not a tautology, a mere pseudo-proposition. The sentence expressing it may be emotionally significant to him, but it is not literally significant. And with regard to questions the procedure is the same. We inquire in every case what observations would lead us to answer the question, one way or the other, and if none can be discovered, we must conclude that the sentence under consideration does not, as far as we are concerned, express a genuine question, however strongly its grammatical appearance may suggest that it does. Hence, empirical verification was assigned a function which went far beyond its possibilities to appraise the truth value of all statements without exception. As compared with the previous forms of positivism, the new element here was the division of all statements into two types, analytical and synthetic. Analytical statements were regarded as tautological or identical, similar to those often used in mathematics and mathematical logic. Synthetic statements were regarded as object judgments characteristic of empirical, factual sciences and claimed to be the only statements which carried any new information. Regarding the first two types of statements as being of some scientific significance, logical positivism not only denies all other statements any scientific value, but considers them simply senseless. If one or another statement does not lend itself to direct verification, it must at least be reducible by logical means, as a theoretical, non-analytical statement, to a corresponding basic or protocol statement which can be confirmed by direct observation. Statements which are neither analytical nor synthetic are meaningless and subject to elimination from the language of science as metaphysical. The narrowness of the verification criterion induced the positivists to make repeated attempts at its modification. The watered-down version of this criterion admits of both full and partial verification of statements, i.e. of their partial confirmation by empirical data. A theory was needed, however, which being itself in agreement with this criterion, would define more accurately the notion of confirmation, on the one hand, and correspond to the general program of positivism and to the traditions of empiricism, on the other hand. A most significant attempt to develop such a theory was Carnap's inductive logic expounded by him in Logical Foundations of Probability and in the Continuum of Inductive Methods, and then, in an enlarged and elaborated form, in a basic system of inductive logic. A characteristic feature of both versions of his system consisted, first and foremost, in that the logical probability of the meaningfulness of universal generalizations was recognized to equal zero and that there existed a theoretically neutral language of observations. Out of the three phases of inductive inference, the selection of the language, the selection of the statements of this language and the assessment of the degree of confirmation of a given statement by other statements, Carnap focused on none other than the appraisal of the probability of statements relative to the results of the observation. As we see, in Carnap's inductive logic, the traditional problem of induction undergoes a considerable transformation. The main task of an inductive conclusion is regarded to be the formulation of a probabilistic prognostication of a particular event rather than of a universal assertion. Induction for Carnap is practically any non-deductive conclusion and, primarily, a metalinguistic statement establishing, on the basis of experimental data, a definite degree of confirmability of a hypothesis. Consequently, Carnap expands the volume of the traditional concept of induction, on the one hand, and, on the other, eliminates the problem of confirmation of universal assertions, i.e. laws, from its content. According to Carnap, universal laws appear to be senseless from the viewpoint of the verification principle and inconfirmable in inductive logic. In point of fact, universal statements are useless. No one, in Carnap's opinion, will make a stand for the universality of this or that theory in any part of the universe. All a scientist or a practical worker may want is a hope that the next test will confirm his hypothesis. The logical evolution of Carnap's views brought him later to an admission that a shift in emphasis from confirmation to decision-making in the analysis of inductive logic's problems would provide even a more radical method of ousting universal laws as the last remnants of metaphysics in science. Such a shift would indeed free science from universal laws, replacing them with specific hypotheses. Finally, in the foreword to the second edition of Logical Foundations of Probability, Carnap altogether avoids mentioning the degree of confirmability in connection with the assessment of inductive probability and prefers to speak of the significance of inductive logic for the theory of solutions only. This looks like the end of the last hope to construct the methodology of science on a strictly logical foundation. The failure to solve this problem cannot but tell on the prospects of the program of empiricism, since it affects the two most important and interconnected premises of positivist philosophy. A question is bound to arise: are the principles of Carnap's inductive logic purported to be helpful in the solution of the main task of logical empiricism compatible with the principles of empiricism itself? It has already been pointed out that Carnap's inductive logic was focused on the evaluation of the degree of confirmation of hypotheses. It proceeded from the assumption that the statements concerning such confirmations by empirical data were the result of metalinguistic analysis and, as such, analytical statements. Carnap emphasized that his inductive logic excluded any a priori synthetic principles and not only remained loyal to empiricism but even in some respects corrected its shortcomings, thereby strengthening its positions. The principle of induction, as formulated by Carnap, was based on the assumption that the experimental data testified to a very high degree of probability of the world's uniformity. Since the probability in the formulation of this principle was logical by nature, the statement as such was analytically true. Its truth was not necessarily conditioned by the truth of the principle of induction. It was sufficient to know that this principle was probable. The contradiction inherent in this proposition consisted in that the principle of induction itself was assigned a role of the foundation of logic and, consequently, its analytical truth value could not be deduced from the very same logic, but was to be established within the framework of a more general logical system. All attempts made before Carnap to develop the logic of inductive conclusion pivoted, as it were, on the principle of the uniformity of nature which lay at the root of the principle of induction. Yet this latter principle is ontological rather than logical and cannot be obtained through inductive generalization. According to Kant, it could have been classified with good reason as an a priori synthetic generalization. Carnap, as we see, could not avoid this ill-fated dilemma either and had to make his choice between an a priori synthetic generalization and an ontological statement. A detective story writer skilled at stock phrases could have summed up the situation in these words: the fateful shadow of metaphysics has again crossed his path. It was not fortuitous that Carnap, seeking later to provide a rational substantiation for induction, pointed out that the axioms of inductive logic could only rest on a priori statements and argued that inductive logic as such could be constructed in a formal way. Yet inductive probability could only be justified in the context of the theory or solutions where the concept of probability is linked with utility and rational action. The search for a non-inductive foundation of inductive logic as a form of scientific cognition brought Carnap in the end to the understanding of probability as a reasonable degree of faith. As a result, the theory of induction turned out to be built on the sand of intuitive and subjective propositions. Each of the paths tried by Carnap in his attempts to substantiate induction on the basis of empiricism led him beyond its limits right into the arms of metaphysics. It is noteworthy that logical positivism seeks to reinforce empiricism in its drive against metaphysics by a logical analysis of the structure of knowledge. For all the internal contradictions of Carnap's version of logical positivism, it turned out to be the most successful of all, as it revealed one of the main trends in the development of positivism and displayed a characteristic feature of its understanding of the subject matter of philosophy. Significantly, both the adherents and opponents of Carnap's theory often call it logical empiricism. The search for new ways in the struggle against metaphysics was by no means accidental. Already in the 19th century, the development of theoretical sciences revealed the narrowness and inadequacy of the empiricist program for the revision and restructuring of science which had been advanced by early positivism. It became clear even in that period that the program of struggle against metaphysics ran counter to the interests of science and hampered the development of theoretical investigation. The theory of the atomic structure of matter, quantum mechanics, and the theory of relativity provided ample proof that empiricism as a philosophical and methodological program was useless and even detrimental to scientific progress. The rapid development of logico-mathematical studies in that period seemed to indicate an attractive and promising way out of the difficult situation to treat a theory as an aggregate of logically interconnected facts. That anti-metaphysical line was started by Russell and then developed by Wittgenstein in his Tractatus Logico-Philosophicus into an elaborate theory followed by their successors. Russell did not yet shun many traditional philosophical problems which he hoped to solve through the agency of strict rules of mathematical logic. His failure on this path caused Wittgenstein to take a more uncompromising position, not only to divorce science from metaphysics, but also to throw the latter overboard as senseless mysticism. The centuries-old controversy over certain philosophical problems pertaining to the world outlook was viewed by him either as a result of violation of the elementary rules of logic, or as a linguistic confusion. Alfred J. Ayer, one of the contemporary followers of these ideas, keeping his allegiance to more or less orthodox logical positivism, writes, "We may accordingly define a metaphysical sentence as a sentence which purports to express a genuine proposition, but does, in fact, express neither a tautology nor an empirical hypothesis. And as tautologies and empirical hypotheses form the entire class of significant propositions, we are justified in concluding that all metaphysical assertions are nonsensical." According to Ayer, the typical examples of metaphysical assertions are those underlying the problems of the reality of experience, the unity of the world, the nature of true reality as distinct from sensory experience, etc. Richard von Mises, who regarded his own position relative to traditional philosophy as the most conciliatory among the neo-positivists, was also of the opinion that metaphysics constituted the sphere of pre-scientific propositions and was not entirely devoid of future, as people would always ask questions extending beyond the limits of scientific knowledge. Even in new fields of research, while the adequate scientific language was still non-existent and the main linguistic rules and logical forms were not yet known, new questions going beyond the familiar ground were bound to be at first non-scientific, i.e. metaphysical. To become truly scientific, new concepts must get a footing in their field, merge with the formal systems adopted earlier and develop full ability to communicate, so to speak, with other fields of scientific knowledge. Clearly, this contraposition of scientific and non-scientific or metaphysical knowledge is rooted in a peculiar understanding of the ideal of scientific knowledge. This ideal, according to positivism, is represented by empirical science with its principle of empirical verification of any assertion. To become scientific, a proposition must pass through the purgatory of sense perceptions which alone are capable of providing direct, really verifiable and really objective knowledge. Metaphysics as a specific set of traditional philosophical problems derives, according to positivism, from the recognition of some unique reality which does not lend itself to scientific cognition and can only be apprehended with the help of the metaphysical, speculative faculties of the mind. A more ambitious conception of metaphysics is one that places it in competition with the natural sciences, says Eyre. The suggestion is that the sciences deal only with appearances, the metaphysician penetrates to the underlying reality. All positivists, irrespective of the school to which they belong, hold that traditional philosophy postulates the existence of some transcendental reality which is different from and independent of the sensual world, but which determines its main features. The pretension to know something beyond possible experience presupposes the existence of an extra-empirical source of knowledge. The only method whereby metaphysical philosophers obtain their truths can be the method of a priori speculative reflection. For instance, Russell considered that one of the essential features of the classical tradition in philosophy consisted in a conviction that a priori reflection alone was capable of penetrating the mysteries of the universe. Nothing but an a priori method was capable of proving that reality was different from what appeared to direct observation. Emphasizing that the a priori principle was the essence of traditional philosophy, Mises wrote, "As soon as one speaks of reaching beyond experience and of the disclosure of the true core, one appeals to the existence of extra-empirical sources of knowledge." In spite of all their many differences, such theories as Husserl's Wesensschau and Plato's doctrine of ideas, Spinoza's knowledge through apprehending insight, Kant's a priori and Schopenhauer's trans-empirical metaphysics, are things of a similar kind. This stand, despite certain modifications in different forms of positivist philosophy, has not changed till nowadays. There is nothing, asserts Eyre, that cannot be expressed in the language of observations, and everything beyond these limits is of a mystic nature. In point of fact, however, along with mystic entities, Eyre throws overboard everything that cannot be perceived by senses. According to positivism, the unscientific character of metaphysics springs from its worldview function, or, more precisely, from its social orientation and claim to disclose the essence of the world, as well as from the fact that its propositions are based on convictions. On these grounds, metaphysics is regarded as a false projection of subjective human qualities and emotions on knowledge and on the world in general. The possibility of a scientific world outlook is dismissed altogether, since scientific theories, according to positivism, cannot give answers to questions pertaining to worldviews. The positivists maintain that metaphysics meets man's psychological need for understanding the world as a whole and his place in the world, and is called to life by the fateful questions as to the meaning of human life, moral responsibility, and human values. Yet science is unable to tackle these questions, as they cannot be answered on the grounds of empirico-mathematical investigation, which is regarded by positivism as the only form of scientific knowledge. These questions, according to the positivists, will always remain the objects of unscientific methods of comprehension. Man is entitled to use any means to express his worldviews, including the least suitable one, i.e. metaphysics, but in that case he should not claim it to be what it is not and will never become a science, a system of knowledge. Carnap regards metaphysics not as actual knowledge, but rather as poetry giving but an illusion of knowledge. The worldview character of philosophy is considered by positivism as the main cause of its incompatibility with science. Justly underlining the inseparable ties between the worldview, on the one hand, and ideology and politics, on the other, the positivists come to the conclusion that no problems relating to nature, society, and cognition can be solved by philosophy on a scientific basis, for the simple reason that these problems are treated in the broad context of the world outlook, and their solution depends, in the final analysis, on the views and ideological stand of the philosopher. The desire to arrive at practically useful answers in the most difficult and most general questions of life, says Mises, leads to the construction of systems of metaphysical propositions. Ambitious and noble were the aspirations of positivism, which set out to free philosophy from the fetters of religious and idealistic dogmas. The 20th century seemed to have been destined to become the age of triumph for positivist philosophy. Indeed, it has started with fundamental scientific discoveries, and its closing decades are marked by a profound revolution in the entire system of scientific knowledge, technology and social relations, which are being successfully restructured on truly rational and scientific principles. Ironically, however, This century has also borne witness to the decline and fall of the philosophy that has made science its fetish. Dramatic as it may be, the situation is not likely to rouse our emotions unless we perceive a human drama behind the ideological vicissitudes. In point of fact, the reverses of fortune in the realm of ideas are never divorced from the destinies of human beings and usually entail a drama of a whole galaxy of outstanding personalities, who believed in the viability of the principles they had advanced and did everything possible to defend and elaborate them. One can hardly blame any one of them personally for the long and, alas, futile wanderings in the labyrinths of methodology. If only it were a matter of personal fallacies, mankind would have long ago found a way to avoid them. Yet the bitterest irony consisted, perhaps, in that positivism, whose credo was service to science, failed to find a common language with its master for any appreciable length of time. True, there were periods when positivism was in vogue. Its shares went up at the turn of the 20th century with the discoveries of the complex structure of the atom and of the electromagnetic field. Hopes also soared in the 1920s, which were marked by the successful development of quantum mechanics and the theory of relativity. Another spell of good luck came with the intensive investigations into the problems of linguistics and psychology in the 1930s and 1940s. Finally, the last boom was connected with the rapid development of cybernetics and genetics, neurophysiology, and psychophysiology. The philosophy of science has been favorably commented upon and can even boast of the homage paid to it by Henry Poincaré, Albert Einstein, Bertrand Russell, Niels Bohr, Werner Heisenberg and Jacques Monod. Yet it is also known that the heights of their mutual sympathies invariably coincided with the periods of abrupt breakdown of old fundamental theories rather than with constructive periods in the history of science. Once a crisis in science comes to an end and the gulfs are bridged, the philosophy of science in its logico-empirical version would inevitably reveal its inability to offer a positive program for scientific, technological, or social progress. Each new upswing of theoretical thought was a sure sign of approaching depression in positivist philosophy. Yesterday's followers and adherents of positivism would promptly turn away from the friends of science, and the short-lived mutual understanding would give place to even a more profound and lasting mutual distrust than before. These tides remind one of something like intermittent fever in Western science, and the blame for it can hardly be put on any particular individual. The disease must evidently be traced to a source other than the human qualities of each separate thinker, be he great or mediocre, honest or hypocritical, egoistic or unselfish. It proved to be contagious for altruist Einstein and misanthrope Heisenberg, great Bohr and mediocre Paul Volckmann. The true cause of the illness lies not in the merits or demerits of individuals, outstanding or at least interesting as they are, but in the conditions of contemporary society. The role of social conditions in the emergence and development of positivism is a separate subject that lies outside the scope of this work. Here I shall confine myself to discussing the general laws and tendencies of scientific cognition, which provide, as it were, an epistemological background of the developing ideological drama. Paradoxical as it may seem, this drama is contained in embryo in the basic tenet of positivism determining its attitude to science. It is precisely the glorification of science and the disparagement of philosophy that did positivism an ill turn, accounting for the skepticism and even for the downright denial of the value of scientific cognition that are characteristic of positivist works. How did the extremes meet? To answer this question, let us turn once again to the positive platform of the philosophy of science. Rejecting traditional philosophy as unscientific and metaphysical and using many other disparaging epithets to belittle its role, positivism has never denied the need for philosophy in general. On the contrary, the exponents of positivism have underscored the significance of a new, scientific philosophy which was called a philosophy of science and given it many other no less pretentious titles. What was the real meaning of their contentions? Philosophy as a theory of the most general and essential laws of being was eliminated by Kant in favor of some universal system of scientific knowledge. All scientific knowledge, according to Kant, can only be obtained by special sciences through observation, experiment, description, and generalization with the help of broadly used mathematical means. There can be no specifically philosophic understanding of nature different from that ensured by the natural sciences. Whatever the particular distinctions in the understanding of the subject matter of positivist philosophy revealed by different representatives of the first form of positivism, there is every reason to assert that their views are in the main identical. New philosophy has in fact nothing in common with old metaphysics and does not basically differ from other positive sciences. Both the positive sciences and scientific philosophy are absolutely neutral in the metaphysical sense, i.e. in relation to materialism and idealism. The main object of a philosophical investigation is science, its concepts and method. The methods of philosophical investigations are also borrowed directly from science. In short, science is its own philosophy. It is these ideas, developed and elaborated during the evolution of positivism, that underlie its understanding of the subject matter of philosophy. Just like the rapid development of special sciences and the strengthening of their experimental base in the 18th century gave the early positivists occasion to contend that scientific investigation should substitute for philosophic cognition of the world, so the development of biology and psychological sciences was in the late 19th century interpreted by Marxism as the elimination of metaphysics from the studies of man's cognitive activities in favor of a scientific theory of knowledge. This idea was clearly expressed by Marx follower and commentator V.V. Lisovic, one of the first Russian positivists. What will remain of philosophy after the theory of knowledge, too, gains the status of a separate and independent science? He asks and proceeds as follows: when psychology, thanks to its successes, rose to a truly scientific level, no fragment was left of the old all-embracing and undivided science, philosophy, which could be said to possess the property of universal and comprehensive knowledge. Its place was taken up by a number of separate independent sciences, and philosophy in the old sense of the word disappeared. The achievements of biology and psychology in the study of man, his psychical and cognitive activity, were interpreted by the second form of positivism as the emergence of a scientific theory of knowledge opposing traditional epistemology as unscientific metaphysics. Marxism, like classical positivism, made the concepts and methods of special sciences the object of philosophy, which, consequently, was to be metascientific by nature. According to Mach, a philosopher differs from a natural scientist in that the former has to deal with a broader range of facts. Justly stressing the need for a broad approach to philosophical matters, Mach maintains, in full agreement with the positivist principles, that it is achieved not through the generalization of the process of cognition in philosophical categories and its interpretation on the basis of a definite worldview and methodology, but with the help of some new specialized science which would study knowledge with the use of special scientific means of investigation. Such means, according to Mach, could best be borrowed from biology and psychology, since it was precisely these disciplines that studied man as the subject of cognition and could provide a reliable basis for the understanding of his cognitive activity. The most explicit presentation of the positivist concept of the relationship between science and philosophy can be found in the works of Schlick, Carnap, Wittgenstein, and other members of the Vienna Circle, which is usually associated with the emergence of logical positivism. The representatives of the new trend fully agreed with their predecessors in that scientific philosophy was an imminent product of the development of science, that philosophy should give up metaphysical problems if it was to be promoted to a rank of science, and that it should got both its object of inquiry and its method from science itself. According to neopositivists, the only reason why philosophy had been unable to become scientific for a long period consisted in the insufficient development of science itself, which could not provide the necessary means for philosophy to fulfill its metascientific functions. The emergence of scientific philosophy at the present stage of the evolution of science was a result of the development of mathematical logic, which devised the technical means for the analysis of science. The initial methodological models developed within the framework or positivism were in fact nothing but the application of the ready-made body of mathematical logic borrowed from Principia Mathematica by Russell and Whitehead to the logical development of some hypothetical system of ideal scientific knowledge. Logical positivism was a full-scale realization of the analytical tendency in the understanding of scientific philosophy. Yet unlike Mill and Mach, who initiated this tendency, logical positivism, did not regard philosophy as a theory dealing with the principles of the classification of sciences, the system of laws common to all sciences and with cognition as such, but as an instrument for the analysis of science. This approach reduced philosophy to a scientific system of actions, a kind of analytical activity. Wittgenstein's thesis that philosophy is not a theory but an activity became the banner of an influential trend in analytical philosophy. The great contemporary turning point, wrote Schlick, is characterized by the fact that we see in philosophy not a system of cognitions, but a system of acts. The attempts of the earlier positivists to construct scientific philosophy as a theory are regarded by neopositivists as a relapse of old metaphysics. In view of the growing proportion of highly specific logico-methodological problems in scientific investigations, logical positivism demanded that methodology should be completely independent of philosophy and that a new pure methodology, free from any presuppositions, should be developed that would banish philosophical epistemology together with other philosophical worldview elements from genuine science. According to the logical positivists, the reflection upon scientific knowledge, hitherto the domain of philosophy, turns into a special field of concrete scientific investigation. In this respect, the only distinction of logical positivism from other forms of positivist philosophy consists in that it turns into an absolute the logico-methodological analysis of knowledge instead of empirical science in general and psychology and biology in particular. Logical positivism regards the use of accurate logico-methodological means in the investigation of the structure of scientific knowledge as a scientific method of the formulation and solution of philosophical problems. The emphasis on logic as an instrument of philosophical research is the keynote of the latest stage in the realization of the principal aim of positivist philosophy, viz. discarding traditional philosophical problems and substituting formal logical and linguistic methods of analysis for the philosophical approach to science. It should be noted that positivism denouncing the so-called extra-scientific metaphysics is in effect carrying out a program based on entirely extra-scientific principles. It is wrong to take for granted the assertions of the positivists that their philosophy is free from metaphysics, as the premises of positivism, unlike those of other forms of philosophy, are allegedly self-evident. Positivism is shy of declaring and exposing to analysis the postulates underlying the entire system of its arguments. The metaphysical content of the philosophy of science is admitted retrospectively by the positivists themselves. It has become a peculiar tradition with the positivist philosophers to accuse their predecessors of metaphysicism, inconsistency in the struggle with metaphysics, various concessions to metaphysics and deviations from the principle of neutrality in philosophy. Spencer reproached Comte for concessions to metaphysics. The Machists are advancing similar charges against both of them. As regards the neo-positivists, they are laying claims to a final break with metaphysics which allegedly has never been banished completely from the writings of all positivist philosophers. Defending the concept of phenomenalistic analysis, Gustav Bergman reproaches physicalists for their inclination to metaphysics, which term, as it transpires, he applies to some of their materialistic statements. Even within logical positivism itself, the palm of the most consistent fighter against metaphysics is claimed now by one, now by another of its representatives. It will be shown later that despite all attempts of positivism to discard such problems as the relation of man to being, consciousness to matter, interdependence of space, time, and movement, causality, the nature of contradictions, etc., it is in fact unable to ignore them altogether and has to tackle them in one way or another, often in a disguised form. Moreover, the more persistent the attempts of each new generation of positivist philosophers to dismiss the above problems as metaphysical and nonsensical, the more obvious their importance for science and philosophy. All positivist theories invariably started from some sort of denunciation, be it the denunciation of metaphysics, idealism, dualism, or materialism. Yet all their criticism designed to clear the way for the new scientific methodology always contains in a hidden form some positive, assertive elements. The metaphysics of positivism is all the more dangerous as it is concealed behind loud phrases about the need to fight it and rid science of the cobweb of the past. The oversimplified idea of scientific knowledge and the disregard of its hierarchical multilayer structure, as well as the primitive understanding of the nature of the scientific reflection of the world that leaves no room for the throbbing thought, proved detrimental to positivism even in its self-evaluation and prevented it from understanding the hidden purpose of its own dogmas. Not only did positivism fail to uncover its social face and state its social aims, it proved unable even to define its place in the general process of cognition. The hidden part of the positivist program, its basic general postulates covered up by loud and pretentious declarations, have never been brought to light for open examination. Yet for the purpose of this analysis it is advisable that acquaintance he made of these ghosts of metaphysics kept from the public eye in the backyard. A curious paradox with the positivist philosophy, besides its unhappy relations with science, consists in that in its struggle against metaphysics, positivism at all the stages of its evolution has invariably found itself in a snare of metaphysical concepts, sometimes not a bit more elaborate than those of the 18th century materialism or Hegel's idealistic dialectics. Incidentally, the metaphysical fallacies of German classical philosophy and the Enlighteners' materialism have at least the justification that their speculativeness was partly a result of the immaturity of science and social relations, ruling out the possibility of the profound, truly scientific understanding of the laws and tendencies of social development. But can there be any justification for positivism wallowing in metaphysics and idealism at our time, when philosophy became a branch of science way back in the mid-DLE of the 19th century, when the problem of the relationship between philosophy and special sciences has been successfully solved and they have developed their own powerful means of theoretical investigation? If Minerva's night-flying owl had ventured to make its appearance in broad daylight, it would have inevitably struck against various obstacles and could have hardly become the ancient symbol of wisdom. Positivism, unlike the mythological bird, has appeared too late to win the scientist's faith for long and become the foundation of scientific knowledge. It has never, even in the days of its so-called triumphs, been able to overcome the somewhat ironic attitude of the scientists to most of its claims. Positivism combines in itself the belated faith in empirical science which was the foundation of the industrial power of capitalism in the 18th century with the youthful illusions of its ideologists that the prosperity of capitalist society was inseparable from scientific progress. Yet it is already infected with early skepticism in the anticipation of its inevitable decline and does not believe either in science, industry, or in human values. The metaphysical principles making the foundation of positivist philosophy are similar to those metaphysical doctrines which were characteristic of both the 19th century's idealistic philosophy and mechanistic materialism. How can they tally with the latest versions of positivism, with its refined logic of scientific discovery, semantic philosophy, pseudoscientific terms such as explication, denotation, verification, and the like? The rejection by positivism of such traditional philosophical problems as the relationship of consciousness to being, spirit to nature is by no means tantamount to the rejection of idealistic and materialistic metaphysics. Just like in the case of Marxism, which claimed to rise above the antithesis between materialism and idealism with the help of neutral world elements, introjection, the principal coordination, economy of thought, it simply means that the only object of scientific investigation is, according to positivism, the scientist's sensory experience, which allegedly does not represent any metaphysical, transcendental reality. The true significance of the empirical theory of verification advanced by neopositivism consisted in that its adherents, despite all their anti-metaphysical declarations, were forced in the end to revert to the traditional, essentially metaphysical, problem of philosophy, that of the basic, ultimate elements of knowledge. Instead of the objective reality, the title absolute was conferred on sensations. According to the positivists, man's activity proceeds not in real space and time, but within the narrow confines of logical formulae binding the sensory experience. Man is incapable of breaking out of the jail built by positivist philosophers. The mystification of the relation of knowledge to reality is characteristic of all idealistic philosophy which regards the world as the materialization of an ideal form, as logic incarnate represented in language. Carnap, like Berkeley, Hume, and any other subjective idealist, puts the true relation of knowledge to objective reality upside down. He starts his analysis not from objective reality, but from the logical structure of the language as it exists today, i.e. the language which has already taken a definite shape and is no longer a living organism. In other words, the accumulated factual material represented in the modern language is the eternal truth, not relative, inaccurate, approximate, but Her Majesty reality personified. To be intelligible, reality must have the same parameters as the logical structure of language. Man cannot go beyond the facts arranged in accordance with the logical structure of language. Such transcendence would call for a truly mystic ability to abandon the sphere of language and intellect. According to Ayer, for instance, the world is a logical structure made up of sensations, which, in his modernist parlance, are called sensuous content. Since the sensuous content is inseparable from the forms in which it is expressed, we are unable to pass beyond the bounds of even our statements of sensations. Ayer does not deny the existence of material objects, yet such existence, in his opinion, cannot be proved with the same certainty as the existence of sensuous images. In the positivist picture of the world, like in a frequently staged play, the action always follows one and the same pattern set by the producer. Subject to change are only the actors, i.e. concrete facts. Not only do the present logical schemes substitute for real relations between objects which are infinitely richer, more complex, and contradictory than their logical counterparts, no less important is the fact that such schemes turn out to be even more speculative than the natural philosophical doctrines of the 18th century, except that they take into account some results of the scientific progress during the past 2 centuries. In other words, the artificial positivist schemes ignore the crucial fact that the logical links and relations are by no means identical with the real ones. Positivism sees its main task in binding together the ultimate elements of scientific knowledge rather than in searching for them. Nevertheless, such elements do have to be defined, if only vaguely. The more resolute the opposition of positivism to objective reality as something that stands behind the elements and is different from them, the more it turns these elements into the absolute source of knowledge. By the ultimate elements of knowledge, logical positivism understands facts. For all the ambiguity of this term, which can denote both the fragments of objective reality and events registered by language, the so-called facts are turned into an absolute similar to Mach's neutral world elements or Berkeley's sensations. The certitude of these original sources of knowledge does not need any further confirmation, it is self-evident. All other structures of knowledge rest on this solid foundation given directly in experience. Wittgenstein selected propositions such as the world is all that has place, the world is an aggregate of facts, but not things, the atom fact is the connection of objects, objects make the substance of the world and therefore cannot be composite, are in fact nothing but vaguely defined ontology not much different from that of Hume or Berkeley, it is the ontology of atom events given in sensations. The only difference consists, perhaps, in that in the ontology of the classics the atoms are connected by association, through the agency of mental links, whereas in logical positivism the connection must be purely logical. Positivism takes for granted Hume's doctrine that the laws of science do not mean anything but habitual concomitance of events and sets itself the task of showing the soundness of this. It has also borrowed the empiricist concept of observation as a simple self-evident act which only calls for distinguishing the observation of objects from the observation of their properties. Observation is not only the initial, but also the final point of cognition, since the only method of the verification of knowledge is also observation. Hence, it would not be correct to regard the positivist doctrine as free from any ontology. Recognizing that observation represents something that exists independent of man and his consciousness, positivism projects outside the result of observation. The positivist philosopher's world appears to be made up of separate, unconnected objects united only by some kind of affinity which, incidentally, is taken for granted and requires no explanation. These logically independent and empirically indifferent facts are joined with one another solely through the relation of similarity, just as distinctions are the only form of their separation. Consequently, each object can change without affecting the properties of other objects or can remain immutable despite the existing alternatives. This, however, is not the premise, but rather the conclusion following from the logical independence of statements of facts. In Ayre's doctrine, all facts are particular or represent conjunctions of separate events, so that any generalization of such facts can only be purely formal. Causality has no other empirical basis than permanent conjunction since, according to Ayre, there can be no obvious links between them. Hence, relations between facts can only be external. Even if one speaks of internal relations, the phrase can only mean a combination of simple elements as component parts of larger objects. Ayre avers that even if the process of identifying an element in the system carries some reference to other elements, there will be no two elements of which it can be said that they are necessarily related, and this is as much as Hume's argument requires. Hence, the obvious paradox consists in that positivism, despite its own declarations about the need to overcome metaphysics and free philosophy from myths and utopias, remains itself metaphysical and even a mythological system, substituting speculative logical schemes both for objective reality and for the real processes of cognition. Advocating a strictly scientific approach to knowledge and demanding the elimination of all a priori propositions from scientific analysis, the positivists proceed from a very definite system of values which were established way back in the ideological battles with scholastic metaphysics. We shall yet have not one opportunity to see that positivism, even in its latest forms, has not been averse to the classical tradition in philosophy and in science in general. On the contrary, it has proved its strong affinity, remote in time but not in spirit, for this tradition, attempting to reconcile Locke's and Hume's views, incompatible in many respects as they are. The inherent metaphysics of positivist philosophy, incapable of critical self-analysis, combines in itself some characteristic features of 18th century natural philosophy and mechanistic materialism, manifesting themselves in the irresistible urge of positivism towards formal simplicity, rigidity, and completeness of scientific knowledge, with the principles of Hume's and Berkeley's subjective idealistic philosophy underlying the positivist absolutization of empirical facts regarded as the only source of self-evident certitude and the true foundation of scientific knowledge. Indeed, beware of metaphysics. The widely advertised neutrality of positivist philosophy is in fact nothing but a philosophical eclecticism leading inevitably to idealism, just as the proclaimed freedom from metaphysics is nothing but a smokescreen for more subtle metaphysics. Lucien Seve has justly observed that positivism is a typical form of the decline of metaphysics which has not yet managed to find its way to scientific materialism. It stands to reason that the inner contradictions of positivism inherent in its basic dogmas, let alone the contradictions between the premises and conclusions, could not but lead positivism from one crisis to another and stimulated its attempts to find a way out with the help of one or another stopgap theory. The philosophy of science was bound in the end to reject the positivist program of struggle against metaphysics and give up attempts to discard all general problems pertaining to being, nature, society and thinking. It is not surprising, therefore, that the tendency towards the revival of metaphysics has at last prevailed in the philosophy of science itself. 2. Metaphysics of Critical Rationalism. By Igor Naletov. One of the radical attempts to solve the problem of the relationship between science and metaphysics on a non-positivist basis has been undertaken by Karl Popper, a prominent English philosopher, who proposed a doctrine of the structure and development of scientific knowledge and gave it the name of critical rationalism. It is noteworthy that the main principles of his doctrine, alternative in a way to logical positivism, were developed by Popper within the walls of its citadel, the Vienna Circle. The ideas of Popper, who had been a member of the circle from its very foundation, foreshadowed, as it were, the inevitable crisis and disintegration of the new school long before it reached the peak of its glory, when nothing seemed to betoken the impending end. From the very beginning, Popper was a severe critic of the new trend in the philosophy of science which was budding within the Vienna Circle among the philosophers and natural scientists interested in the logic and methodology of science. However, Popper was no alien in the circle, though there is an obvious tendency now to leave this fact out of account in considering his relation to logical positivism. Popper's alliance with the new school was by no means accidental, even if we put aside his formal membership of the Vienna Circle. One could evidently speak of a certain difference of opinions concerning the means, yet the aim as such was undoubtedly common. This is true at least of the early period of Popper's activity, when he advocated the restructuring of scientific knowledge on the basis of an empiricist interpretation of its laws and categories, and underscored the need for complete elimination of metaphysics from scientific studies. Hence, not only did he identify himself with the task set by logical positivism in that early period of his research, but he strove wholeheartedly to solve them in a most consistent and effective manner. True, the way which Popper considered to be the most expedient and logically sound fell off the tracks chosen by most of the other adherents of the Vienna Circle. Giving him credit for scientific intuition, one ought to note that he sensed the inherent weakness of the verification theory when it was still in the cradle, and discerned the seeds of contradictions bound to undermine this theory when it was to start revealing its philosophical content, particularly when the principles proclaimed by the Vienna Circle were to be applied to the problems of real scientific cognition. In his polemics with logical positivism, Popper stressed, not without reason, that modern physical theories were too abstract, even speculative, to meet in any degree the criterion of verification. This criterion, according to which the truth of any theoretical statement must be confirmed by direct experience, could not provide reliable guidelines even for a most general appraisal of their scientific value. All attempts to reduce them to experimental data and to show that such statements, if only in the field of classical mechanics, were based on direct observation have proved to be futile. Even the basic laws making the backbone of a theory were too remote from what was called the empirical foundation of science. On the other hand, the treatises devoted to dreams and spiritualistic seances appeared at first sight much closer to everyday experience than theoretical propositions, and even seemed to use something like the induction method, which held undivided sway in empiricist natural science. Popper also noted the fact that many scientific theories had originated from myths. It was yet another proof that there existed no sharp demarcation between science and metaphysics, particularly in terms of the verification theory. According to Popper, Copernicus's heliocentric theory of the universe was inspired by the Neoplatonists' worship of the sun, which they placed in the center of the universe. Ancient atomistics was another example of a myth that played an extremely important role in the development of science. As opposed to logical positivism, which reduced the difference between science and metaphysics to the difference between meaningful and senseless propositions, Popper underscored already in his first mature works that the problem of meaningfulness and senselessness was a pseudo-problem. Metaphysics, according to Popper, was neither a science nor a set of nonsensical assertions. Hence, already in the early period of his ideological evolution, Popper held a different view of metaphysics than the founders of the Vienna School, influenced to a considerable extent by Wittgenstein's and Schlick's ideas. According to the verification version of logical positivism, the criterion of the scientific value of different forms of human knowledge is their confirmability by inductive methods. An assertion can only be regarded scientifically valid if it can be confirmed by inductive methods or an inductive inference. As regards a theoretical proposition, it must permit logical reduction to a protocol statement confirmable by an experiment. The basic distinction of Popper's criterion of scientific knowledge from the verification principle consisted in that he regarded refutability and not confirmability as the main characteristic feature of a scientific statement. Hence, Popper's solution of the problem of demarcation between scientific and non-scientific assertions is the direct logical opposite of the neopositivistic criterion. The immunity, even if only thinkable, of a proposed hypothesis against refutation is a sure sign of its metaphysical nature. A system of assertions can only be considered scientific if it is at least capable of being at variance with observation. From this it follows that the verifiability of a theory coincides not with its confirmability, but with its refutability, and this is just what makes the difference between science and non-science. For instance, the existence of God, according to Popper, is asserted in approximately this form: God is because he is. Since this statement is practically tautological, the degree of its confirmability is very high. Yet it is quite obvious that a statement of this kind is completely immune from refutation and is, therefore, non-scientific. Popper's argument against the verification principle and in favor of his falsification criterion are serious enough, though not at all as original as he claims. Putting aside the author's pretense, let us take a more close look at his arguments against the verification version of anti-metaphysical philosophy. First, Popper contends that observation is always preceded by certain theoretical assumptions and scientific knowledge, contrary to the positivist concept, does not start with sensory experience. Second, the traditional problem of empiricism, that of the substantiation of the inductive conclusion, derives, according to Popper, from Hume's error concerning the nature of the scientific method. In Popper's opinion, Hume indeed showed that a theory cannot be deduced logically from observation statements, yet he overlooked a very important circumstance: his arguments do not prove that a theory cannot be refuted by observation. Therefore, contrary to the expectations of the positivists, empirical generalizations are immaterial for scientific cognition. A scientist is usually not guided by generalist observations, but makes a resolute step and puts forward bold proposals which are subject to subsequent empirical verification. Popper maintains that scientists test new theories not in an attempt to deduce them from a certain imaginary basis, but by creating experimental situations whereby they try to refute or falsify them. One cannot but admit that Popper did pinpoint the vulnerable spot of empiricism. Yet the full significance of his criticism can only be assessed in the light of the program which he proposes as an alternative. It may seem at first sight that his epistemological principles are radically different from those of positivism. Indeed, according to Popper, knowledge cannot start from nothing, from a tabula rasa, nor yet from observation. The advance of knowledge consists, mainly, in the modification of earlier knowledge. Although we may sometimes, for example in archaeology, advance through a chance observation, the significance of the discovery will usually depend upon its power to modify our earlier theories. Refutation in science, according to Popper, is a motive force of progress. A refuted hypothesis gives place to another one intended to eliminate or avoid the error. Some conclusion ensuing from an adopted theory or from a hypothesis may be refuted. This will cause the scientists to improve and transform the theory or the hypothesis. It may also happen that the very premises of a theory will prove to be invalid. In that case, the theory should be resolutely rejected. In any case, a scientist himself must always strive to subject his hypotheses to severe criticism, as it stimulates continuous progress of science. Refute. Calls Popper on scientists. A refutation, in his opinion, is a scientist's victory, since any act of rejection represents the essence of science, elimination of errors and perpetual progress, knowledge. According to Popper, the test of a theory amounts in fact to an attempt to refute it, and refutability is the fundamental property of scientific knowledge, whereas the critical spirit is one of the basic characteristics of scientific life, the ethical imperative, so to speak, of a scientist's behavior. In assessing a hypothesis, a scientist should first of all decide whether it lends itself to a critical examination and, if so, whether it is capable of withstanding a critical charge. Newton's theory, says Popper, predicted a deviation of the Sun's planets from Kepler's orbits owing to their interaction, and thereby exposed itself to a possibility of being refuted by experience. Einstein's theories were tested in a similar manner, as the conclusions they suggested did not follow from Newton's theory. By contrast with the metaphysicians striving for an ever broader generalization and confirmations of their ideas, the scientists do not seek a high degree of probability of their assertions, or, to be more precise, it is not their main aim. The more a statement asserts, the less probable it is, says Popper. For instance, a theory giving exact quantitative predictions in relation to the splitting of lines in the atom emission spectrum under the influence of magnetic fields of different intensity is more vulnerable to experimental refutation than a theory predicting merely the effect of a magnetic field on such emission. In that respect, according to Popper, the more definite and refutable a theory is, the more verifiable it also is, as it lends itself to more accurate and exacting tests. In other words, contrary, for instance, to Carnap, Popper maintains that a high degree of verifiability cannot represent the aim of science. If that were so, the scientists would confine themselves to tautological statements alone. Actually, however, their task consists in developing science, i.e. in enriching its content, and that is bound to lower the probability of its propositions. As we see, Popper presents rather a dramatic picture of the evolution of science, which consists essentially in a continuous struggle of theories and in the survival of the fittest. Unlike Carnap, who regarded the victory of a theory to be in no way damaging to the prestige of its rivals, Popper maintains that the triumph of one hypothesis inevitably spells the doom of all others. With Carnap, scientific theories move in a respectable and civilized society, whereas Popper sees them waging relentless struggle for existence in which the rise of a theory can only be achieved by murdering its opponent. Explaining his understanding of the difference between science and metaphysics, Popper used to say that a believer perishes together with his false convictions, whereas a scientist sacrifices his creation, a theory, for the sake of the progress of science. As regards each individual scientific theory, it begins, according to Popper, with a problem. Then follows a tentative solution, a conjecture, criticism, and correction of errors. The tentative solution may prove partly or even completely erroneous. Yet this does not mean, says Popper, that a scientist is entitled to a deliberate error. To avoid it, he must, first of all, look deeper into the problem and comprehend it. And how can he do this? Popper says, to understand a problem means to understand its difficulties, and to understand its difficulties means to understand why it is not easily soluble, why the more obvious solutions do not work. The step that follows a tentative solution consists in discussing and criticizing the theory. At this stage everybody tries to find faults with it, to refute it or to correct the errors. Popper writes, the critical attitude may be described as the conscious attempt to make our theories, or conjectures, suffer in our stead in the struggle for the survival of the fittest. It gives us a chance to survive the elimination of an inadequate hypothesis when a more dogmatic attitude would eliminate it by eliminating us. This attitude, according to Popper, is true of the animal, pre-scientific and scientific knowledge and, consequently, characterizes the mechanism of its evolution in general. A specific feature of scientific knowledge consists in that the struggle for existence in human society becomes more difficult because of conscious and systematic criticism. In Popper's opinion, one can only speak of any progress in science in connection with the possibility of falsification. Popper's falsification concept is closely linked with his peculiar notions of the genealogical tree of knowledge. If we take a tree in its natural position, i.e. with its crown up, for a model of the evolutionary process, we shall have, according to Popper, the picture of the development of applied sciences, since they are characterized by the ever-increasing diversification and specialization. Yet to visualize the development of pure knowledge, of fundamental sciences, one should set the tree with the crown down, since the leading tendency in the sphere of pure knowledge consists in the growing integration and unification of theories. From the epistemological viewpoint, Popper's concept is different from the traditional empiricist stand only in that it dismisses the question of the source of knowledge, since the logic of a scientific discovery, which is what Popper's epistemology boils down to, does not concern itself with questions of this kind. In point of fact, this question lies on the other side of the demarcation line which Popper draws between science and metaphysics. Yet even within the narrow limits of a purely logical model of the process of cognition, Popper's concept gives rise to serious contradictions. Indeed, in investigating the relation between knowledge in general and a concrete discovery or theory, one must answer at least two questions: which element of knowledge and at which stage of its maturity is taken as the basic proposition, which proposition in a given specific case can be confirmed or refuted with the help of an experiment. The second question remains, in fact, unanswered by Popper. As regards the first one, the answer is as follows: the initial, basic propositions are a product of arbitrary convention among scientists. Popper does not deny the connection of basic propositions with experience. In The Logic of Scientific Discovery he writes that the decision to adopt a basic proposition stands in causal relation to our sense perceptions. Experience, according to Popper, can only go to the extent of motivating a decision which is needed for the adoption or rejection of a proposition. Yet any attempt to trace basic propositions to perceptions would be entirely fruitless. As we see, despite the ostensible opposition to empiricism, Popper's concept reveals a curious similarity to logical positivism in at least two aspects: in its tendency to limit the subject matter of epistemology to purely logical problems and to reject some general problems. Popper, like the leading theorists of the Vienna school, is forced to resort to conventionalism when it comes to explaining the origin of basic propositions, though he substitutes conventionalism from below for the traditional conventionalism from above used by logical positivism in its attempt to account for scientific laws and theories. Popper's conventionalism is a result of his far-reaching logicism, leading to the dismissal of philosophical and sociological problems of science as insoluble. The basic propositions introduced by Popper are intended to replace the protocol statements of the Vienna school and differ from them in that they reflect a system of conventional knowledge rather than the transient individual experience. The rational kernel in Popper's criticism of the verification theory consists in that Popper considers science as an endless chain of theories that replace one another. He effects a radical change in the traditional orientation of the logical analysis of scientific knowledge. Having started with the investigation into the rules of refutation of scientific theories, Popper made the progress of science the pivotal point of his concept. The problem of the criterion of scientificity now organically merges with the concept of the development of science. Crises in science, i.e. the collapse of traditional theories, are declared to be inherent in the main postulates of the logic of scientific development. The new logic of science is a logic of scientific discovery, of the radical transformation of the existing systems of knowledge. Popper has shifted the focus of attention from the formal logical analysis of systems and propositions to the problem of the logical reconstruction of historical events in scientific development. In his person, the logic of science has made a step towards the history of science in the hope of creating a new tradition in the analysis of scientific knowledge. New horizons have been opened up before logic both in terms of theory and heuristics. Popper's logical notions show a clear tendency towards historicism in the presentation of scientific progress. Historical analysis, of course, would have been highly helpful in the solution of such problems as the criterion of scientific theories, the role of philosophical knowledge in the development of science, and many others. But such analysis proved to be beyond Popper's possibilities. Logicism has got the better of his aspirations. Development, a traditional metaphysical problem, has also been treated with reference to scientific knowledge by Thomas S. Kuhn, who gave it even a more pronounced anti-positivist turn. In opposition to Popper, Kuhn put forward a thesis that scientific development cannot be explained by means of rational logical notions in principle. The sharp controversy that was initiated by his book The Structure of Scientific Revolutions, first published in 1972, is still unabated, centering around Kuhn's polemics with Popper's school. This polemics is playing rather an important role in weakening the positions of critical rationalism. A crucial feature of scientific life which, according to Kuhn, was ignored by Popper, consists in the presence of some dogmatic elements in the scientists' work which bolster up their faith in the success of their investigations and help them to persist in their studies without arguing with their colleagues. As distinct from Popper, who underscores the significance of criticism in science, Kuhn emphasizes the function of dogma in scientific investigation. Contrary to Popper, who avers that bold refutations and tough competition of theories pave the way for scientific progress, Kuhn sees the starting point of progress in a transition from debates and competitive theories to a common viewpoint shared by all specialists. According to Kuhn, the true creator of science is the scientific community, a group of professionals who decide to adopt a certain scientific achievement or theory as a model and make it a basis for their investigations. No scientific community can start investigating natural phenomena without a definite system of generally recognized notions. Such a system of notions also includes certain metaphysical propositions or models of the type: heat is kinetic energy of particles making a body, or all perceptible phenomena are essentially interaction of qualitatively homogeneous atoms in free space, etc. Within the scientific community, a model theory is a paradigm, whereas the study of nature within the framework of a paradigm is normal science. If there is a paradigm, the solution of concrete scientific problems resembles the solution of puzzles. The scientist has a model of the solution, the rules to be followed, and knows that the problem is soluble. The conditions being set, his success depends on his personal ingenuity. The secret of scientific achievements lies largely in the self-organization of the scientific community. No other professional group has succeeded to such an extent in fencing itself off from everyday life and layman's questions as the scientific community. To be sure, such isolation can never be complete, yet it is very essential. A scientist always does his individual research with an eye to his colleagues in the first place, whereas a poet or a writer addresses a non-professional audience and depends to a great extent on its appreciation. Just because he is working only for an audience of colleagues, an audience that shares his own values and beliefs, the scientist can take a single set of standards for granted, writes Kuhn. He does not even have to select his problems, they themselves are waiting for him. However, this is only the first stage of the scientific process. The next stage consists in a breakdown of old paradigms, a crisis, and a formation of a new paradigm. It is a period of extraordinary investigations and controversy leading to the development of the new principles of investigation and to the creation of a new picture of the world. The main task of this period is to select a theory that would play the role of a paradigm. This selection, according to Kuhn, is not a logical problem as it appears to logicians. The criterion for the selection lies in a socio-psychological sphere. The scientific community selects for a paradigm the theory which appears to be best suited to ensure the normal functioning of the scientific mechanism. Therefore, each critical period gives way to a new upsurge of creative activity and another step forward in the onward march of natural science. To an individual scientist, however, a change of basic theories is tantamount to conversion to a new faith. He feels like entering a new world with entirely different objects, notions, problems, and tasks. Hence, a scientific revolution consists essentially in a change of paradigms. This change does not yield to rational explanation in terms of logic as it is rooted in the professional feeling of the scientific community. Either the community possesses the necessary means for solving puzzles, or, if such means are not available, the community has to create them. The main turning points in the history of science are associated with the names of Copernicus, Newton, Lavoisier, Einstein. According to Kuhn, each of these turning points signified that a group of professional scientists had to discard one age-old theory in favor of another incompatible with the former. Paradoxical as it may seem, Popper's logical concept of scientific revolutions and of the downfall of famous theories has been constructed on the basis of the same historical material. In this connection, Kuhn justly observed that Popper had no reason for characterizing all scientific activity in the terms applicable to its rare revolutionary periods only. The severity of the test criteria referred to by Popper is only one side of the medal, the other one being the tradition of normal science, the solution of puzzles. Subject to testing is not the basic theory, but the scientist's conjecture, his ingenuity. An erroneous conjecture is a setback for the scientist, but not for his paradigm. Popper's idea of the elimination of errors which accompanies a change of theories is yet another concept which meets Kuhn's resolute opposition. Popper regarded as erroneous Ptolemy's geocentric astronomy, the phlogiston theory, Newton's mechanics. Kuhn refuses to accept this point of view. No error has been committed in the development of these theories, and the notion of error in general is absolutely irrelevant in the assessment of an obsolete scientific theory. In his opinion, the most one can say in such cases is that a theory which had once been correct later became erroneous, or that a scientist made a mistake by adhering to a theory too long. In the final analysis, the basic distinction between Popper's and Kuhn's concepts lies in their different understanding of the nature of science and progress. Popper has repeatedly emphasized the need to cast off psychologism in the solution of such problems. He was never tired of repeating that his concern was the logical rules of scientific progress rather than the scientist's psychological incentives, yet he could not but admit that the rules of logic followed by scientists in their investigations are something like their professional imperatives. In contrast to Popper, Kuhn contends that such imperatives alone can account for a scientist's selection of one solution instead of another, and that his preference cannot be explained on purely logical or experimental grounds. In other words, it is only the analysis of socio-psychological factors in the development of science that provides a key to the correct understanding of the historical aspects of scientific progress. Popper's science is impersonal, whereas Kuhn strives to introduce a human element into the logical problems of scientific cognition and highlights its sociological and psychological aspects. Both concepts, however, are completely divorced from the problem of the interaction between philosophy and particular sciences. Moreover, Kuhn even makes a special point of substantiating this indifference. A question, naturally, arises if such an abstraction in the investigation of the history of science is justifiable and if it is not likely to distort the true picture of scientific progress. A serious attempt to save the logical tradition in the analysis of historical changes in science was made by Popper's disciple Imre Lakatos, a prominent representative of critical rationalism and a talented expounder of his school's principles. Lakatos holds that it is necessary to discard completely the tradition of logical positivism, which focused on formal logical means in the analysis of scientific knowledge. He shares Popper's opinion that the only way in the investigation of the logic of science is to turn to the real practice of scientific thinking. To substantiate this view, he shows that even mathematics, which has long been regarded as the main bastion of the adherents of formal logical analysis, needs the substantive analysis of its history so as to get a basis for the development of the logical and methodological scheme of scientific discovery. Each time the historical process of scientific cognition reveals a need for a change in the existing system of knowledge, there appears a possibility for different strategies and for different ways of development. Being always faced with the necessity of casting lots in selecting one of the alternatives that would prove the most beneficial for further scientific progress, the scientists never stop seeking for a guideline. This guideline, according to Lakatos, must be provided by the modern logic of science. It is precisely for this reason that it should break off with the tradition of formalism. Formal logical analysis deals with deductive, formalist theories which represent science in the artificially frozen state, whereas the real object of logical analysis and explanation should be the methods and mechanisms of changes in the structure of knowledge. Criticism gives scientists a rich situation logic, i.e. opens up a broad range of possible lines of behavior in different situations. Lakatos points out that Popper's solution of the demarcation puzzle and his criterion of scientific knowledge have brought about a radical change in the very formulation of the problem. After Popper, the logical appraisal of a scientific theory turned in fact into the analysis of conditions under which a given theory or hypothesis can be adopted for scientific use. In other words, Popper's new approach to the traditional problems of the logic of science brought to the forefront the question of the acceptability of a scientific theory or a hypothesis. According to Popper, a theory can only be accepted as scientific if it is falsifiable. Lakatos, however, regards this criterion as only one of the requirements a theory must meet in order to become acceptable. Kuhn's controversy with Popper about scientific revolutions raised the crucial question of the possibility of representing the endless change of fundamental scientific theories as a rational process interpretable in terms of logic. As for Lakatos, his main object was to give a logical explanation of the victory of a new paradigm. He is firmly convinced that logic is capable of giving the scientist a rational guideline for his behavior during a critical period in the development of science. Proceeding from this aim, Lakatos develops his concept known as the methodology of research programs. Lakatos sides with Kuhn in his criticism of Popper's rule, having falsified reject. According to Lakatos, the comparison of a theory with the results of an experiment is a more complex procedure than Popper originally thought it to be. This comparison involves, as it were, three layers of knowledge: the theory under test itself, the sensory data explained by the theory, the so-called background knowledge embodied, for instance, in the instrument design. We cannot know what the experiment demonstrates and how it can pass a final judgment on the theory under test. Rather, says Lakatos, we subject to testing a tangle of our theories and the experiment's verdict is, incompatible. Which of the theories must be rejected is still a big question. Generally speaking, there are no absolutely indisputable facts which would compel an ardent adherent of a theory to surrender immediately and unconditionally. On these grounds Lakatos comes to the conclusion that a theory cannot be invalidated by a single empirical counterexample. Its rejection can only come about in the process of adoption of a new, better theory. Broadly speaking, it means that the true object of a logical evaluation is a series of theories in their succession rather than an individual theory. Several series cluster around propositions playing the role of something like a dogma here. According to Lakatos, Kuhn was right. It can therefore be affirmed with good reason that the scientists in their investigations of nature translate into reality some more or less developed programs. Lakatos understands science as activity aimed at solving concrete problems within the framework of a certain program. Each program can be viewed as consisting of two components, a rigid core and a safety zone of sacrificial theories. The rigid core consists of one or several propositions which are not subject to refutation. Such are, for instance, the three laws of thermodynamics and the law of gravitation for the adherents of Newton's theory. These propositions must be preserved under any onslaught of falsifying data. The salvation of the core is achieved at the expense of auxiliary hypotheses which replace one another and are intended to neutralize counterexamples and preserve the core with the help of various amendments and modifications. By way of illustration, Lakatos refers to Newton's gradual elaboration of his theoretical models. Having first worked out his program for a planetary system with a fixed point like the Sun and one single point like planet, Newton derived his inverse square law for Kepler's ellipse. But this model was forbidden by Newton's own third law of dynamics, therefore the model had to be replaced by one in which both the Sun and the planet revolved round their common center of gravity. Later he introduced more planets as if there were only heliocentric but no interplanetary forces. However, the results obtained at this stage ran counter to observations, and later Newton worked out the case where the Sun and planets were not mass points but mass balls and also introduced interplanetary forces. Such multistage elaboration, according to Lakatos, reveals the true course of the scientist's thought. The history of science, according to Lakatos, is the history of the birth, life, and death of research programs. While a program is being realized, science runs its normal course. It is Kuhn's normal science. During a change of programs, or a change of paradigms, science undergoes a revolution. As distinct from Kuhn, however, Lakatos believes that programs are logically commensurable and can be compared to one another. Their comparative analysis can provide a scientist with a reasonably reliable guideline for selecting one program and rejecting another. According to Lakatos, any theoretical concept of knowledge provides a framework for the rational restructuring of the history of scientific knowledge. Though not every detail in the history of science fits in with rational explanation, logico-methodological concepts should provide the closest possible approximation to real processes in order to permit their description. For instance, an inductivist who considers Newton's theory an error, and its lasting prevalence a delusion would find no rational justification for it. Popper's type of logic would provide a rational explanation for a scientist's failure to recognize the collapse of his theory by referring to his metaphysical views. In Lakatos' opinion, preference should be given to a concept which permits the rational restructuring and interpretation of the largest possible number of facts in the history of science. Proceeding from this criterion, Lakatos considers his concepts to be the most expedient. However that may be, his ultimate conclusion is this: it is the history of science which is the touchstone of any logico-methodological concept, its strict and uncompromising judge. The controversy between the critical rationalists and the adherents of Kuhn's concept of the history of science had greatly affected the assessment of the very possibility of constructing a purely logical concept of scientific knowledge and its development. The most skeptical views in relation to this problem were expressed by Paul Feyerabend. In one of his works, after expounding the basic principles of Popper's logic of scientific investigation, Feyerabend puts two questions which he considers to be of prime importance: whether it is desirable to live up to the rules of critical rationalism and whether science can be brought in accord with these rules. Feyerabend gives negative answers to both questions. According to Feyerabend, the highly specialized thinking characteristic of modern civilization is accountable for a corresponding narrow approach to the study of man's cognitive activity and for a tendency to rationalize the process of cognition by simplifying its participants, strictly delimiting the field under investigation and by abstracting from historical context. Feyerabend contends that such abstraction from the external factors of scientific development becomes fatal for philosophy, since human inclinations, interests, and ideological influences have a greater effect on the progress of knowledge than is generally believed. Despite his general opposition to Kuhn's understanding of the nature of scientific activity, Feyerabend, as he himself admitted, had wholeheartedly accepted his thesis of the incommensurability of basic scientific theories that succeed one another in history. Incommensurability was the point on which the views of both authors completely coincided when they were discussing the basic ideas of Kuhn's book. Kuhn was fond of comparing the world as it appeared to Aristotle with the world depicted by the 17th century science. Having taken the cue, Feyerabend carries out a detailed comparative analysis of classical celestial mechanics and the special theory of relativity and strives to show that even the concepts of length, mass, and speed in these theories were entirely different. According to both Kuhn and Feyerabend, the meaning of observation terms is completely determined by the theoretical context in which they are used. From this it follows that theories replacing one another are mutually incompatible and even incommensurable. They belong to different worlds. The field of application of a new theory is not necessarily the extended field of application of the previous theory, these fields may only overlap each other. The view according to which a new theory is bound to be commensurable with the previous one cannot be accepted as a universal principle. Incommensurability may be eliminated in one aspect, but holds good or even becomes more complete in another. The thesis of the incommensurability of theories succeeding one another is so important for Feyerabend that he considers it imperative for the logical analysis of scientific theories to start with revealing and emphasizing the qualitative distinction of the new theory over the old one. A new theory must not only explain new facts, but also show the causes of the failure of the old theory. It is only on this condition that a new theory can be admitted to the temple of science. According to Feyerabend, a scientific theory can only be identified by its novelty and complete break from its predecessor. This criterion should also be applied to epistemology and to the logic of science. Feyerabend contends that the history of science testifies to the absence of any norms and standards of scientific activity valid for all times. Proceeding from his own understanding of Hegelian dialectics, Feyerabend maintains that any phenomenon can only be investigated in terms of the dialectics of the subjective and the objective, chance and necessity. Any absolutization of norms and rules tends to bar the way to cognition. The true task of philosophy is to neutralize the baneful trends towards the stability and rigidity of methodological norms. Philosophy should embody the whole gamut of man's creative potentialities, all his individual qualities. To achieve this end, however, it must do away with the stability of all norms of scientific knowledge. Consequently, the logic of science should renounce the very idea of standards which hold good throughout history. Such standards can at best be treated as a verbal ornament or, more accurately, as a remembrance of those happy days when it was believed possible to gain success in science just by observing a few simple and rational rules, and when scientific investigation was not yet known to be a risky and hazardous venture that it is, with endless upheavals and cataclysms. Feyerabend's methodology calls for rejection of the theoretical monism characteristic of positivist and some other philosophical doctrines. The plurality of theories, in his opinion, must not be regarded as a preliminary stage of knowledge which will be replaced later by a single true theory. Theoretical pluralism is assumed to be an essential feature of all knowledge that claims to be objective, writes Feyerabend. Nor can one rest content with a plurality that is merely abstract and created by arbitrarily denying now this and now that component of the dominant point of view, as is the plurality created by the various attempts of modern artists to free themselves from the conventions of their predecessors. In its methodological orientation, the theory of science should proceed from the idea of epistemological anarchism. The development of science, according to Feyerabend, is a process of the continuous combination of standards and their violations, dogmas and heresies, norms and errors. Kuhn's normal science does exist, but it has to be opposed in every way as it reflects the ideology of professional specialist. Kuhn's concept of paradigm is deficient in that it consoles the specialists instead of subjecting their views to criticism. Feyerabend's motto is an uninterrupted revolution. Proceeding from his own interpretation of Hegel's words about human practice, man's spiritual and practical activity, Feyerabend avers that it excludes any regularities. A theory of science should only provide some general hints, rules of thumb and heuristic methods, but not general injunctions. Knowledge is an ever-increasing ocean of mutually incompatible alternatives. Nor is philosophy itself amenable to rational analysis in view of the disorderliness, complexity, and wholeness of its structure. Feyerabend proposes a broad program of struggle to attain the ideal of anarchic epistemology and overcome the ideas of critical rationalism which seeks to alienate science and enslave human spirit. He points out three means to achieve this goal: scrupulous analysis of the works of such revolutionaries as Galilei, Newton, Luther, Marx, and Lenin, study of Hegel's philosophy and its alternative as expounded by Kierkegaard, integration of science and art. According to Feyerabend, their present separation is not natural and results from the idea of professionalism which must be discarded. A poem or a play can be intellectual and informative in equal degree, whereas scientific theories are capable of giving pleasure. In Feyerabend's opinion, we can change science and make it conform to our tastes. Being indeed anarchical and wide open to all winds of theoretical thought, this model of scientific knowledge nevertheless leaves enough room for metaphysical ideas. Moreover, their function, as defined by Feyerabend, makes them a decisive factor both in the criticism and in the development of what is generally believed and highly confirmed. Hence, they must be present at any stage of the development of scientific knowledge. Feyerabend contends that a science free from all metaphysics is on the way of becoming a dogmatic metaphysical system. Metaphysics performs the role of an instrument of criticism of existing theories, on the one hand, and, just because of the possibility of such criticism, is an argument in favor of these theories. The postulate of Feyerabend's philosophy affirming the absence of any certainty, stability, and system in methodology assumes itself the character of a dogma. Its absolutization results in the restoration of a new variety of metaphysics which is anything but refined. Joseph Agassiz also shares the view that the claim of logic to the role of the theory of scientific knowledge can hardly be considered justifiable. As for himself, he is inspired by the idea of reproducing the real history of science with all its wealth of conflicting tendencies, and the methodology of science has no special appeal for him. The keynote of his works is the futility of preconceived viewpoints and the need for a scrupulous and unbiased reproduction of the entire history of science with all its real conflicting tendencies. In Agassiz's opinion, one ought to start with asking himself a question: what do we know about science in general and about its history? The existing historiography is too raw to provide a basis even for a most abstract theoretical discussion of the criterion of scientificity and the logical principles of cognition. Agassiz contends that a broad program of historiographic investigations of science should be based on Popper's situation logic, which makes it possible to reveal the historical context of various scientific theories or hypotheses. He warns, however, that such investigations should not be influenced by any preconceived idea of science, since the present-day task consists in disclosing and singling out concrete genetic links between scientific theories rather than in their reduction to some ideal type or logical model. Agassiz holds that the core of science reveals itself in the scientist's metaphysical, i.e. philosophical, views, which should therefore be given priority attention in historiographic studies. He shows that philosophical ideas tend to degrade to current opinions if their authors are shy of exposing them to criticism. Those and only those scientists can develop new fruitful theories who are willing to subject their philosophical principles to a serious examination. According to Agassiz, the priority objective of a historian of science is to disclose the nature of the metaphysical nucleus of scientific theories and doctrines. He therefore contends that there should be a radical change in the very orientation of the logical analysis of knowledge which, in his opinion, should be focused on historiographic investigations. The history of science should be written anew, since the existing historiography of science is unsatisfactory. It is evidently for the accomplishment of this task that Agassiz sets out to revive metaphysics. Significantly, Popper, Feyerabend, Lakatos and some other representatives of the modern philosophy of science follow different paths and are interested in different aspects of scientific cognition. Yet they have one point in common: all of them stand for the rehabilitation of metaphysics, which has been held in contempt by positivism for many years. Of course, the difference in their approach to the process of cognition and their different aims cannot but tell on their concepts of metaphysics, their understanding of its role in scientific cognition and their attitude to traditional philosophical problems. For instance, unlike Popper, who does not go beyond the formal justification of metaphysics, and unlike Lakatos, who confines himself to asserting the irreducibility of theory to the empirical basis, Agassiz's doctrine tends to endow metaphysics with certain substance. Accepting in principle the view that metaphysical proposition can be identified by its empirical unfalsifiability, Agassiz nevertheless brings his metaphysics closer to the traditional philosophical problems. It is indicative that his assessment of the scientificity of one or another theory depends to a certain extent on its relation to metaphysics. Thus the selection of scientific problems which are to be studied should be governed, according to Agassiz, not by the degree or their verifiability or falsifiability, but by their importance for arising metaphysical problems. Metaphysics is regarded by Agassiz as a coordinating factor in the development of science, since the criterion of the importance of a scientific problem is its metaphysical significance. It is noteworthy that Agassiz's understanding of the concrete historical conditions affecting the development of science appears to be more profound than that of Popper, as he takes into account, or, at least, shows interest in the factors determining the selection of problems to be tackled and the change of scientific interests. An important role, in his opinion, belongs not only to the techniques and equipment used in experiments, but also to the general socio-economic situation, to society's needs, etc. For all that, his doctrine assigns the role of the main factor to none other than metaphysics. Some scientific problems, he writes, are relevant to metaphysics, and as a rule it is the class of scientific problems that exhibit this relevance which is chosen to be studied. In his analysis, Agassiz deals not so much with a single theory as with a totality of theories, problems, and methods of investigation characteristic of a given period and viewed by him as a single whole. It enables him to make comparisons and deduce general principles governing scientific progress in different fields, e.g. in physics, biology, social sciences in a given period. In Agassiz's interpretation, metaphysics is no longer a specialized theory divorced from science. Hence, the focus of attention should be shifted from the problem of demarcation between science and non-science to that of demarcation between science, on the one hand, and metaphysics, on the other. This leads to a corresponding modification of the criterion of such demarcation. The aim of scientific investigation, according to Agassiz and contrary to Popper, is not to find and verify plausible hypotheses, but to search for and to test those hypotheses which appear to be relevant to metaphysics. Reasoning in a purely metaphysical manner, Popper regards the transition from observations to a good theory not as a result of some inductive conclusion, but as a tentative solution subject to testing, as an advancement of any new theory. The criterion of a theory which is to be given priority in testing should be, according to Popper, its falsifiability. Contrary to Popper, Agassiz contends that the choice among rival theories should be made on an heuristic basis and governed by metaphysical considerations. He also contends that metaphysics itself takes part in the development of theories considered important in given problem situations. Scientific physics, he writes, belongs to the rational debate concerning metaphysical ideas. Some of the greatest single experiments in the history of modern physics are experiments related to metaphysics. I suggest that their relevance to metaphysics contributes to their uncontested high status. And yet, I contend, the metaphysical theories related to these experiments were not parts of science. Metaphysics for Agassiz is not something homogeneous. As has been indicated above, it can be bad or good. The former merges with pseudoscience, the latter, with science. Bad metaphysics, such as existentialism or Hegel's philosophy, is not capable of exerting serious influence on the development of science. Good metaphysics, on the contrary, not only provides something like a methodological program for science in point of fact, it blends with science and can hardly be distinguished from it. Agassiz regards metaphysics as a program for future scientific development and stresses that it cannot be characterized as true or false. It can be either commendable or condemnable. Here Agassiz practically follows in Popper's footsteps, adopting the main principles of his doctrine. Metaphysical theories themselves may engender an attractive program such as that of Faraday, but the attractiveness or unattractiveness of a program is not directly connected with the truth or falsity of the metaphysical theory that produced it. According to Agassiz, the significance of a program is only determined by the heuristic value of this theory. At this point, however, we arrive at a contradiction. If the criterion of demarcation between science and metaphysics holds good, the truth or falsity of metaphysical theories will not depend on their refutability, or else there must exist a method for establishing the truth or falsity of theories without resorting to their falsification. In his concept, Agassiz strives to fence off bad metaphysics which claims to be on an equal footing with empirical science. He says, metaphysics may be viewed as a research program, and the false claims of pseudoscience as the result of confusing a program with the finished product. Yet he fails to draw a distinct demarcation line between true science and the pseudoscientific style of thinking characteristic of old natural philosophy. Unlike Lakatos, who either merges metaphysics with special sciences and practically makes it their integral part, or altogether eliminates metaphysics from scientific investigations, regarding it as some obscure source of inspiration for the scientist, some purely subjective factor akin to his personal inclinations, aesthetic tastes, or peculiarities of biography, Agassiz strives to resolve the contradiction by turning this subjective factor into something immanent in the very substance of science. A scientific theory in his doctrine appears as some kind of interpretation of a metaphysical concept, but not as its logical consequence. It should be rioted, however, that this part of Agassiz's program of reviving metaphysics is patently beneath any criticism. What with metaphysical theories being neither true, nor false, there remains at best but one way out, to assume that there are no practical means, or even no possibility in general to come to a definite conclusion as regards their status. In that case, however, one has to give up all attempts at distinguishing between metaphysics and science and to leave the reader in the dark regarding the ways whereby metaphysics becomes immanent in scientific theories undergoing strict verification procedures. It proves impossible to reconcile the understanding of philosophy as an external factor determining the development of science with its role of an internal factor determining its content. The sphere of metaphysics, too, though including some traditional philosophical problems, appears to be both too narrow and too vaguely defined for all Agassiz's pretensions to having developed a highly efficient working model, something like a matrix for production of new theories. All that a scientist now needs, according to Agassiz, is but a few comparatively simple parameters having a purely technical meaning. In Agassiz's doctrine, metaphysical propositions have no basic distinctions from empirical generalizations. On the other hand, they must meet the rigid rules of formal logic. This kind of approach, which appears more or less compatible with Lakato's concept, does not tally with Agassiz's historiographic orientation and runs counter to his intention of giving a sufficiently accurate, adequate, and broad representation of the historical process of scientific cognition. The history of critical rationalism shows that Popper's initial call to turn to the analysis of the development of science has proved, as it were, a Trojan horse for critical rationalism. Having taken his cue from Popper, Feyerabend comes to doubt the very possibility of maintaining a logical, normative stand in the analysis of scientific knowledge. The criterion and the norms of scientificity advanced by critical rationalism prove untenable when applied to the real practice of scientific thinking, to the study of the history of science. As a result, Agassiz puts forward a new program of the investigation of science focusing not on the logic, but on the history of its development. Would it be correct, then, to draw the conclusion that the history of science indeed attests to the fallacy of the existing logical concepts of scientific knowledge and its development? It would rather be more correct to say, paraphrasing Lakatos, that life itself has compared the logical and historical pictures of science and showed that these pictures are incompatible. Hence, the conclusion of the critical rationalists about the necessity of radical changes both in the history and logic of science appears to be quite sound. Critical rationalism is undoubtedly one-sided in all its variants of scientific development, as it does not strive to present science as an integral part of the life of society. Yet this school has succeeded in showing one important thing, namely, that the progress of science is not a simple accumulation of knowledge or a gradual increase of its certainty, but a complex contradictory process. The positivist logic of science was only capable of reflecting the norms and standards of a certain synchronous level of science. Critical rationalism has made an attempt to construct a logic of scientific development, i.e. a logic capable of reflecting diachronous transformations. This attempt, however, has called in question the very idea of such a logic. Indeed, the history of critical rationalism has vividly demonstrated that the traditional logical approach with its orientation on the natural laws of rational thinking suffers a complete fiasco whenever it is applied to the problems of growth and development of knowledge. The critical rationalists cannot accept this fact, as all of them, even such a radical as Feyerabend, have committed themselves to the logical tradition. Nevertheless, the tendency to tone down the rigors of the positivist attitude to metaphysics and to link philosophico-methodological analysis with the 20th century theoretical investigations clearly revealed itself already in Popper's early fundamental works. This tendency became even more manifest in his subsequent studies and particularly in the investigations of other critical rationalists. Popper's concept of science as a chain of successive theories replacing one another accounts to some extent for an important change in the traditional positivist orientation of logical analysis. Starting out with the doctrine of falsification, Popper has come to the problems of the development of science and reassessed the criterion of scientificity in terms of historical progress. Crises in science, i.e. the periods of the collapse of its traditional theories, are not only explained by his logic, but ensue from its main postulates. A theory which is found to be fully confirmable turns, according to Popper, into technology, know-how, or something of the kind, and has no more room in the temple of science. Popper's logic of science is the logic of scientific discovery, the logic of a radical transformation of the existing system of knowledge. His emphasis on the history of science is an important point of his program of logical analysis, marking a considerable deviation from the positivist traditions, if only for the fact that he focused his attention not on the formal logical analysis of systems of statements, but on the problem of the logical representation of scientific development. To be sure, his emphasis on the relative independence of theoretical knowledge afforded greater freedom for creative thinking and allowed for a possibility of generic links between scientific theories and metaphysics. Nevertheless, despite the deductive character of the logical structure of knowledge, Popper's concept, as has already been pointed out, did not go beyond the limits of empiricism, since it proceeded from the direct dependence of a theory on its empirical verification, post factum though it was. This dependence on empirical data was perhaps even more rigid than allowed by the verification version. On these grounds, early Popper's concept should be regarded on the whole as essentially logico-positivistic. Its assessment by critical realism, focusing on the formal structure of Popper's logico-methodological system rather than on its philosophical orientation, need not be taken into account too seriously. Popper's attitude to metaphysics, i.e. to general ontological problems, as well as his definition of the falsification principle have been gradually changing. His later works present a modified falsification variant watered down in accordance with his growing interest in metaphysical problems and in the question of autonomy of the so-called World 3. To be sure, from the very beginning Popper's philosophical system as a whole did not fit the Procrustean bed of the falsification principle devised by him to eliminate metaphysics and looked, from the viewpoint of this principle, quite metaphysical even in its initial explication. Yet late Popper's blunt turn to metaphysics was evidently somewhat unexpected and amusing even for his most ardent adherents, despite the obvious trend towards such a development traceable already in his early publications. Popper's new stand was clearly expressed in his works Objective Knowledge and the Self and Its Brain, in which he set out to construct a cosmic methodological system, though already in the 1950s and 1960s Popper had criticized the physicalist and behaviorist theories of consciousness, questioning at the same time the fruitfulness of the linguistic approach to the problems of matter, spirit, the brain, and psychological phenomena. Popper's recognition of refutability as a characteristic feature of scientific knowledge and his assessment of metaphysics as a historically inevitable, though mythological stage of scientific cognition were in themselves important steps towards his own metaphysics. No less important was his idea that the mysterious process of scientific cognition manifests itself in the strife of hypotheses and theories, i.e. in the sphere of rational thinking, but not in the depths of the scientist's individual consciousness. This concept was also instrumental in paving the way for metaphysics and contributed to the materialization of consciousness. All these fragmentary notions developed later into an evolutionary concept of consciousness and knowledge, into a metaphysical system of three worlds which shall be considered in more detail in the next chapter. Popper's main epistemological or logico-methodological doctrine denies the validity of any final explanations or final truths. Yet Popper abandons his principles when it comes to the primary source of objective knowledge. Rejecting Plato's metaphysics of ideas, he evolves his own metaphysics, which resembles to some extent 18th-century natural philosophy and is supplemented by notions borrowed from evolutionism and genetics. Popper maintains that active human consciousness capable of influencing the environment through the mediation of culture had its forerunner the biological evolution of organisms. The aims and preferences of the organism influence the environment, which, in turn, affects the evolution of the organism. According to Popper, this emergent process is not only analogous to the consciousness and vital activity of the organism, but also provides a key to the understanding of the origin of science. Already in his Objective Knowledge, Popper makes an attempt to reveal the embryo of science in its incipiency in the vegetable and animal kingdoms. I assert, he writes, that every animal is born with expectations or anticipations which could be framed as hypotheses, a kind of hypothetical knowledge. This, according to Popper, is the secret of the phylogenesis of scientific knowledge, which provides a clue to its ontogenesis. In his opinion, this inborn knowledge, these inborn expectations will create our first problems, and the ensuing growth of our knowledge may therefore be described as consisting throughout of corrections and modifications of previous knowledge. Hence, there is no and cannot be any exoteric history of science. Its history is the logic of scientific discoveries, which is nothing but a chain of successive problems or theories. The genetic structure of man also contains in incipiency the faculty of speech, which plays an important part in natural selection and, according to Popper, participates in some obscure way in the social process of language study. Thus Popper comes to the problem of the relationship between consciousness and the brain, spirit, and matter, not only from the logical, but also from the historical viewpoint. However, handicapped by his earlier commitments, Popper in fact disregards the historical aspect in the development of consciousness and ignores the real, social context of its formation and progress. The emergence of language, according to Popper, leads to the formation of the cortex and, consequently, to the development of consciousness. Popper's biological approach to the problem of the origin and development of knowledge, prompted by his studies of modern evolutionary biology and genetics, must have become yet another stepping stone towards his concept of emergent realism. In recent years this concept has been contrasted not only to positivism with its physicalist and behaviorist tendencies in the approach to the problems of the nature of consciousness, history, etc., but also to the ideas of the so-called scientific realism and scientific materialism. Investigating the origin of objective knowledge, Popper has been engaged of late in a controversy against idealism, phenomenalism, positivism, materialism, and behaviorism simultaneously, or, using his own words, against all forms of anti-pluralism. Explaining the reason for his critical attitude towards reductionism, Popper describes life as an inherent property of all physical bodies. He declares, if the situation is such that, on the one hand, living organisms may originate by a natural process from non-living systems, and that, on the other hand, there is no complete theoretical understanding of life possible in physical terms, then we might speak of life as an emergent property of physical bodies, of matter. Coming out against positivist reductionism, Popper specially emphasizes the uselessness of purely linguistic solutions whereby the behavior of an individual once explained in terms of postulated psychical states is translated into the language of physiological states, or an account of a physiological state is reduced by linguistic means to the Schrödinger equation. Particularly characteristic in this respect is Popper's reappraisal of the problems which he recently qualified as metaphysical. We must beware, he writes, of solving, or dissolving, factual problems linguistically, that is, by the all too simple method of refusing to talk about them. On the contrary, we must be pluralists, at least to start with. We should first emphasize the difficulties, even if they look insoluble, as the body-mind problem may look to some. According to Popper, the hopes that the objective meaning of a theory can be reduced to the states of consciousness of those who propound it rest on a trivial error failure to distinguish between the two meanings of the word thinking. In the subjective sense, thinking describes perceptions or the processes of consciousness, but different perceptions or acts of individual consciousness cannot be logically related even if they are causally connected to one another. Another problem which has come of late to be interpreted by Popper in terms of emergent realism is the relationship between the self and its brain. Popper agrees with scientific materialism in that all spiritual activities of the individual are accompanied by certain brain processes. Yet his concept of the self is entirely different from that of scientific materialism, as he regards it essentially as a self-contained entity identical with what was earlier called soul and what actually constitutes man's true essence less the religious envelope. Popper ranks himself among the interactionists who disagree with the materialists in the understanding of the relationship between the consciousness and the brain and regard the problem basically in terms of the interaction between two levels of reality, the psychic and the physical. Moreover, they assign the active role in this system not to the physical world, i.e. the brain as a material object, but to what they consider to be the self. Popper even goes so far as to assume that the self is a quasi-substantial entity if substance is understood as a process or as activity in general. Traditional materialism, according to Popper, usually linked man to machine. Modern materialism identifies him with computer, whereas the self is in fact the ghost in the machine and at the same time the active programmer of the thinking activity. The self is the embodiment of wishes, plans, hopes, the determination to act and the acute awareness of its being the acting center. The self is the motive force of activity. What makes the self is different from the chemical and biological processes attending the act of thinking and other kinds of activity by one unique quality: the integration and coherence of experience. Expounding his views, Popper writes, "What characterizes the self is that all our experiences are closely related and integrated, not only with past experiences but also with our changing programs for action, our expectations, and our theories with our models of the physical and the cultural environment, past, present, and future, including the problems which they raise for our evaluations, and for our programs for action. But all these belong, at least in part, to World 3. The important conclusion that Popper makes reflects the socio-ethical and ideological thrust of his concept. The emergence of the self signifies the transition of nature to a socio-cultural level of development and the transformation of the laws of evolution and natural selection in accordance with the new environment. The main function of mind and of world 3, writes Popper, is that they make possible the application of the method of trial and the elimination of error without the violent elimination of ourselves. Thus in bringing about the emergence of mind, and world 3, natural selection transcends itself and its originally violent character. Nonviolent cultural evolution is not just a utopian dream, it is, rather, a possible result of the emergence of mind through natural selection. Hence, Popper's scheme of cognition, his understanding of its sources and trends is falling under the increasing influence of the concept of natural selection and biological inheritance. It stands to reason that this concept can in no way be subjected to empirical verification. Being a simple extrapolation of biological laws to the sphere of scientific cognition, it is postulated as premise which does not have to be proved and is in fact rooted in Popper's interest in biology. The notions of evolutionary biology are introduced into the system of epistemological categories by analogy rather than on the basis of a serious investigation into the nature of cognitive processes. Biological laws are declared to be universal, governing the development of the world in general and the process of cognition in particular. Popper's former logicism gives way here to a biologist concept of scientific development which seems to contain more of a substance than a purely formal logical theory. Yet this ostensibly more profound concept is essentially metaphysical, and that in the worst sense of the word, because of its undisguised a priorism, subjectivism and speculative nature. Rejecting the principle of the universality of physico-mathematical knowledge which underlies the concept of logical positivism, Popper comes in the end, as a result of his own evolution, to the ontologization of biological knowledge, substituting biological laws and notions for general philosophical principles and traditional philosophical problems. Using the falsification theory as a foundation, and the notions of special sciences, mainly biology, as building blocks, Popper erects his own metaphysical building that has no room for categories and problems with long-standing historical tradition behind them. Even if he speaks of the active essence of consciousness materializing in culture, i.e. in the universal, and strives to find some culturological approach to the solution of different problems, this approach is limited to the self-programmed wholeness of World 3. As to social reality, it is reduced by Popper to an indefinite combination of physical reality and World 3. All in all, Popper's doctrine, with all its weaknesses inherent in any metaphysical system and often justly criticized by both positivists and scientific realists, and handicapped by its speculativeness, a priorism, empirical contestability and dogmatism, proves rather a meager replica of more profound systems. It offers but very schematic, embryonic versions of new metaphysics which is far behind 18th-century materialistic natural philosophy and Hegel's idealistic metaphysics in terms of profoundness, informativeness, and wealth of concrete material. It is not improbable that the further evolution of critical realism and the views of its inspirer, who has evidently embarked on the final stage of his scientific career, will somewhat enrich and elaborate the schematic solutions proposed so far. Yet the very return of positivism to metaphysics, and a crude one at that, which aggravates the old weaknesses of natural philosophy by new idealistic fallacies, proves better than anything else that this philosophical trend has outlived itself and is now, very much in the manner of a scorpion, stinging itself to death with its own venom. 3. Scientific Realism. Metaphysics and Ontology. By Igor Naletov. The internal contradictions of positivism and the growing rift between its concepts and the real scientific development were bound to lead to a profound crisis which will evidently mark the end of the school as an independent philosophical trend, though its traditions and certain achievements in the logic and methodology of science have been adopted by many schools of the modern philosophy of science. Equally inevitable was a more radical, compared with critical realism, revision of the notorious positivist demand for elimination of metaphysics, i.e. concepts, theories, and problems that failed to meet the rigid empirical criterion of verification or falsification. Not only did this demand run counter to the very essence of positivism, which has always rested on certain non-empirical postulates. It was also untenable from the viewpoint of the laws, problems, and tendencies of scientific cognition, as it tended to restrict the scientist's outlook to the mole's horizons and kill the very spirit of creative scientific endeavor. The philosophical platform of positivism, despite the periodic revivals of interest in its evolution, was bound sooner or later to arouse dissatisfaction among scientists, as it deprived them of the stimulating effect of theoretical and philosophical knowledge and shut them off from the wealth of human culture. Discontent with the isolationist concept alienating science from humanitarian and social values was also to be expected, and had in fact been predicted, e.g. by the Marxist philosophers, among the intellectuals, particularly in the humanitarian circles. Natural, too, was the antipathy to positivism on the part of various philosophical schools and trends which could never stomach some or all of its tenets. The storm which had long been gathering over positivism was precipitated by the scientific and technological revolution, with its imperative demand for immediate solutions to a number of fundamental problems of scientific, technical, and cultural progress, and the decrepit vessel of the philosophy of science was swept over by a powerful wave of general discontent. The critical fervor of different schools has been centering largely around the demand to revive metaphysics. Naturally enough, such a revival, as well as the content of metaphysics itself, are receiving widely varying interpretations ensuing from no less widely varying intentions. Idealism, for one, resentful over the hesitating position of positivism between the objective knowledge of the physical world and subjective perceptions, is insistent on the unequivocal recognition of the primacy of the mind and consciousness. The scientific community, long deprived by positivism of solid grounds in theoretical investigations, is demanding of the realists a reliable ontology, a materialistic one at that. The scientists whose interests mainly lie in the sphere of empirical investigations are expressing their grave concern over the theoretical vacuum, partly traceable to the anthropogenic influence of positivism. All these trends are unanimous in their demand to concentrate on the solution of fundamental philosophical problems, and are keenly aware of the inability of traditional philosophy to meet the challenge of natural sciences. It stands to reason that the concept of constructive revivified metaphysics, advanced by such heterogeneous opposition to positivism with its wide diversity of interests and views on the subject matter of philosophy, cannot but be very vague, or at least extremely polysemantic. Problems regarded as metaphysical include general scientific and metatheoretical doctrines, the so-called ontology or the general doctrine of being rejected by positivism, as well as the traditional eternal philosophical problems of value, ethical norms, etc. Such an approach will be quite understandable if we take into account the fact that the attempts to revive metaphysics are based on the specific material of the history of science, history of philosophy, ethics, psychology, linguistics, etc. In his afterword to a collection of articles entitled The Future of Metaphysics, one of its exponents, Richard McKeon, writes, "The future of metaphysics is determined by the controversies of philosophers as well as by the ontology of things or the epistemology of thoughts, and its course is often marked more clearly by suggestive paradoxes than by indubitable certainties. We need not characterize all the trends of metaphysics, the more so as some of them, continuing the line of idealism and religious philosophy, have always fed on such problems, and the crisis of positivism has simply added fuel to their fire. Far more important to us is the variety of new metaphysics, known as scientific realism, which springs up on the ruins of positivist philosophy and pretends to the role of its alternative in the methodology of science. The name scientific realism, which is currently used alongside other names, such as scientific materialism, new ontology, critical realism and others, is purely conventional, since this school has not yet offered its solutions to the problems of scientific progress, nor defined its objectives or methods of analysis. The name represents what may be termed the nucleus of the program, the criticism of positivist views on the structure, foundation, and future development of scientific knowledge. It is noteworthy, however, that the so-called materialism of the new school proves in some respects to be but a new version of reductionism, whereas its criticism is sometimes markedly uncritical and its newness often goes back to the concepts of the 19th or even 18th centuries. Vague as it is, The new teaching has evidently revealed so far only one positive feature: recognition of the objective reality as the starting point of scientific cognition. To this can be added its intention to analyze the real process of scientific development and the real history of science rather than to indulge in the invention of speculative schemes based on new metaphysical concepts. It is undoubtedly a sober approach which corresponds to the present level and to the prospects of scientific development. To be sure, critical attitude to positivism is an important asset of the new school. Its criticism is all the more effective as it exposes the inner contradictions of the philosophy which has in fact been source of the youthful inspiration of practically all modern prominent expounders of scientific realism. Willard Van Orman-Quine, Herbert Fagel, Wilfrid Sellars, Mario Bunge, and many other contemporary leaders of this trend were under a strong influence of positivist philosophy, at least in their early period, even though they did not completely share its views. Understandably, the general crisis of positivism, which revealed itself not only in the internal contradictions of the positivist methodological program but also in the conflict with the general trend of scientific cognition, marked a turning point in the attitude towards the ideas of Carnap, Schlick, Reichenbach, Ayer, and other positivists. No less significant is the opposition of scientific realism to critical rationalism, which is often considered to be the direct successor of positivist philosophy. One cannot deny, however, the mutual influence of these trends, which is manifested, for instance, in that Popper, Feyerabend, and others not infrequently identify themselves with the realists. True, their statements are not immune from verification. The realism of the new school implies a critical reappraisal of the positivist methodological program, prompted, as has already been pointed out, by the practical needs of the scientific and technological revolution in the late 1940s, early 1950s. This reappraisal has involved almost all the essential points of this program: the problems of the objectivity of knowledge, causality, determinism, the relationship of matter and consciousness, and, to a lesser extent, the problems of the development and structure of science. To be sure, the actual range of problems requiring a different approach in connection with the methodological criticism of positivist philosophy is much broader and extends far beyond the narrow scope of the positivist program, which, in fact, determines the horizon of scientific realism and prevents it from opening up broader fields of scientific cognition. We shall consider the attitude of the new trend to these problems later and concentrate now on its interpretation of the scientificity of philosophy and the relationship of philosophy and science, the two main topics of this chapter. The anti-positivist solution of these issues by scientific realism has led, first and foremost, to the revival of ontology. It is noteworthy that realism connects the revival of ontology as a philosophical doctrine of being and as a philosophical explication of the properties, objects, and relations of the external world with the recognition of the external world, i.e., the reality which existed prior to and independently of man. Significantly, most of the followers of scientific realism declare themselves modern materialists, exponents of scientific materialism, etc. But how true are such declarations? Do the claims of scientific realists correspond to the content of their doctrine and its premises to its conclusions? The new school directs its criticism first and foremost at the extremes of the positivist slogan of struggle against metaphysics under the cover of both verificationism and falsificationism. According to the realists, this slogan is untenable for several reasons. First, in everyday practice, scientific investigation ignores the facts which contradict theory. Second, facts are not primary in scientific cognition, they are born, so to speak, in theoretical diapers. Third, theories deal not with the objects of observation, but only with their idealized models. Fourth, the verification of a scientific assertion is not, as a rule, a simple consequence of a theory, but rather follows from a theory combined with additional assumptions which must also be tested by experience. Hence, neither verification nor falsification taken separately can provide a satisfactory criterion for establishing the truth of a theory and recognizing its scientificity and, consequently, for distinguishing metaphysical statements from true science. Quine, one of the early opponents of positivism representing the views of the New School, clearly reveals the unsoundness of the main dogmas of the traditional philosophy of science, its belief in the possibility of sharply demarcating the analytical truths independent of empirical facts from the synthetic propositions based on empirical facts, and its reduction principle whereby each meaningful assertion can be reduced by purely logical means to basic empirical facts or propositions of the protocol statement type. He points out that the basic concept of logical positivism, which regarded language to be the starting point of analysis, was fallacious, since the so-called physical object language proposed by this school was at variance with its own demand to be the language of sensually perceptible physical phenomena. Including the notions of a logically developed theory, language incorporated of necessity certain elements of mathematical theories related, for instance, to mathematical logic. The presence of such notions as a class of objects and a class of classes in the concept of logical empiricism was in itself a linguistic indulgence incompatible with the monastic vows of positivism. Quine admits that ontological problems are unavoidable and emphasizes that their formulation can only be sensible and free from contradictions if ontological statements meet the demands of modern logical analysis. The adopted ontology can only be regarded as unambiguous after the confusion resulting from the use of individual terms has been eliminated with the help of Russell's description theory, quantification methods, etc. According to Quine, the fundamental ontological question can be put as follows: what kind of objects can be considered real if we believe in the truth of a given theory? The criterion of being, which is the subject matter of ontology, is no less definite. To be is to be the meaning of the variable. From this it follows that any theory recognizes in fact only those objects which can be classified as variables connected with one another in such a way as to confirm the truth of the propositions of the given theory. Quine as a realist declares in favor not only of the existence of objective reality, but also of a possibility to construct scientific ontology, thus overcoming the general anthropocentrism of positivist philosophy. In his opinion, no special philosophical system of knowledge is required for this purpose, since ontology is entirely a product of scientific theory. Quine contends that our knowledge, on the one hand, maintains contact with the external world through sense perception. Yet it also comprises entities outside sensory experience. Man's knowledge is predetermined by his sense perception, but different people need not necessarily get identical sensory data under identical conditions. This accounts for a possibility of switching over from the empirical language to the language of theory. It is precisely the intersubjective language which makes it possible, according to Quine, to perceive different empirical facts, i.e. to agree or disagree with the observer's propositions. It is this, writes Quine, that enables the child to learn when to assent to the observation sentence. And it is this also, intersubjective observability at the time, that qualifies observation sentences as checkpoints for scientific theory. Observation sentences state the evidence, to which all witnesses must accede. As distinct from Feyerabend, Quine is ready to go beyond the empirical evidence. Even if two theories are equivalent in terms of empirical evidence, they may be very different. This suggests, according to Quine, that the preference in selecting a true theory is determined by its simplicity rather than by a criterion related to empirical material. Hence, the judgments regarding the truth of a theory can only be passed after the theory has been accepted or rejected. It is only within the framework of the existing conceptual scheme that one can assess the true content of a theory. Consequently, reality as the true content of knowledge is entirely out of the question, except in the language of the adopted conceptual scheme. Quine prefers not to speak of things in themselves or of some other special philosophical interpretation of a scientific theory. Reality, according to Quine, is in fact what we believe to be existing. Therefore he regards science as primary, and epistemology as secondary, or, as he puts it, as science self-applied. Its task, according to Quine, is to show how we know what we ought to know about science. Quine does not concern himself about the metaphysical status of propositions but is rather interested in what we should do with them. Epistemology, according to Quine, is not something outside science, it is incorporated in our judgment about it. The decision as regards what is existent and what is non-existent depends on the contemporary state of science. Quine takes special note of Carnap's well-known attempt to water down the rigid dogma of radical reductionism by conceding that each proposition taken by itself and isolated from other propositions can be confirmed or disproved as a whole. Yet even this thesis does not seem to him quite satisfactory, and he contrasts to it his own version, according to which our statements about the external world face the tribunal of sense experience not individually but only as a corporate body. According to Quine, total science is like a field of force whose boundary conditions are experience. A conflict with experience at the periphery occasions readjustments in the interior of the field. Re-evaluation of some statements entails re-evaluation of others, because of their logical interconnections, but the total field is so undetermined by its boundary conditions, experience, that there is much latitude of choice. No particular experiences are linked with any particular statements in the interior of the field, except indirectly through considerations of equilibrium affecting the field as a whole. If this view is right, reasons Quine further, there is no ground for speaking about the empirical content of an individual statement, particularly if it be a statement at all remote from the experiential periphery of the field. Furthermore, it becomes folly to seek a boundary between synthetic and analytical statements. Any statement can be held true if the theoretical system is subjected to drastic enough adjustments. Mario Bunge, one of the most influential adherents of scientific realism, also points out the sketchy character of the positivist concept of the relation of theory to experience. He maintains that the procedure of checking a theory is, generally speaking, far more complex than is suggested by those simplified schemes imposed both by the verification and falsification principles. The task of the philosophy of science is to bring the description of this procedure as close as possible to the scientist's real work. In one of his articles he writes, "We must start afresh, keeping closer to actual scientific research than to the philosophical traditions. The empirical test alone is far from being sufficient. A scientific theory must be subjected not only to an empirical, but also to a non-empirical test which should have at least three aspects: metatheoretical, intertheoretical, and philosophical. The object of the metatheoretical checking of a theory should consist in ascertaining that it is not inwardly contradictory, that its consequences have factual content, and that there exists a procedure for a transition from unobservable causes to observable ones. The intertheoretical checking consists in ascertaining that the theory in question is consistent with other theories, already recognized. The purpose of the philosophical checking is to establish to what extent the new theory corresponds to the dominant philosophy. Bunge has no doubts about the need to bring our scientific theories in accord with the dominant philosophical concepts. The worldview, according to Bunge, has a direct bearing on the selection of research problems, the formation of hypotheses, and the evaluation of ideas and procedures. This correspondence has always been sought for and alleged even if it did not exist, as was the case with the relativist and atomic theories in relation to positivism. The latter circumstance makes it absolutely imperative to check the soundness of the philosophical principles themselves. According to scientific realism, Popper's falsification theory is no less contradictory than the verification theory, and both of them are equally far removed from the real practice of scientific cognition. Not a single scientist, says Bunge, would like to see his own creation dead. On the contrary, he would do everything possible to make it viable, i.e. to corroborate his theory. A closer look at the process of consolidation of a scientific theory reveals in it two more or less distinct stages. At the first stage, the theory advanced by a scientist gains ground, and his colleagues, no less than the author himself, are busy searching for facts to support it. At the second stage, the new theory struggling for existence and for the right to develop comes across phenomena which do not fall within its framework. The theory becomes the object of criticism, and the process of the revaluation of facts begins. A lot of theories highly beneficial to science have won the right to existence without applying to the falsification criterion. There are many methods whereby a theory can be constructed. Theories can adapt themselves to new data which seemed at first inconvenient, develop additional and auxiliary hypotheses and, once they reached the necessary level of corroboration, are never discarded at once. A way of building a scientific theory, writes Bungay, is to surround the central hypotheses with well-meaning protectors hoping they will eventually turn out to be true. There is nothing wrong about protecting a hypothesis by ad hoc hypotheses as long as the latter are in principle independently testable. This method permits building quite a viable hypothetico-deductive system and may ensue in a new crop of experiments, whereas a strict application of Popper's criterion would nip the whole development in the bud. After a detailed analysis of the applicability of Popper's falsification criterion to some important scientific theories, Bungay comes to the conclusion that it is useless in the assessment of many general theories such as, for instance, the concept of continuum mechanics, the evolution theory, etc. They can only be tested in combination with additional hypotheses or specific data pertaining to the components of the systems, their interaction or spatial configuration, etc. Unlike the lever, simple pendulum, and other specific theories which lend themselves to full-scale testing, the field theory or, for instance, the concept of quantum mechanics cannot be subjected to exhaustive testing. In this connection, Bungay singles out three types of scientific theories: specific theories, such as particle mechanics or the quantum theory of the helium atom; generic fully interpreted theories, such as classical mechanics, quantum mechanics, general relativity, the evolution theory; generic semi-interpreted theories, such as games theory, information theory, field theory, etc. Characterizing the third type theories, most of the symbols of which are assigned no factual interpretation, Bungay points out that such theories are particularly valuable in case of insufficient, incomplete knowledge of facts. Emphasizing also their extremely general character and empirical untestability, Bungay points out that many such theories seem in fact to qualify as metaphysical ones. From this he makes the conclusion that there is no sharp line of demarcation between science and metaphysics. Surely, contends Bungay, there is a line between wild metaphysics and science as well as a boundary between exact metaphysics and pseudoscience, but there seems to be no frontier between exact metaphysics and the set of most general scientific theories. In fact, there is a good deal of overlap. Bungay further points out that the term metaphysics had different shades of meaning in the history of philosophy and concentrates on two of them. Plain metaphysics, according to Bungay, ranges from elaborate nonsense through archaic common sense to deep and sophisticated yet outdated good sense. It is removed too far from modern knowledge. Kant, says Bungay, was certainly right in his day in stressing the difference between science and metaphysics and in claiming that it was impossible to conceive of metaphysics as a science. So were probably the Vienna Circle and Popper in their own time, that is. Now, according to Bungay, the situation has radically changed with the appearance of exact ontological theories relevant to science. Conditions are now ripe for the emergence of exact metaphysics, which seeks to solve some problems put off by plain metaphysics and strives to keep tune both with formal and factual sciences. Bungay's requirements to scientific metaphysics, on which he dwells at length, deserve special attention. In his opinion, scientific metaphysics should concern itself primarily with the most general properties of reality and real objects, rather than with spiritual objects. It should be a systematic theory or a part thereof rather than expound somebody's views. It should make use of logic and mathematics. It should expound key philosophical concepts and fundamentals of science. It should contain elements which can be found among the postulates of scientific theories. Scientific metaphysics can itself become a scientific theory as a result of specification or additional conditions for its application. Meta-theories, according to Bungay, can also be constructed with the use of elements borrowed from other fields of knowledge, as well as with the help of analogy and extrapolation. In Bungay's opinion, all means are good for this purpose. He considers in detail the analysis and synthesis theory as an example of metaphysical theories and maintains that it is growing beyond the bounds of chemistry where it originated. Among metaphysical, he also rates the automata theory on the grounds that it can be referred to the object-medium system of any type, mechanical, electrical, biological, or behavioral. The author classifies the problems pertaining to the methodological analysis of scientific metaphysics under three categories. The first relates to the form of metaphysical theories, which, in the author's view, must have a mathematical structure to qualify as exact theories. This structure must be at least algebraic or logical, if not quantitative. The second category of problems is pertinent to the content of metaphysical theories. Here the author points out that scientific metaphysics, unlike factual sciences, is concerned primarily with the world at large. Consequently, the logically possible models of natural processes lie outside its sphere. Finally, the third category of problems is connected with the testing of metaphysical theories. Rejecting both the empirical positivist and Popper's concepts of the testability of scientific knowledge, Bungay proposes a special criterion of scientificity: the conceptual testability of theories understood as their compatibility with the fundamentals of our prior knowledge. What is more, conceptual testability is but the indispensable condition of scientificity. To qualify as scientific, theories of any type must also meet additional requirements which depend on the nature of the problem being considered. These additional requirements, according to Bungay, are as follows: a hypothesis should be at least indirectly confirmable, a specific theory should include components which are both empirically confirmable and refutable when enriched with empirical data, a generic interpreted theory should be susceptible of becoming a specific theory upon the adjunction of subsidiary assumptions and their interpretation, a generic semi-interpreted theory should be capable of turning into a generic interpreted theory. Bungay avers that conceptual testability jointly with any of the above four conditions constitute necessary and sufficient conditions for a hypothesis or a theory to be called scientific. Hence, testability in the broad sense is in fact the equivalent of scientificity, testable knowledge is scientific and vice versa. As regards the testability of metaphysical theories, the author does not go beyond generalities. A metaphysical theory should be enlightening, as well as capable of being inserted in the non-formal axiomatic background of some scientific theory, i.e., it should be susceptible of becoming a presupposition of theoretical science. To be scientifically valid, metaphysical theories, according to Bungay, should be exact, consistent with scientific knowledge, and capable of clarifying and systematizing philosophical concepts or principles. As we see, Bungay's testability concept is patently contradictory. Denying a sharp line of demarcation between metaphysical and generic scientific theories, he nevertheless does not admit that metaphysical theories, unlike scientific ones, do not lend themselves even to a conceptual verification. They cannot be true or false, they can be applicable or non-applicable. They are useful in the sense that they are always motivated and constitute sweeping generalizations of actual or possible specific theories. The theories of this kind are corrigible, but not refutable, they can be improved upon formally or they can be made more complex. In short, theories in scientific metaphysics cannot be refuted, but, on the other hand, they can be confirmed if not through prediction but at least by showing that they are compatible with a whole family of specific theories or that they take part in the design of viable systems. Strangely enough, writes Bungay, such theories can be adequate and convenient without being true, and they can never be falsified. At most they can be shown to be irrelevant or pointless or useless. According to Bungay, the theories of the second and third types can raise the level of generalizations and serve as a basis for predictions owing to the introduction of additional specific premises. If that is so, there seems to be no reason why the theories called by him metaphysical cannot be specified in a similar manner. Sure enough, the general systems theory or the theory of integration levels classed by the author as metaphysical cannot give concrete predictions in such fields as, for instance, economics, biology, cybernetics, where they have set up, so to speak, their specialized divisions. Yet it is obvious that these theories can provide a basis for some general conclusions which, in turn, enable scientists to make forecasts and inferences of a less general level, and so on. Hence, there is no sharp line of demarcation between metaphysical theories and the theories of the second and third type from the viewpoint of their testability either. Bungay writes, while the Vienna Circle rejected metaphysics as the enemy of science, and Popper tolerated it for its heuristic value, we have come to regard metaphysics as capable of becoming scientific and moreover as constituting, together with logic and semantics, the common part of philosophy and science. However, contrasting his viewpoint to the positivist concept, Bungay fails to take into account that positivism has qualified as metaphysical not only and even not so much the general theories of science as the most general philosophical principles of materialism and dialectics. That is why any consistent criticism of positivist philosophy must of necessity show the real methodological and worldview significance of these principles for special sciences. Critical as he is of positivism, Bungay undoubtedly makes here an important concession. Bridging the gap between science and metaphysics, he disregards the difference between philosophical concepts and the general theories of modern science, reducing the former to the latter. Among the important components of scientific metaphysics Bungay ranks, for instance, the concept of the structural levels of matter. Giving this concept the conventional interpretation reflected in relevant scientific literature, Bungay, however, treats it not only as a metaphysical theory, but also as a set of definite epistemological principles. Moreover, he also presents it in a methodological form as a set of conditions which scientific investigation must comply with. One may ask here if other metaphysical theories too must have both the epistemological and general methodological form. The answer to this question should evidently be in the negative, since the level of generalization in the concept of the structural levels of matter is much higher than in such metaphysical theories as the automata theory or the theory of games. The automata theory cannot provide a basis for the general methodology of science and epistemology. Here Bungay, evidently, eliminates the line of demarcation which does exist that between special scientific theories and philosophical concepts. However broad the generalizations in such theories as the theory of games, the automata theory and the general theory of systems, all of them remain within the sphere of special sciences, whereas the concept of structural levels has long since become the object of philosophical investigations. Such vagueness in demarcating special sciences and philosophy is by no means accidental. In the context of Bungay's concept, it attests to a tendency to reduce philosophy to the level of metaphysical principles and theories rather than to include metaphysical theories into the system of philosophical knowledge. This becomes even more evident when we acquaint ourselves with Bungay's attitude towards materialism and dialectics. Substantiating his views on the scientific value of metaphysical theories, Bungay evidently intends to dispel in this way the prejudices of positivism against the so-called metaphysical problems. His efforts, however, go wide of the mark, since he deprives materialism and dialectics of their methodological and worldview role in science without any reason whatsoever, and ascribes all methodological functions to general theories, such as the automata theory, the general systems theory, etc. This trend towards the identification of ontology with science is characteristic, with some variations, of many other representatives of scientific realism, though some of them attempt to distinguish between philosophical and scientific ontology. The task of the philosopher, writes Errol Harris, is thus twofold. He must use the evidence provided by the sciences to construct a comprehensive and coherent conception of the universe, and he must examine the methods of scientific investigation and discovery and the process by which the science advances, in order to discern the insignia of reliability that entitle any discipline to be called by the name of knowledge, that is, science. As a rule, the defense of a scientific theory by realism is not based on ontological convictions, rather on the contrary. The reliability of a theory guaranteed by the use of adopted means and methods of scientific investigation can serve as a basis for ascribing ontological existence to its postulates, motions, and concepts. Of course, besides the scientific perception of reality by man, there also exists the conventional everyday perception. Wilfrid Sellars, for instance, even writes about a tragic dualism of the two antagonistic ways of thinking, the scientific and the manifest. The first makes use of the techniques, methods, and language of natural sciences. The second is guided by the common sense and traditional thinking adopted in everyday life. In Seller's opinion, the task of philosophy consists in a harmonious integration of these two ways of thinking. Yet in his ontology he shows obvious preference for the paradigms of scientific thinking. For him, the world's ultimate constituents are primarily the theoretical postulates and principles of science. Speaking as a philosopher, he notes, "I am quite prepared to say that the common sense world of physical object in space and time is unreal, that is, that there are no such things. Or, to put it less paradoxically, that in the dimension of describing and explaining the world, science is the measure of all things, of what is that it is, and of what is not that it is not." As we see, scientific realism, gradually detaching itself from positivism, step by step shapes its anti-positivist program aimed at reviving metaphysics. The central point of this program is the relation of consciousness to the brain, the problem which was completely ignored by the former philosophy of science. Indeed, the development of scientific ontology is impossible without its solution. Positivism has eliminated the consciousness-brain problem as patently metaphysical. Thus Carnap wrote, "Are the so-called mental processes really physical processes or not? Are the so-called physical processes really spiritual or not? It seems doubtful whether we can find any theoretical content in such philosophical questions as discussed by monism, dualism, and pluralism." The attempt to get rid of the psychophysical problem, like of other so-called metaphysical problems, was not and could not be successful. It proved to be yet another delusion of positivism. In point of fact, positivist literature itself gives quite a definite solution to this problem in the monistic spirit of subjective idealism. This solution, which has nothing in common with materialist views, is plainly stated by Moritz Schlick, who writes that the adjectives physical and mental formulate only two different representational models, or by Alfred Ayer, who tries to substantiate the thesis that statements of mental phenomena and statements of bodily phenomena are two different methods of the classification and interpretation of our experience. The authors of these views are far from asserting the primacy of electromagnetic, thermal, mechanical, or other physical processes which underlie psychic phenomena. They do not deal with the phenomena of objective reality. Their main intent is to emphasize the unity of science or sciences which study sensory experience or facts entirely different by nature. All they are aiming at is to provide a single description of sense data on psychical processes, on the one hand, and of sense data on the outer world, on the other. They seek reduction within the framework of a theory only and do not turn to the actual processes taking place in the physical world. Consequently, sensory experience remains the origin of all origins, the cause of all causes, and the task only consists in harmonizing the languages of physics and psychology within the present framework. The sum total of this reduction is bluntly stated by Karl Hempel, who contends that psychology is an integral part of physics and even asserts that all sciences have in principle one and the same nature and belong to physics as its branches. Searching for the ontology of knowledge, scientific realism, naturally, could not sidestep the problem of the relation of consciousness and the brain, not only as a specific issue directly involved in all the problems being raised by the new trend, but as an independent problem of crucial importance for the very status of scientific ontology. It is not accidental that the branch of scientific realism directly concerned with the investigation of this problem has actually turned into a more or less independent school of scientific materialism, the name suggesting a definite anti-positivist and anti-idealistic orientation of the new teaching. Nevertheless, the difference between positivism and scientific realism is not infrequently hard to determine, mainly owing to the fact that both schools bear a distinct mark of reductionism. Logical positivism, coming out against dualism, strives to overcome it by reducing psychic to physical phenomena within the framework of scientific descriptions. The followers of scientific materialism are also engaged in reductions with practically the same aim as the positivists to eliminate dualism. The difference between these two schools consists in that scientific materialism, in contrast to positivism, is concerned not with theoretical reductions, but with ontological ones, i.e. it strives to reduce psychic phenomena as such to physical phenomena. It is, in fact, the confusion of these two types of reduction that underlies endless debates in the literature on psychophysical problems. Positivistic reductionism tends to treat the psychophysical problem within the narrow confines of the concept of unity of scientific knowledge, casting aside all its so-called metaphysical aspects. The possibility of reducing the psychic to the physical is based here, and by no means accidentally, on the theory of meaning alone. The description of an object in psychical terms must have the same meaning as its description in physical terms. The proof of the unity, naturally, boils down to the logico-semantic analysis of statements. Logical positivism maintains that psychological statements cannot be directly translated into physical ones. Yet one can speak of them as being identical if they are considered to be just different methods of describing one and the same object. The direct experience of human beings, as well as the experience we sometimes ascribe to some higher animals, is identical with certain aspects of nervous processes in the organism. What is had in experience, and knowable by acquaintance, is identical with the object of knowledge by description provided first by moral behavior theory, and this is in turn identical with what the science of neurophysiology describes. The author of this statement, as we see, does not accentuate physical identity. He emphasizes the fact that in the two kinds of knowledge, the knowledge through the realization of one's own raw sensations and the knowledge by description, differing from each other both in the source of information or language and in the method of verification, we in fact deal with one and the same object, which gives us the right to speak of their identity. Very characteristic is also Feigele's pronounced positivistic approach to the problem. He sincerely believes that the identity thesis eliminates any ontological interpretation of the psychophysical problem and thereby abolishes psychophysical dualism. According to Feigele, the mental and the physical are identical in that the mental terms, on the one hand, and some neurophysiological terms, on the other, have similar meanings and, as scientific progress goes on, tend to converge so that their correlation gradually turns into actual identity. Feigele distinguishes between direct sense experience, which carries direct knowledge of our mental states, and the experience expressed in some very personal language. All empirical concepts are based entirely on this personal language, since they form a higher degree of certainty. Despite a certain deviation from the positivist paradigm noted by numerous authors, Feigele nevertheless does not desert it completely. The physicalism of his position is, on the whole, far removed from consistent, i.e. dialectical, materialism, though Feigele sometimes notes seeks to overcome the barrier set up by positivism and find a way to objective reality which is pictured as having its own existence independent of the process of cognition, yet being knowable only through the medium of science. Here the function of reduction is different. It consists in creating a scientific image of the world, ontology, representing the real processes as they actually happen. Determining whether or not materialism can be true, writes Jerry Fodor, is part of understanding the relation between theories in psychology and theories in neurology, a relation that many philosophers believe poses a stumbling block for the doctrine of the unity of science. In particular, it is sometimes maintained that the unity of science requires that it prove possible to reduce psychological theories to neurological theories, the model of reduction being provided by the relation between constructs in chemistry and those in physics. The treatment of the mind-body problem by positivism is also criticized by Australian philosopher J.J. Smart, who unequivocally dissociates himself from its dualism. He writes, "Insofar as after-image or ache is report of a process, it is report of a process that happens to be a brain process. It follows that the thesis does not claim that sensation statements can be translated into statements about brain processes. Nor does it claim that the logic of a sensation statement is the same as that of a brain process statement. All it claims is that insofar as a sensation statement is a report of something, that something is in fact a brain process. Sensations are nothing over and above brain processes." Criticizing dualism, Smart counterposes to it what he styles as his materialistic metaphysics. According to Smart, every year science provides more and more convincing proof that man is nothing but a psychophysical mechanism. Sooner or later his behavior will be exhaustively characterized in the corresponding terms. In point of fact, there is nothing in the world besides a complex aggregate of physical particles, protons and electrons, and their interaction, and the only real laws of science are the laws of physics and chemistry. As we see, unlike former materialism which gravitated towards ontological reductionism, i.e. tended to reduce real psychic and mental processes to physical phenomena, modern scientific materialism strives to substitute the knowledge of physical objects for the objects themselves, thereby identifying reality with its linguistic image. The difference of the approaches to the mental physical or mind-body problem on the part of Hegel, on the one hand, and Smart, or Sellers, on the other, consists in that the neopositivist faction focuses on this problem in order to discard it as metaphysical by reducing the mental to the physical, whereas scientific materialism as a form of scientific realism pursues quite a different aim: to translate the descriptive language used to characterize mental processes into the language of science. In order to be able to construct a scientific ontology of mental processes, the reductionist approach to the consciousness-brain problem characteristic of scientific realism and positivism, the attempts of both schools to reduce all spiritual phenomena exclusively to neurophysiological processes, are largely traceable to their common traditions. The similarity of the realistic and positivist views also shows up in their exaggerated emphasis on the analysis of the language used to describe processes in interest. For all that, one ought to distinguish between positivist reductions and the reductions proposed by the scientific materialists who sincerely strive for a materialistic solution of the above problem. It should be noted that in its approach to the mind-body problem aimed at creating a new scientific ontology of mental processes, scientific materialism, like scientific realism in general, makes certain concessions to idealism and cannot be credited with consistency. Scientific realism as a whole regards the ontology of mental processes and, for that matter, ontology at large as a peculiar projection of scientific knowledge on the outer world, as a certain theoretical assumption which follows of necessity from the adopted system of scientific knowledge. Hence, reality as understood by realism is identified with the current scientific picture of the world and even with the language whereby the present or eventually possible reality is described. The specific input to NPP should be the whole of physics, past and present, classical and quantal, writes Bunge. The corresponding output should be a realistic account of actual and optimal research procedures, of conceived and conceivable ideas, of currently pursued and possible goals both in theoretical and experimental physics. As we see, realism offers no criterion for distinguishing between the really existing objects of science and purely mental, theoretical ones which, consequently, need not necessarily have their analogues in the material world. It proceeds from the conviction that reality outside the language of science, i.e. reality as such, is nonsensical, since all true judgments of reality can only be expressed in scientific notions. According to Rorty, the traditional description of psychic and spiritual phenomena in modern culture must also be replaced by scientific description, which is to be given priority. All other languages are not only inadequate, they are simply anachronistic, akin to demons and evil spirits. On the face of it, this thesis is directed against phenomenalism and the later views of Wittgenstein, who underscored the decisive significance of the analysis of everyday language as a panacea for all unpleasant dilemmas of modern science and advocated the concept of the plurality of languages. Yet it is quite obvious that the language of science reflects primarily the most general or universal properties and links of being and is incapable of conveying the boundless richness of relations in the real world. The deficiencies of scientific knowledge are to be made up for by literature, painting, music, sculpture, and other forms of human culture. The underestimation of the humanitarian forms of culture by all scientific realism is yet another feature which draws it closer to positivist philosophy. It is not fortuitous that both positivism and realism seek to reduce the broad diversity of individual traits to a few rather lean abstractions and show undisguised skepticism regarding the possibility of penetrating the inmost recesses of human heart. The conceptual framework of persons, writes Sellers, is not something that needs to be reconciled with the scientific image, but rather something to be joined to it. It should be noted that distinguishing between ontology and objective reality as such calls for analysis of scientific knowledge from the angle of the relation of the objective to the subjective in its content. The accomplishment of this task, in turn, presupposes a comprehensive study of the subject's role in scientific cognition, of his intellectual possibilities and limitations, merits and demerits, the theoretical heritage and the new concepts and hypotheses, abstractions and assumptions, philosophical and theoretical premises, etc. It is only through such a comprehensive study that one can reveal the objective component of theoretical knowledge and regard it as truly scientific ontology. As to the ontology which is being constructed by scientific realism outside the crucible of philosophical examination, it does not go beyond the generalization of special knowledge and the extrapolation or even direct ontologization of current scientific theories. The example of Bungay, Quine and other representatives of scientific realism shows that this school, having made some obvious concessions to idealism, has also failed so far to dissociate itself completely from the idealistic understanding of metaphysics as such. Scientific metaphysics, which is identified with ontology by most of the scientific realists, should in fact be regarded as a sphere of general scientific or meta-theoretical research. It lies beyond the limits of theoretical knowledge proper, though its generalization level is below the level of philosophical laws and principles as understood by dialectical materialism. From the viewpoint of scientific realism, the analysis of problems belonging to this sphere does not call for their serious examination either in terms of materialism or dialectics, the latter being in special disfavor with this philosophical school. It is only natural, therefore, that the ontology thus constructed turns out to be indeed metaphysical, and sometimes in the worst sense of the word at that, as it is not amenable to any critical analysis in terms of either philosophical or special scientific concepts. Scientific realism makes a very vague distinction between ontological and scientific theoretical problems, and this in fact amounts to postulating a new philosophical discipline. Philosophy, or what appeals to me under that head, writes Quine, is continuous with science. It is a wing of science in which aspects of method are examined more deeply, or in a wider perspective than elsewhere. It is also a wing in which the objectives of a science receive more than average scrutiny, and the significance of the results receives special appreciation. To sum up, the characteristic features of scientific realism are its anti-positivist orientation and persistent search for non-traditional ways in the development of the methodology of science. Life shows, however, that this school has no future as an independent philosophical trend and as a serious alternative to positivism, because it proceeds from the incompatibility of materialism and dialectics within a single philosophical doctrine. Assessed in general terms, scientific realism represents a certain tendency of the bourgeois philosophy of science to turn from positivism to the objective analysis of scientific knowledge. Chapter 2. Search for objective knowledge. 1. Positivism, Objectivity as Observability of Events. By Igor Naletov. Objectivity of knowledge has been a key issue in the course of the entire history of philosophical thought. In our time, too, it remains a touchstone of the true attitude of one or another philosophical school to science, revealing the extent of its influence on social and practical life. Those philosophers who show interest in this problem have always been aware, vaguely or keenly, that knowledge which cannot be regarded as objective is powerless or useless, and that the practices relying on such pseudo-knowledge are adventurous and even harmful. Failing to meet the requirements of objectivity, they are bound to become arbitrary. Philosophical schools do not always focus their attention on the problem of objectivity, let alone placing it in the foreground. Wittingly or unwittingly, it is often overshadowed by other issues, seemingly more concrete and, at first sight, more pressing. Yet it always underlies all controversies over the place and role of metaphysics, i.e. over the subject matter of philosophy, and has a direct bearing on such problems as the relation of sensory experience to theory, induction to deduction, truth to error, etc. Therefore the problem of the objectivity of knowledge sometimes becomes, as it were, a concentrate of many issues pertaining to different aspects of the theory of knowledge. It would not be correct to say that this problem has been treated separately from all other problems of the methodology of science, such as causality, determinism, laws of development, etc. Yet its solution has always been determined primarily by the answer to the question if reality exists outside and independently of man. Any answer to this, be it positive, negative, or 50-50, and even abstention from any answer at all, is in itself a sufficiently clear indication of the philosopher's views on the content and nature of knowledge. Attempts to elude the issue have never helped to make the philosopher's and scientists' life easier. On the contrary, the muddle has always grown worse. In its attempts to reject all unscientific, metaphysical problems, including the problem of the independent existence of objective reality and such absolutes as matter, substance, space, causality, and others, positivism has proved to be no more fortunate than other philosophical schools. However, it would be interesting and instructive to trace the impact of the objectivity problem on positivist philosophy in general, and on its specific concepts and notions in particular. This question deserves special attention if only for the fact that numerous gullible authors take in all good faith the rejection by positivism of the problem of the existence of objective reality as metaphysical, whereas others, aware of the latent contradiction in the views of the positivist writers, suspect them of a crafty intention to conceal the true meaning of their philosophy and its subjectivism. As a matter of fact, neither of these views can be accepted without serious reservations. The issue is much more complicated than is implied by the proposed explanations. There is yet another aspect to the problem of the objectivity of knowledge in positivist philosophy. The understanding of its true attitude to this problem provides a key to understanding the modern criticism of the positivist program by critical rationalism, scientific realism, scientific materialism, etc. Being always opposed, as it was, to the discussion of the so-called metaphysical problems and, in particular, refusing to investigate the relation of knowledge to the objective world and bother about the origin of scientific knowledge and what lies behind this knowledge, positivism could not afford to discard completely the principle of the objectivity of knowledge. Declaring against this principle would be tantamount to opposing the fundamental scientific tradition, in fact, the entire history of science, which has always held that objectivity was its chief goal and basic trait distinguishing it from other forms of knowledge and intellectual culture. Positivism has regarded traditional philosophy to be metaphysical first and foremost because it postulates the existence of transcendental reality different from and independent of the sensuous world. The question of the existence of the physical world independent of sensory experience has always been viewed by positivism from Kant to Reichenbach as a pseudo-problem at best. Refusing to discuss the origin of scientific knowledge, positivism has also regarded as metaphysical the question of its development not only from the historical, but also from the logical angle. Both these negative premises of positivist philosophy have led to a number of dramatic conclusions. For instance, Mach not only discards the absolutes of Newton's mechanics, for which he had good reason, but also declares himself against the atomic theory. Accepting the theory of relativity and quantum mechanics, Carnap and Reichenbach interpret them merely as logical devices to systematize and harmonize sensory experience. In the notes to his article The Elimination of Metaphysics Through Logical Analysis of Language, Carnap comes out against idealism as a metaphysical tendency. At the same time, expressing his attitude to metaphysics, he writes, "This term is used for the field of alleged knowledge of the essence of things which transcends the realm of empirically founded, inductive science. Metaphysics in this sense includes systems like those of Fichte, Schelling, Hegel, Bergson, Heidegger." Carnap is evidently not aware of the fact that this criticism reaches far beyond his target and hits the theoretical pillars of all modern science, as well as its material foundation. Reichenbach, on his part, ignores the real dialectical unity of the corpuscular and wave properties of matter, which was not known to classical physics and which is considered in Bohr's concept of complementarity, developed and elaborated, among others, by Vladimir Fock and his disciples. In his philosophical discourse on quantum mechanics, Reichenbach makes certain assumptions regarding the terms particle and wave which, in his opinion, are neither true nor false, and proposes a theory of equivalent descriptions according to which both the corpuscular and wave interpretations are admissible under certain conditions, as they say the same thing, merely using different languages. The independent existence of objects made no serious problem for the researchers in classical science. First, their attention was mainly focused on the external side of the physical world, and science was only building up strength to penetrate the hidden mechanisms of phenomena and processes, the structure of physical bodies, the Earth's bowels, the intricate heredity carriers, and the laws of cosmic processes. Second, the notions expressing the properties of objects and phenomena under observation differed but little from current everyday concepts. Third, the distorting influence of the researcher on objects and phenomena under investigation was incommensurate, even in terms of energy alone, with real processes in nature, and could not therefore affect to any appreciable degree the course or direction of these processes. Finally, progress in scientific cognition was very slow, and scientific concepts and theories were not subject to rapid change, at least on a historical scale. Knowledge accumulated and grew in scope without any serious breakdowns. Revolutionary changes in science were regarded by scientists themselves as something quite out of the ordinary. Positivism as a philosophical teaching was a typical product of its time, though it was not destined to have a long life. As physics and other sciences were passing on from macroscopic objects familiar to man from his everyday experience to the inner structure of matter, the problem of objectivity was acquiring essentially new scope and dimensions. Scientific notions were more departing from the ideal of sensual certitude, observability. Particularly heavy was the blow delivered on the principle of sensual certitude by the discovery of electron and other microparticles at the end of the 19th century. The crisis in physics at the turn of the century was regarded as crisis of all former scientific ideals, including the ideal of objective knowledge and, consequently, as a crisis of materialism. The fact that objects under investigation could be observed no longer was used by positivist philosophy not for revising its mistaken views, but for confusing the issue, namely, for rejecting the idea of any reality beyond the limits of sensory experience. Incidentally, it is precisely this philosophy clinging to the obsolete ideals of empirical science that bears responsibility for the survival of the dogmas of metaphysical materialism in natural sciences till the end of the 19th century, the dogmas which had been discredited and buried by dialectical materialism half a century earlier. If objective reality is only what is observable, the task and the function of theory consist merely in finding as yet unknown observable and measurable objects proceeding from the available sensory experience and taking into account the body of mathematics. In this case, theory does not play any independent role, and its function is confined to purely logical analysis, leading a scientist from one sensory experience to another. The obvious implication of this approach is that a non-classical theory should be free from any new notions, i.e. notions having any new physical meaning, new objective content. A physical theory is merely a new logical means to systematize the observable. Quantum mechanics, however, proved to be not only far removed from the ideals of positivism, it was a direct challenge to it, despite some temporary rapprochement between them regarding the principles of causality and objectivity, which ended in a complete alienation, evidently final. The positivists regarded quantum mechanics as an expression of experience or its elements connected by formal logical means. By contrast, Bohr's aim was rather to find out the conditions making experience possible, i.e. its necessary premises. The so-called Copenhagen interpretation is often associated with the assertion that the non-existent cannot be observable. Its essence, however, will be more accurately summed up in the statement: the observable is definitely existent, the non-observable allows of certain suppositions. The purpose of research in classical physics was to establish definite phenomena taking place in space and time, and to investigate laws determining the course of processes. A problem was considered solved if the researcher succeeded in proving that a process did take place in space and time. The method whereby the process had been cognized, the observations which had made it possible to ascertain its existence experimentally were absolutely immaterial. In the quantum theory, the physicist is faced with an entirely different situation. The very fact that the mathematical scheme of quantum mechanics is not a graphic representation of processes taking place in space and time shows that it can only permit calculating the probability of one or another result of an experiment based on the experimental knowledge of the previous state of the atom system, insofar as the latter has not been subjected to any other disturbances except those needed by the experimentalists themselves. Even a most complete set of experimental conditions cannot give more than a mere probability of the result expected in the next experiment on the system. To the positivists it was a sure sign that any objectivity of the processes in interest was entirely out of the question. Each observation led to a certain discrete change of the mathematical values characterizing the atomic process and, consequently, to a discrete change of the physical phenomenon itself. In contrast to the classical theory, where the method of observation was immaterial for the process under investigation, in the quantum theory the disturbance produced by each observation of atom phenomena plays a decisive role. Further, since any observation can only be summed up in probability statements as regards the results of later observations, the account of the essentially uncontrollable disturbance component must become, according to Bohr, a decisive factor in constructing a quantum theory free from contradictions. As distinct from positivism in general or, at least, from its most radical versions, Bohr did not consider sensory data to be elementary entities. What he called phenomena could only be defined within a broader context of reality. This reality as the context of experience could be set by concepts performing the role of definite conditions or premises of classical physics. Bohr usually meant two such conditions, spatial time description and causality, which were only compatible within the classical model of events. In his opinion, the discovery of the quantum of action had led to a break between them and to the adoption of the principle of complementarity of descriptions. Things being as they were, Bohr and a number of his followers made an attempt to combine the object of observations, the measuring apparatus and the observer into a single quantum mechanical system and thus to eliminate uncertainty. In his speech on receiving a Nobel Prize, Werner Heisenberg said that classical physics was the kind of aspiration for the knowledge of nature in which scientists strove to make conclusions on objective processes proceeding in fact from their sensations and refusing to take into account the influences of all observations on the object being observed. Quantum mechanics, on the contrary, obtained the possibility of considering atomic processes by partly refusing to objectivize them and describe in terms of space and time. Despite the controversies lasting many years, this interpretation known as the Copenhagen approach has not yet completely lost its grip on the minds of philosophers and physicists, many of whom are still inclined to think that by breaking with the traditions of classical science, quantum mechanics has opened up a new epoch. Quantum mechanics, writes, for instance, J. A. Wheeler, has led us to take seriously and explore the view that the observer is as essential to the creation of the universe as the universe is to the creation of the observer. Unless the blind dice of mutation and natural selection lead to life and consciousness and observership at some point down the road, the universe could not have come into being in the first place, there would be nothing rather than something. Hence, quantum mechanics provides a new point of reference for understanding all events in the universe, including its emergence in the form which engendered our life itself. Reality, according to Wheeler, can no longer be regarded as independent of the observer. Eugene Wigner, too, is inclined to share the opinion that quantum mechanics deals with nothing else but measurements or observations. He maintains that the equations of movement both in classical and quantum mechanics do not describe reality but are merely instruments to calculate the probability of certain results of observations. His opinion is in full conformity with the positivist views that the observation becomes fulfilled when the observer's consciousness is brought into play and that not a single system has any definite measurement attributes of its own, they appear only as a result of the very process of measurement or simultaneously with it. In this connection, Wigner writes, it is the entering of an impression into our consciousness which alters the wave function because it modifies our appraisal of the probabilities for different impressions which we expect to receive in the future. It is at this point that the consciousness enters the theory unavoidably and unalterably. If one speaks in terms of the wave function, its changes are coupled with the entering of impressions into our consciousness. There is nothing surprising, according to Wigner, in that idealism provides the most relevant representation of the world. Even if it were possible to exclude the observer from the analysis of a quantum mechanical situation, it would be necessary, in Wigner's opinion, to project him mentally. Indeed, observation and measurement are important requisites for the construction of quantum mechanics. The admission of this fact, however, leaves open the question of the relations between the components of this unity: the system, the instrument, and the observer. Wigner's method reduces the first two to the last one. The independent existence of physical objects is called in question. To be sure, Wigner does not aver that consciousness creates its images in absolute vacuum or that physical theories are products of immaterial elements. His viewpoint, rather, consists in that scientific research is limited to the sphere of actually existing, i.e. observable, events. Wigner does not simply repeat the arguments of Machist philosophy but goes further, making the object more and more dependent on observation. This view leads, in fact, to the elimination of the positivist concept of system-instrument unity in favor of the logical primacy of the observer. As a result, reality becomes the world of experience or the empirical world. Modern physicist S.W. Hawking goes even as far as asserting the existence of some impenetrable curtain which completely shuts out everything that lies behind it. In his opinion, gravitational collapse sets an obvious barrier to scientific cognition which can hardly be expected to be overcome even in the distant future. The thing is that the inner state of the black hole is, according to theoretical calculation, unobservable in principle. Hence, gravitation provides an example of uncertainty regarding the existence of real objects, which is even of a higher order than the uncertainty in quantum mechanics. Recalling Einstein's winged words, God does not play dice, in his well-known controversy with Bohr, the author even attempts to strengthen Bohr's arguments. In his opinion, God not only plays dice, he sometimes throws the dice where they cannot be seen. Another threat to the objectivity of scientific knowledge comes from the probability interpretation of the so-called psi function. According to Bohr, the wave and corpuscular theories of microparticles need not necessarily be contradictory in reality despite their conceptual incompatibility. Both theories are equally important for the physical reality, each covering a definite type of situations, and consequently, are complementary. Proceeding from this viewpoint, some physicists and philosophers came to the conclusion that the psi function is a wave function representing the density of probability and, consequently, is merely a mental projection of theory on a physical situation. In point of fact, nothing but the form of mathematical equations makes it possible to treat a particle as a certain density of probability which can represent it in an experiment. The function provides but a partial description of physical reality and, besides, merges the object and the subject into a single whole. Though, according to Heisenberg, we can separate them temporarily in different specific situations, they can never be completely detached from each other. Erwin Schrödinger contends that one can hardly assert the existence of waves in nature if probability is their characteristic feature. In his opinion, one can only speak of the probability of an event if one believes that it does occur now and then. If the probability function does not describe any physical reality in an experiment, it definitely does not give any information on what takes place between two experiments. As we see, some of the above arguments boil down to the assertion that what is not observable cannot be accepted by science. Others emphasize the fact that wave is the only form of quantum movement in space, which is attested to by such physical phenomena as interference, diffraction, and others. Since waves represent nothing but probability, doubt is cast on the existence of particles in the period between the experiments ascertaining their presence. It should be noted that the above viewpoint leaves out of account two important circumstances. First, any experimental set is a macrosystem. Analyzing the results of experiments, a physicist cannot but proceed from certain laws governing physical phenomena. As a rule, he does not have to resort to probability functions. Second, the idea of the inseparable unity of the subject and the object reflects the simple fact that dynamic and spatial parameters cannot be defined simultaneously in a single experiment. Indeed, certainty can only be attained within definite limits. This fact, however, gives no grounds at all for a conclusion that the unity of the object and the subject is inseparable in general. Besides, even if particles do appear in the course of an experiment only, as is the case with excited vacuum, probability as a state is no less objective than actuality. From the viewpoint of the positivist interpretation of physical reality, the very idea of such objectivity is bound to look preposterous indeed. The real obstacle confronting the experimentalist and preventing him from accurately defining the parameters of a moving particle consists at present in the objective and glaring contradiction between the absence of any system capable of emanating or absorbing less than one quantum of energy, on the one hand, and the inevitability of the exchange of energy, however negligible, between the instrument and the object in any measurement or experiment, on the other. As regards the micro-world, where one quantum of action and the object under measurement are commensurate, any process of measurement will cause a substantial change in the state of the object. All that does not prove, however, that the existence of the object in microphysics is completely dependent on the subject. It stands to reason that the observability of an object as such does not provide a solid ground for scientific cognition. The progress of theoretical research, and particularly quantum mechanics and the theory of relativity, have revealed the inadequacy and limitations of observation as a method of cognition to the positivists themselves. The development of theoretical science has enhanced the danger of solipsism, which was evident even to the Machists way back in the late 19th century. The very fact that quantum mechanics and the theory of relativity appear to be equally meaningful to different people irrespective of their nationality and ideological affiliation has called for a considerable extension of the notion of objectivity. From the methodological viewpoint, the philosophers of science have begun to attach ever-growing significance to Hume's old idea that the focus of attention should be shifted from the observation of individual phenomena to the regular repetition of events, their regular concomitance or sequence. A separate experiment can neither confirm, nor refute a hypothesis. It takes a whole series or succession of observations. Philip Frank, a representative of late logical positivism, wrote, "A single experiment can only refute a theory if we mean by theory a system of specific statements with no allowance for modification. But what is actually called a theory in science is never such a system. Therefore, no crucial experiment can refute any such theories. From this it follows that one of the main requirements to an experiment is its reproducibility at different times and in different parts of the universe. What is the purpose of this methodological principle leading to the denial of the decisive role of experiments in science? Its aim is to replace the criterion of observability by the criterion of intersubjective verification of knowledge. As a result, objectivity becomes equivalent to intersubjectivity. Solipsism can be avoided by recognizing at least the existence of other people. But this is not all, of course. It must also be postulated that people are alike everywhere, consequently, the reality constructed by them will also be similar everywhere. Contrary to common sense, which accepts only one physical world, the emphasis on the subject who is the architect of reality leads to a tempting idea that different scientific theories and, consequently, their authors represent different worlds which they themselves construct. To avoid absolute relativism ensuing from this concept, it is necessary to show additionally how one experience can be compared with another, i.e. to solve the problem of their mutual correction. Naturally enough, subjective experience may fail to tally with what is regarded true by common consent. Let us consider at least one of the answers to this question proposed by Max Born, which is sufficiently typical of all attempts of the positivists to find a way out of a difficult situation without forfeiting their main dogmas. Expounding his views, Born describes a conversation with his cousin who asked him a puzzling question way back in his school years: "What do you mean exactly when you call this leaf, here, green, or the sky, there, blue?" Dissatisfied with Born's reference to the impressions of other people who all saw green and blue like he did, The cousin said, "There are color-blind people who see the colors differently, some of them, for example, cannot distinguish red and green." The answer to this question appeared to be far from simple, and the question itself was evidently not at all as superfluous as it had seemed at first to Born, if he deemed it necessary to return to it time and again in his declining years. Moreover, Born admitted that he had found the meaning of this question even more profound after he had got acquainted with the classical answers to it given by Kant, Russell, Mach, and Hume. Assessing the positivist doctrine alongside those of other philosophical schools he was to some degree familiar with, Born wrote, "In the most radical interpretation this theory means a denial of the existence of an external world, or at least the negation of its knowability. In practical life a follower of this doctrine would hardly behave as if there were no external world." Born, however, does not accept the materialist view either. In his opinion, dialectical materialism has so broadened the concept of matter that its initial meaning has been completely lost and the concept itself has become too far removed from concrete problems of physics. The existence of the real, objective, knowable world, according to Born, has turned into a sanctified creed. Born offers his own solution to the problem of objectivity of knowledge. In his opinion, the impossibility to prove the objective existence of green leaves and the blue sky is rooted in the attempt to reach an agreement on a single sensory impression. Such a task, according to Born, is nonsensical. Objective knowledge can only be reached by obtaining the perceptions of two communicable impressions which lend themselves to intersubjective verification. The equality or inequality of such impressions can already be ascertained quite definitely. Born lays special emphasis on the communicability of impressions. One person cannot give an adequate description of his sensations which he experiences when looking at a green leaf, but two persons together can come to an agreement regarding the color of the leaf they observe. Objectivity is thus reduced to the equality of impressions. An important means of comparing impressions is a symbol, i.e. a visual or a sound signal, the exact form of which is not important. What matters is the information conveyed by the symbol. One and the same set of data can be represented by different signals. Symbols performing the function of data carriers during intercourse between individuals are of decisive importance in attaining objective knowledge. The process of cognition is visualized by Born as follows. A child assimilates language as the totality of symbols and learns to correlate them with one another. It is worth noting that Born does not speak of the correlation between symbols and the objective world, but of the correlation between different symbols with definite meanings. Hence, given the ability to manipulate symbols, the measurement of heat intensity can be presented as the process of correlation of the sensation of heat with a geometrical value. Learning provides man with a dictionary and enables him to correlate sensations through the agency of thermometer readings, i.e. to correlate his sensations with other people's sensations. Similarly, chemistry teaches people to correlate different substances with a combination of symbols denoting elementary basic components. By correlating atomic weights with the symbols of elements one can learn the corresponding molecular weights, whereas the correlation of valency with the symbols of atoms makes it possible to forecast the results of chemical reactions. Such correspondence of sense data is established, according to Born, in all spheres of experience. Born notes the existence and coincidence of structures which are identified with the help of the sense organs and indicates that the corresponding impressions can be passed from one individual to another. He is even inclined to call these structures after Kant things in themselves. Physical formulae and systems of equations need not necessarily symbolize what is known from experience and what can be visualized. Yet Born is convinced that all these formulae are deduced from experience through abstraction and a continuous process of experimental test. For the sake of objectivity, the scientists should describe the essence of their abstract formulae in the plain language, using self-evident notions. Yet modern science, according to Born, cannot avoid subjectivity, no matter how hard the scientists may try to do so. On the whole, Born's interpretation of the complementarity principle falls in line with the principles of the Copenhagen school. A scientist is free to choose the experimental apparatus which is to be used in his experiment. However, the selection of the apparatus determines the picture of reality. Thus a subjective trend, writes Born, is reintroduced into physics and cannot be eliminated. Another loss of objectivity is due to the fact that the theory makes only probability predictions, which produce graded expectations. As we see, Born in fact substitutes the process of tuition and learning for the cognition of reality. He proceeds from an already existing system of knowledge which enables the individual experience of every man to be harmonized. This approach implies that individual experiences are identical and therefore do not need any comparison, elaboration, and correction of their content. It is quite sufficient to correlate the symbols denoting one or another totality of impressions. Such a model has in fact nothing in common with the real process of scientific cognition, which aims first and foremost at investigating new, unknown phenomena, but not at harmonizing and systematizing individual experiences with the help of an arbitrarily selected aggregate of symbols described by Born. Of course, the communicative aspect of scientific cognition is in itself an interesting philosophical problem, but it should not overshadow the essence of scientific cognition. Criticizing Mach for his attempts to reduce the world to sense perceptions and the scientific theory to a means for establishing logical links between sense perceptions, Born is in fact very close to positivism in his understanding of the process of cognition. The world lying beyond phenomena indeed remains for Born something like the Kantian thing in itself, which is not amenable to any determination. As a result, the problems of truth, of the certitude of knowledge and of the means for improving incomplete and inaccurate knowledge become superfluous. No reason whatsoever is given for the identity of our perceptions of reality, except for the reference to the selected system of symbols and to an agreement on their meanings. Such identity is the more strange as the subjective perceptions of different people vary to a considerable extent, and as there are no similar people with equal abilities for perception, equal personal experiences, equal interests, and equal stocks of knowledge, let alone many important personal qualities. The investigation of these problems has long since transcended the bounds of physical science, though the problems themselves have not become any easier for that reason. On the contrary, in such fields as chemistry, biology, the psychology of public opinion, and others where the possibilities for observation are limited, it has proved even more difficult to explain how subjective knowledge can be turned into objective knowledge, verifiable and applicable for practical purposes as it is. To save the principle of objectivity in these fields on the basis of empiricism, the philosophy of science had but one way out: only to sacrifice its traditional phenomenalist approach in favor of physicalism. This did not mean, however, a complete break with traditions, since the philosophical thinking of the positivists has always been characteristic of a peculiar symbiosis of both the phenomenalist and the physicalist approaches. Whereas the philosophers advocating phenomenalist analysis contended that sensory experience was the basis of knowledge from the epistemological viewpoint, and that the statements expressing such experience formed the language of all meaningful propositions, the physicalists believed that the foundation of all knowledge was the observation of material things, and that the statements of observation made the core of the language which was used for expressing the meaningful propositions of cognitive value. Carnap, for one, represented both these tendencies in different periods of his life. Siding up first with the phenomenological branch of positivism, he became later one of the most persistent and, perhaps, most profound expounders of the second branch too. As a result of the evolution of his views, Carnap became, willy-nilly, an instrument for a considerable deflation of the initial claims of physicalism, though the latter has not lost its ground completely till nowadays. For later time Carnap, the foundation of knowledge is not irrefutable statements, as he believed earlier, but statements which underlie any scientific investigation and provide a psychological basis of cognition not only for a scientist, but also for any individual in general. It is these initial statements that can be connected intersubjectively with other statements and therefore make the objective foundation of knowledge. Carnap's radical physicalism boils down to the assertion that all meaningful statements can be connected in one way or another with a statement of the type, the temperature in this place varies within 5 to 10 degrees C. According to Carnap, the statements of such sciences as biology, chemistry, geology, etc. can be reduced to physical notions because the type of determinism prevailing in these sciences can be reduced to physical determinism. All laws of nature, he writes, including those which hold for organisms, human beings, and human societies, are logical consequences of the physical laws, i.e. of those laws, which are needed for the explanation of inorganic processes. For instance, the notion of impregnation can be interpreted in terms of merger of sperm and ovum accompanied by some redistribution of elements. Similarly, psychological knowledge, in Carnap's opinion, can be reduced to physical knowledge. Thus, a statement to the effect that somebody has been very angry at 10 a.m. today can be translated without any detriment to the scientific value of the statement into the language of physics by stating that the person's breathing and pulse have quickened, the muscles have strained, etc. True, Carnap concedes that this reduction may perhaps fail to provide a clear idea of the laws underlying impregnation in the first case, and the emotional process, in the second. Making this concession, Carnap does not concern himself about the nature of the impregnation process or the individual's inner world. He views the problem from the angle of verbal descriptions only. If such descriptions prove to be impossible for some reason or other, there can be no question of attaining intersubjectivity, i.e. the objectivity of biological and psychological phenomena as they are understood by different scientists. In turn, the correctness of the initial statements of observation is made by Carnap contingent on the extent of agreement between the sense data of different observers. If the sense data of each of the observers are consistent with the interpretation of the indications of a certain apparatus designed to fulfill a given task, it means that the initial statements required to form a scientific proposition have passed the test for viability. True, intersubjective observability has certain advantages over the phenomenologic language from the standpoint of the development of scientific knowledge. Nevertheless, one can hardly take seriously the attempt to construct all sciences, psychology, and social disciplines including, on the basis of physics, expect all theoretical concepts and laws to be derived from physical concepts and laws. Being aware of the weakness of his position, Carnap later proposed several modified variants of the physicalist program limiting it, for instance, to the reduction of all descriptive terms in the languages of different sciences to terms denoting sensuously perceived properties of things. In his opinion, the class of observable material predicates can provide a reliable basis for the reduction of all statements and for language integrity. For instance, the ability to be dissolved in water is revealed and confirmed by the observation of the fact of dissolution. It was a significant moderation of Carnap's initial stand, as the sphere of observable empirical and dispositional predicates is markedly broader than the dot sphere of terms expressing our sense data in purely physical parameters. Finally, in one of his latest works entitled Philosophical Foundations of Physics, Carnap beats a further retreat and confines himself to a mere recommendation of a very general character, an admonition rather than an injunction, advising the scientists to base their language on the language of physics wherever possible. This is all that remained of his formerly uncompromising physicalism. Of certain interest in this context is also the position of Ernst Nagel, one of the latest and sufficiently radical adherents of the physicalist principle of reductibility. Like all other philosophers siding with the modern philosophy of science and upholding some essential traditions of positivism, Nagel sees the meaningfulness of empirical statements in their connection with direct observation, considering logical links between them chiefly formal or linguistic. In his opinion, a theory can only be meaningful if its statements relate to potentially observable things and do not run counter to its principles. He denies meaningfulness to those statements which have no empirical confirmation. According to Nagel, the data of experience, observation statements, and logical links play each their special role in the process of cognition. Nagel maintains that any attempt to base the knowledge of physical facts on sensory data is doomed to failure. If the whole edifice of science were built on direct sensory experience, knowledge would never go beyond its limits. Nagel contends that our knowledge includes objective facts, but not simple sensory data or some of their complexes localized in the sphere of sensory experience. It is only after investigation and by no means before it that we can claim the possession of sensory data. Investigation alone enables us to assert that the Earth is round and that President Roosevelt remained in office longer than his predecessors. In Nagel's opinion, the objectivity of our knowledge does not lead to metaphysical realism. He supports the view of some other physicalists that the doctrine whereby all statements on directly observable objects can be translated into the so-called physicalist language should be replaced by semantic realism, in which non-observable objects are represented by a system of nomological statements. According to Nagel, in proposing the reduction of one theory to another, we implicitly proceed from the assumption that there exists some methods to demonstrate the deducibility of one theory from another. In reductions of the sort so far mentioned, Nagel writes, the laws of the secondary science employ no descriptive terms that are not also used with approximately the same meanings in the primary science. Reductions of this type can therefore be regarded as establishing deductive relations between two sets of statements that employ a homogeneous vocabulary. Nagel admits that the secondary science sometimes includes notions which are absent from the primary science. Understandably, positivist physicalism is directed against openly idealistic concepts which not only fail to provide adequate answers to acute theoretical questions, but in every way hamper the development of modern science. The biologists, for instance, can hardly be encouraged in their investigations by philosophical doctrines explaining all the processes in living organisms by the operation of mysterious immaterial agents such as enthalpy or the vital force, which do not yield to any rational determination or even description. Central to all these doctrines from Émile Dubois-Reymond's time till nowadays has been the idea of blessed ignorance, ignoramus et ignorabimus. A prominent biologist, Konrad Lorenz, says in his book The Reverse of the Mirror that this view not only acts as a brake on scientific progress, but is also one of the gravest errors, having a dire consequence: a doubt about the reality of the external world. Lorenz deplores the belatedness of his enlightenment and notes that the practical problems of medicine and natural science have made him an opponent of idealism. This materialist tendency of modern science causes many biologists to turn their eyes to philosophical materialism. Confessions of this kind are not exceptions with prominent representatives of modern biology. Another well-known biologist, Francisco Ayala, makes this significant statement: the goal of science is the systematic organization of knowledge about the universe on the basis of explanatory principles that are genuinely testable. The reappraisal of values is characteristic not only of modern biology. Idealism is being subjected to devastating criticism in many works on the physiology of higher nervous activity, on neuropsychology, neurophysiology, etc. Contrary to idealistic theories of knowledge, the latest investigations in biology and psychology provide convincing evidence that human thinking is not entirely autonomous. Viewed from both the psychological and epistemological angles, it represents the ability of highly organized living systems to reflect, i.e. to cognize, the external world and themselves. How does this materialistic tendency reveal itself in the modern philosophy of science? Several trends are in evidence here. The beaten track for the adherents of this philosophy is to restrict the problem of objectivity to the problem of observation and accumulation of empirical data. Since the observation of intimate biological processes is identified by many scientists with the analysis of their physical manifestations, their materialism not infrequently borders on physicalism. When it comes to the analysis of new phenomena, particularly in biology, psychology, and sociology, the researchers seek in the first place to trace them to the operation of physical or chemical mechanisms. Naturally enough, it is the only way to transfer many biological, psychological, social, demographic, and other processes to the sphere of the observable. Carnap writes that the physical language is universal. This is the thesis of physicalism. If the physical language on the grounds of its universality were adopted as the system language of science, all science would become physics. The various domains of science would become parts of unified science. According to Carnap, the laws of psychology are special cases of physical laws holding in inorganic physics as well. Identifying all materialism with its mechanistic trend, Carnap believes that the materialist system corresponds to the viewpoint of the empirical sciences, since in this system all concepts are reduced to the physical. It is common knowledge that molecular genetics and molecular biology owe their achievements to modern physics and chemistry. Physico-chemical investigations have enabled scientists to make the greatest discoveries in modern genetics, to reveal the molecular structure of DNA as the carrier of genetic information and to define the role of nucleic acids, their molecular and submolecular structures, in heredity. These epoch-making achievements of molecular genetics and molecular biology have given a new impetus to the mechanistic doctrine and mechanistic reductionism, according to which all life processes and properties of living organisms, as well as the origin and evolution of living matter, can be explained with the help of physico-chemical investigations of microstructures and microprocesses in living organisms. The history of science shows that the ideas stimulating scientific investigations in their initial stage do not always prove beneficial for the subsequent progress of science. The inception of molecular biology was indeed marked by the influence of the physicalist paradigm. Noting this fact, E. N. Lightfoot, however, seeks to perpetuate it. In his opinion, the investigations in molecular biology have been based on the view that living organisms are subjected to the same laws as inanimate objects and can be denoted by terms corresponding to these laws. Now, says Eyre, he holds the same view, though on a higher level of complexity and comprehension. This mechanistic approach has been expressed in a most uncompromising form by the discoverers of the molecular structure of DNA, John Watson and Francis Crick. In one of his lectures in 1966, Crick declared that the ultimate goal of the modern development of biology was explanation of all biological phenomena on the basis of achievements in physical and chemical sciences. In his opinion, there were very good reasons for that. The revolution in physics in the mid-1920s provided a solid theoretical basis for chemistry and for the corresponding departments of physics. According to Crick, it would not be presumptuous to assert that the quantum theory and the available empirical knowledge in chemistry provide at present a no less reliable foundation for the construction of biological science. Crick's reference to quantum rather than to classical mechanics is indicative of a new trend in the modern doctrine of physicalism. Nevertheless, the essence of this doctrine does not change as before. It represents a tendency to express biological phenomena, processes and laws in the physico-chemical language. Taking exception to organicism and holism, one of the representatives of this trend, Jacques Monod, writes, "Some philosophical schools are known to contest the significance of analytical approach to such complex systems as living beings. According to these schools, which rise from ashes like phoenix with every new generation, the analytical approach, qualified as reductionist, has always been sterile, since it tends to reduce, purely and simply, the properties of extremely complex organizations to a mechanical aggregate of the properties of their parts. Harmful and useless is any argument with holists which testifies to nothing but their utter ignorance regarding the scientific method and the essential part played in it by analysis." Monod also rejects the general theory of systems and any dialectical description of living organisms. According to Monod, the cell is indeed a machine which defies any dialectical description. In its essence it is not Hegelian, but Cartesian. According to Kenneth Schaffner, regarded to be a typical representative of modern mechanistic reductionism and physicalism, the discovery of Watson and Crick also contributes to a general development towards a complete chemical explanation of biological organisms and processes, and substantiates the view that genetics, and other biological sciences, are reduced to physics and chemistry. It is noteworthy, however, that while repeating the familiar propositions of radical mechanistic reductionism in relation to living organisms and biological science, Schaffner is forced to make reservations after each of his statements, thereby confirming the irreducibility of biological phenomena to physico-chemical ones. Schaffner's views are apparently anti-vitalistic and anti-idealistic. He cannot but admit qualitative distinctions between the living organisms and the dead nature, yet he persists in his mechanistic reductionism as he sees no alternative to it except for the idealistic doctrine which he does not accept. The crisis of biological chemism and mechanistic reductionism in modern biology is at the same time the crisis of neopositivistic physicalism, the logico-empirical analysis of science, whose representatives from Otto Neurath, Rudolf Carnap, and Percy W. Bridgman to Rudolf B. Braithwaite, M. Brodbeck and Carl G. Hempel have invariably pursued one and the same aim, viz. To reduce the biological to the physical. Until recently, the neopositivistic philosophy of science was predominantly the philosophy of physics and made no serious attempts to apply its logico-empirical analysis to biology. However, the gap has started filling up. The most important contribution in this direction appears to be Michael Ruse's book The Philosophy of Biology, which is remarkable, for one, in that it convincingly shows the difficulties facing the positivists in their attempts to apply the logico-empirical analysis of science, i.e. physical reductionism, to biology. Ruse is out to prove that such application is possible. He stresses, for instance, that there are now no theoretical barriers in the way of an Hegelian-type reduction and that there are obvious signposts about how this should be done, as that such a reduction has been rigorously accomplished. It is only after this development that the physico-chemical and the biological came into harmony, opening the way for a reduction, or at least, for a possible reduction. Ruse obviously strives for a consistent implementation of the logico-empiricist, i.e. positivist, approach to the present problems of biology and to the future of biological science. At the same time, he is aware of the appeal of organicism to the biologists and admits that many branches of biological science, such as systematics and paleontology, seek to develop their own theories, genuinely biological, without resorting to molecular biological, i.e. essentially physical, explanations. He regards such trends as transient phenomena and expresses a hope that biology would ultimately take the course of reductionism and translate its theories into the language of physics and chemistry. In his opinion, the existing state of affairs can only be explained by the stubborn reluctance of prominent modern biologists to join the new school of molecular biological reductionism. In positivist philosophy, empiricism as the criterion of the objectivity of knowledge is inseparably linked with reductionism. Epistemological reductionism, tending to reduce all scientific knowledge to its empirical basis, was supplemented by theoretical reductionism, which revealed itself in persistent attempts to translate all the wealth of accumulated knowledge together with its theoretical explanations in the language of physics. From the viewpoint of logic, this transition is understandable. The laws of physics permit experimental checks of theoretical propositions, making them testable. Hence, theoretical reductionism leads to and finds its logical expression in physicalism. The language used in the description of physical objects appears to be natural, too, since it is the first language of man starting to master the external world. The type of experience expressed in this language precedes chronologically, psychologically, and even logically other types expressed in other languages, the phenomenological one inclusive. The fallacy of this stand is not hard to expose. The perception of physical objects by man at an early stage of his development is indeed natural and goes side by side with the mastery of the physical world. Yet this experience in the child's development is preceded by more primitive forms of perception, such as the perceptions of colors, smells and tastes, which are very different with the infant from modern physical notions. Besides, the development of man does not stop at perceptions, and his growing knowledge of the external world extending to the animal kingdom, thinking and psychological processes, the sphere of social phenomena such as the relations of production, freedom, solidarity, etc., can by no means be squeezed into the physicalist paradigm. Seeking to substantiate their doctrine, the adepts of physicalism also refer to the intersubjectivity of the language of observable physical phenomena as its characteristic feature. In their opinion, this feature accounts for the fact that it is much easier to ascertain the objectivity of one or another scientific proposition through physical reduction than through phenomenalistic analysis. Hence, they make the objectivity of knowledge contingent on the possibility of its intersubjective expression, i.e. on the community of notions and their usability with different people and different scientific quarters. In turn, intersubjectivity is made contingent on the possibility of reducing this knowledge to physical terms. Such a concept of the objectivity of knowledge is far removed from the materialistic concept identifying objectivity with independence from man and his consciousness in general, particularly if we take into account that most physical terms except those testable by direct sensory experience are considered conventional. True, the language of physics provides a basis for intersubjective certainty in the sense that it does not deal with abstract sensory data or even perceptions, but reflects universal or general, recurrent, stable, and therefore regularly observable phenomena, which is in full accord with the requirements of scientific cognition. Yet the requirements of universality and recurrence, being important as they are, do not yet ensure the objectivity of knowledge. Such physicalist views suggest the idea that intersubjectivity is characteristic not only of objects under observation, but of the observations themselves. Hence, they may be considered final in the analysis of epistemological problems. Here is, so to speak, a feedback link from theoretical reductionism back to epistemological reductionism. One strengthens the other. Yet all observations, no matter how complete they may be and whatever their objects, remain, from the standpoint of the theory of knowledge, the perceptions of individuals. The language of physics is incapable of providing the intersubjective basis for science in general and for scientific epistemology, in particular, if only for the fact that it constitutes a smaller part of our language and that the perceptions of physical facts are not more important. Indeed, they can sometimes be even less important than the perceptions of biological or psychological phenomena, since the perception of the physical world is inconceivable outside the human brain. Another weakness of the physicalist program, which becomes ever more obvious with the advance of science, ensues from the growing differentiation of physical science itself. A question, naturally, arises: where is the limit of the reduction process? Do we have to reduce biological, psychical, and social phenomena to the physics of the macro world? Or to molecular physics chemistry? Or to the atomic level? Suppose we adopt the physicalist doctrine and stop at the atomic level. But what about the future? What if the world of the electron or some other elementary particle indeed opens into infinity? One can only be sorry for a philosophy which will attempt to shut the door in the face of a new generation of scientists. Expounding some of the weaknesses of the physicalist doctrine mentioned above, many philosophers propose, in fact, to go back where positivism has started. All their ardent criticism thus turns out to be merely aimed at reinstating the phenomenologic approach. Yet the unsuccessful attempts to reduce the mental to the physical, the biological to the chemical, the theoretical to the empirical, etc. do not mean that biology is doomed to stay forever in the cradle and content itself with exclusively empirical approach. Nor does it mean that the irreducible residue of biology which could not be rationalized by physics and made part of respectable science should always remain purely empirical. The dialectical synthesis of the achievements of phenomenological analysis, be it in biology, psychology, social sciences, or elsewhere, with the results of consistent and rational reduction is the only path to a new theory, a new theoretical fundamental discipline destined to turn biology, sociology, etc. into independent sciences which will not confine themselves, on the one hand, to the superficial description of phenomena, too specific in their external manifestations to be reduced to coarse physical terms, and will not dissolve, on the other hand, in physical notions degrading to a commonplace. There has been growing evidence of late that biology, psychology, sociology, and other specific sciences are beginning to turn onto this path and gain independence not as primitive phenomenological schools, but as full-fledged scientific disciplines. Darwin's phenomenological theory synthesized with the achievements of molecular biology and genetics exemplifies a solution to the dilemma of reductionism or organicism. The same path is evidently being taken now by the modern theory of knowledge despite the predictions of epistemological reductionism. It is emerging as a product of integration of general epistemological concepts with the results of specific investigations into the nature of consciousness as such, on the one hand, and into the neurophysiological mechanisms of conscious and unconscious activity, on the other. In its advancement, new scientific epistemology is casting off both the phenomenological fetters and the physicalist dogmas. Objective Knowledge and Critical Rationalism. By Igor Naletov. Since the 1920s, When Karl Popper proclaimed his principle of falsification as the basis for the testability of knowledge and for distinguishing between scientific propositions and pseudoscience, he has invariably criticized positivist philosophy and its understanding of objectivity as the observability of events. His arguments against empiricism are serious enough. Popper maintains, first, that observation is always based on some theoretical premises and that scientific knowledge, contrary to the positivists, does not start with sensory data. Hence, the objectivity of knowledge cannot be identified with the observability of events. Second, the traditional problem of inductive conclusion regarded by empiricism as the principal argument in favor of the objectivity of a theory is rooted in Hume's error regarding the nature of the scientific method. However, the true significance of this criticism can only be assessed in the light of Popper's positive program. It may appear at first sight that the principles of his epistemology are indeed radically different from those of positivism. Knowledge, according to Popper, cannot start from nothing, from a tabula rasa, not yet from observation. Science, philosophy, rational thought, must all start from common sense. Yet the main principle of common sense is the faith in the existence of the real world. Realism, which asserts the existence of the world outside and independent of its perception, cannot, in Popper's opinion, be proved or disproved. In other words, it belongs to the sphere of metaphysics. Realism should be accepted as the only sensible hypothesis, as a conjecture to which no sensible alternative has ever been offered. Popper's realism, however, has little in common with scientific realism or scientific materialism, particularly in the understanding of objectivity. In Popper's opinion, shared also by enlightened common sense, realism should be at least tentatively pluralistic. A rationalist seeks to reduce all the diversity of the world to several fundamental entities or processes. In Popper's words, Occam's razor can only be applied after recognizing the plurality of what there is in the world. As has been indicated earlier, Popper distinguishes three autonomous and relatively independent worlds, noting that the term world is conventional and that there may be different criteria for their classification. The first world is physical reality, the second world the subjective knowledge of an individual, and the third world, objective knowledge as understood by Popper. My first thesis, Popper writes, involves the existence of two different senses of knowledge or of thought, knowledge or thought in the subjective sense, consisting of a state of consciousness or a disposition to behave or to react, and knowledge or thought in an objective sense, consisting of problems, theories, and arguments as such. Knowledge in this objective sense is totally independent of anybody's claim to know, it is also independent of anybody's belief, or disposition to assent, or to assert, or to act. Knowledge in the objective sense is knowledge without a knower, it is knowledge without a knowing subject. The elements of the third world comprise, according to Popper, not only theories and ideas, but also problems or problem situations. By analogy with physical states, he also qualifies as the third world's elements the states of discussion or the states of critical arguments, as well as information carriers, i.e. books, magazines, libraries, etc. It is indicative in itself that Popper's evolution has brought him to the recognition of the existence of the physical world. Yet the sequence of the worlds as listed above by Popper does not correspond to their significance in Popper's logic of science. It is not at all the physical world occupying the first place on Popper's list that constitutes the essence of scientific knowledge. Nor is the second world, i.e. the world of emotions, sensations, and individual knowledge, of any great significance. In Popper's opinion, it is just because of its exclusive interest in the subjective knowledge as expressed in everyday phrases "I know" or "I am thinking" that traditional epistemology has lost its influence. It was concerned with what was not, in fact, scientific knowledge. Popper writes, "For scientific knowledge simply is not knowledge in the sense of the ordinary usage of the words I know. While knowledge in the sense of I know belongs to what I call the second world, the world of subjects, scientific knowledge belongs to the third world, to the world of objective theories, objective problems, and objective arguments. Hence, the third world or world 3 alone is truly autonomous and objective. From the epistemological viewpoint, this thesis does not offer any new solutions. It only counters empiricism in that it eliminates the question of the source of knowledge, as the logic of scientific discovery, which is the core of Popper's entire epistemology, has no place for such question. It lies on the other side of the line of demarcation drawn by Popper between science and metaphysics. Yet even within the narrow limits of the logico-theoretical model of knowledge, the concept of the third world gives rise to serious contradictions. If we analyze the relation of the third world to a concrete discovery or theory, we are bound to answer at least two questions. First, which element of our knowledge and at what stage of its maturity is regarded as the initial one? Second, which elements in a given discovery or theory can be confirmed or disproved by an experiment? Popper gives in fact no answer to the second question. As regards the first one, the answer is as follows: the selection of the initial, basic propositions is a conventional one. Popper does not deny the connection of basic propositions with experience. In the logic of scientific discovery, he writes that a decision to adopt a basic proposition is not prompted by our sense perceptions. According to Popper, experience can only motivate a decision to adopt a proposition or reject it, but any attempt to trace basic propositions to perceptions will prove completely futile. Hence, despite Popper's resolute opposition to empiricism, his concept reveals curious likeness to logical positivism in at least two respects. First, Popper strives to confine the subject matter of epistemology to purely logical problems and to dismiss some problems of general significance. Second, like the representatives of the Vienna school, Popper is forced to resort to conventionalism as regards the origin of basic propositions. In point of fact, he replaces the conventionalism from above characteristic of logical positivism by conventionalism from below. His conventionalism stems from deeply rooted logicism, which manifested itself already in his early works by the rejection of philosophical and sociological problems of science. Understandably, Popper's basic propositions do not relate to current individual experience, but reflect the system of established knowledge. His concept has not gone beyond a slight displacement of the border between our knowledge and the material world. All we know from Popper about our relation to this world is that our knowledge exerts active influence upon it. He sidesteps the question of the primacy in this interaction, which is embarrassing to both the positivist and Popperian epistemology and constitutes the key issue of the theory of knowledge. According to Popper, the third world emerged as a result of the spontaneous activity of man, and this is just what accounts for its objectivity. The unpremeditated build-up of knowledge by man is akin to the spinning of a web by a spider or to the making of honey by a bee. And I assert, writes Popper, that even though this third world is a human product, there are many theories in themselves and arguments in themselves and problem situations in themselves which have never been produced or understood and may never be produced or understood by men. Such theories and problem situations, according to Popper, do not appear according to plan. They are not even needed before their emergence. Once they have made their appearance, however, they may create new problems or a new system of ideas. The objectivity of a theory is understood by Popper as its independence from individual consciousness. In order to substantiate his viewpoint, he concentrates, first and foremost, on the problem of the acceptance and understanding of scientific discoveries. It should be noted that this problem is not alien to Marxist philosophy either. It has long since been the object of serious discussions in Soviet literature relative to concrete dialectical issues. The true meaning of ideas, theories, and projects is indeed often realized by scientists long after the corresponding discovery or invention is made. This fact, characteristic of one of the aspects of objectivity, is not regarded by Popper as something requiring any special attention. Actually, however, the gradual realization and acceptance of a discovery is nothing but the result of the objectivity of knowledge understood as the reflection of objective processes, i.e. as a fact which can only be explained through the analysis of social factors influencing the development of science and its relation to the material world. Ideas, theories, and other components of social consciousness are indeed relatively autonomous and independent of individual consciousness. The existence of the theory of relativity or Darwin's theory of evolution does not depend on anyone's consciousness. Moreover, we can go even so far as to assert that it was not Einstein or Darwin who had to decide on whether their theories were to be or not to be. These theories were bound to appear, and not at the scientist's wish or by force of coincidence, but mainly because they reflected the objective processes of reality. Besides, to understand the inevitability of these discoveries, one ought to take into account the general laws of scientific development determined in the end by practical needs. Hence, the correct statement of the problem of objectivity is the following: what is the objective content of scientific theories and what are their subjective elements? Frankly speaking, Popper's analysis of a scientific theory cannot boast of subtlety. Knowledge is construed as both a process of cognition and a result thereof, embodied in various theories, ideas, and problems. In Popper's opinion, however, the process of thinking lies outside the concept of scientific knowledge, which should be mainly understood as the product of this process, i.e. as theories and their logical relations. The process of thinking is always individual and subjective, whereas its general results, i.e. problems, ideas, and theories are objective. In Popper's opinion, the incompatibility of certain theories is a logical fact which is absolutely irrelevant to whether somebody is aware of it or not. These purely objective logical relations are the characteristic features of entities which are called by Popper theories or knowledge in the objective sense of the word. Should we defy Popper's scheme, overstep the boundary set by him and consider the connection between scientific knowledge and material reality in all details, i.e. in the process, sum, tendency, origin, we shall find out that there is no sharp line of demarcation between the knowledge of an individual and the system of scientific knowledge developed by mankind. They differ, as it were, by the objective/subjective ratios. Hence, both the thinking processes and their results deserve special philosophical analysis. The electromagnetic theory as developed by James Maxwell was evidently just as much indicative of its author's subjective demerits, as were his mental processes, notions and ideas. To be sure, science cannot be too tolerant. The amendments made by Heinrich Hertz and Oliver Heaviside, as well as the subsequent elaboration of the electromagnetic theory in the light of the theory of relativity and quantum mechanics, have corrected a number of Maxwell's errors. Yet it is not criticism or mutual rational verification which guarantees, according to Popper, the objectivity of the electromagnetic theory. Such criticism can at best eliminate some subjective imperfections, thereby helping to reveal the objective content of the theory. It does not mean at all that a scientific theory owes its objectivity exclusively to criticism and falsification of erroneous conclusions. Despite the proclaimed objectivity of the third world, Popper fails to provide an appropriate substantiation for this thesis. His objectivity can only be defined by comparison with individual experience, and the criterion of the testability of theories is, in fact, intersubjective by nature. Popper himself makes no bones about his stand when he writes, "Now I hold that scientific theories are never fully justifiable or verifiable, but that they are nevertheless testable. I shall therefore say that the objectivity of scientific statements lies in the fact that they can be intersubjectively tested. Intersubjective testing need not go beyond a mutual rational control, which is the common objective of critical discussions. Such rational control, according to Popper, is only possible through multiple checks and repeated comparisons with the obvious. No observations should be taken into account if they cannot be repeated and checked. Such repetitions alone can provide sufficient evidence that we deal not with accidental coincidences, but with events which are intersubjectively testable owing to their recurrence." In other words, the objective world as defined in Popper's epistemological scheme is mainly referred to by scientists for falsification of one or another theory. According to Popper, the essence of scientific activity, its distinguishing feature, consists in systematic attempts to refute ideas, hypotheses, and theories which are being advanced, and in eliminating errors. The tests should result in the selection of a hypothesis which is more resistant to criticism than other hypotheses. In other words, all tests should aim at finding weak points and eliminating untenable theories by their falsification. But just because it is our aim to establish theories as well as we can, writes Popper, we must test them as severely as we can. This is the reason why the discovery of instances which confirm a theory means very little if we have not tried, and failed, to discover refutations. Yet Popper overlooks the fact that every experiment tests not only a theory as such, but also a host of its logical and non-logical premises. All of them participate in the interpretation of an experiment in one way or another. Therefore, if an experiment testifies against a theory, we can never be sure whether the falsification applies to the theory itself, or to the attending premises. The conclusion that an experiment falsifies a theory is purely conventional. Any theory can be saved by introducing additional premises or by modifying the basic ones. Realizing the contradictory nature of the situation, Popper offers, on purely conventional grounds, to adopt a postulate prohibiting the introduction of hypotheses intended to protect a theory against a death sentence. Consequently, in Popper's opinion, theories and ideas must become the objects of merciless falsification. The refutation of theories becomes for scientific cognition the end in itself. In accordance with his model of scientific cognition, Popper contends that not a single scientist can claim the truth of his ideas and theories. Scientists act, he writes, on the basis of a guess or, if you like, of a subjective belief concerning what is promising of impending growth in the third world of objective knowledge. In developing their research programs, scientists, according to Popper, are guided by their conjectures as regards which trend is likely to be the most fruitful in the third world. A scientist therefore must once and for all discard the self-confident "I know" or "I suppose." Since his individual notions are inevitably subjective, he has but very modest rights which only entitle him to say, "I am trying to understand a problem, I am trying to think of alternatives to this problem, I am thinking of an experimental check for the given theory, I am trying to axiomize the theory," and the like. According to Popper, the worlds are real if they can interact with the physical world, and they are autonomous if their irreducibility to one another is postulated. The main problem of his pluralistic philosophy hinges upon the relations between the worlds. Of the three worlds, the two first and the two last ones can directly interact. The second world, the world of individual experience, subjective knowledge, can interact with the two other worlds, but the physical world and the world of knowledge cannot directly contact each other in a similar manner, they have to use the mediation of the second world. In principle, it is possible to assume the reducibility of the mental world to the physical world, but the existence of objective knowledge, its obvious influence on the physical world, on the one hand, and the no less obvious impossibility of the direct causal effect of abstract entities on physical processes, on the other, force the inevitable conclusion about the plurality of the worlds and the autonomy of the mental as the necessary mediator between the physical and the ideal. One of the important functions of the second world is to comprehend the objects of the third world, i.e. the objective content of thinking. Almost all subjective knowledge depends on objective knowledge. The third world is autonomous, though we constantly act upon it and are subjected to its influence. Cognition is traditionally defined as the activity of a cognizing subject. Popper holds that this definition is only applicable to subjective cognition, which should better be called organic cognition, as it consists of certain inborn dispositions to act, and of their acquired modifications. Objective cognition does not depend on the cognitive aims, opinions, and actions of the cognizing individual. Cognition in the objective sense is cognition without the cognizing individual. Objective knowledge consists of the logical content of scientific theories, conjectures, suppositions, and logical content of their genetic code. Objective knowledge can be exemplified by scientific theories expounded in journals and books, discussions of these theories, as well as by problems, problem situations, etc. From the viewpoint of traditional subjectivist epistemology, the third world can only exist as the content of some consciousness. For instance, a book only exists as a factor of culture if somebody reads it. A book remains a book even if it is a table of logarithms composed by a computer and not written by any man. A book belongs to the third world provided it can be understood and deciphered even if such a possibility is never translated into reality. In Popper's opinion, Plato was the first philosopher who discovered the existence of the third world, its influence upon us, and began to use the ideas of the third world to explain the phenomena of the first and second worlds. The history of epistemology knows a far more influential tradition than the one Popper claims to represent. Epistemological subjectivism, like its antagonist, ontological realism, are both rooted in common sense. The everyday concept of knowledge rests on the conviction that sensory data are the source of knowledge. In philosophy, this concept is known as the theory of tabula rasa. It underlies Locke's, Berkeley's, and Hume's empiricism, as well as many theories of modern positivists and empiricists. Traditional non-critical rationalism, contrasting itself to empiricism and subjectivism, has also proved unable to overstep the bounds of common sense. The subjectivist theory of knowledge is incapable of distinguishing between subjective and objective knowledge. In its attempts to disclose the process of scientific cognition, traditional epistemology proceeded either from sense data, or from the self-consciousness of a cognizing individual, remaining in both cases within the narrow confines of subjective knowledge. Naturally enough, it could not understand it either, since the comprehension of the second world is only possible from the positions of the third world. According to Popper, the theory of knowledge of common sense is almost entirely false, yet its main error consists in the search for a self-evident starting point of the process of cognition. Classical epistemology was incapable of understanding that sensory data were nothing but adaptive reactions of an organism. The organs of sense, such as the eyes, are not indiscriminate in their perception of the surrounding world, they take in only those events which are being expected, and no others. Like theories, they must be indifferent to other events which they do not perceive and cannot interpret. Any sensuously perceived material, according to Popper, is already an interpretation based on a theory or on prejudice. There can be no pure sensory experience, just as there can be no pure language of observation. All languages are full of myths and theories. Rejecting epistemological reductionism, Popper also comes out against ontological reductionism. Criticizing physicalism as a variety of radical materialism, Popper alleges that the latter is incapable of explaining the qualitative diversity of reality. In his opinion, materialism could have had some sense before the appearance of life on the earth. After that, owing to the development of human culture and self-reflection of man, physicalist explanations lost their universality. As man has created a new objective world, the world of the products of the human mind, a world of myths, of fairy tales and scientific theories, of poetry and art and music, the emergent, creative nature of the universe becomes, in his opinion, quite obvious. All the three worlds, according to Popper, are real. Speaking of the reality of World 1, Popper agrees with the physicalist materialists that notions used by a physicist, such as fields, forces, quanta, etc., refer to real entities. Yet, in his opinion, traditional materialism with its paradigm of reality in the form of solid material bodies is closer to the truth. He shares the viewpoint of common sense that physical entities are just as real as consciousness understood as subjective mental process, as well as the content of consciousness embodied in culture. The central point of Popper's concept is his assertion of reality and the relative independence of World 3, the world of the products of human spirit such as legends, explanatory myths, instruments of knowledge, scientific theories, scientific problems, social institutions, and works of art. It is noteworthy that Popper links the existence of the objects of World 3 with the embodiment of the products of human intellect in books, sculptures, etc. However, the mere objectification of these phenomena in material culture and in the systems of science does not yet testify to their independence. Popper's crucial argument in favor of the autonomy of World 3 consists in that the development of theories and ideas follows their own laws and they produce consequences which cannot be foreseen by their creators. Being ideal as they can also give rise to material effects. For instance, they can induce people to produce their own kind and other ideal objects, thereby exercising influence on World 1. All civilization, according to Popper, can be regarded as the realization of man's aims, ideals and plans, i.e. the objects of World 3. The distinction of Popper's concept from physicalist theories stands out quite clearly here. He refuses to substitute the epistemological problems of the correlation of the mentalist and physicalist languages for ontological problems, seeks to deduce the qualitative diversity of the external world from reality and posits the problem of consciousness in the context of cosmic and cultural evolution. On the other hand, Popper reveals no less clearly the inadequacy of his understanding of the interdependence of the subjective and the objective consciousness. The concept of autonomous World 3 gives grounds for a supposition that the emergence of new ideas is determined by logical possibilities which have already materialized in the objects of this world, i.e. in theories, problem situations, etc. In that case, ideas and theories must have ideal existence even before they enter individual consciousness, and the task of the subjective spirit must consist in provoking the realization of ideal possibilities lying dormant in human culture, i.e. in translating possibility into reality. More, if we assume that the activity of the subjective spirit is confined merely to grasping and manipulating the objects of World 3, we are bound to deny the spontaneous creative activity of human consciousness and to admit that individual consciousness and new ideas are products of culture, but not of concrete individuals. Popper is evidently not completely unaware of this Platonic tendency in his concept and therefore lays special emphasis on the genetic biological foundation of consciousness and knowledge. Denouncing the philosophy of neopositivism, particularly its claim to the role of the methodology of modern scientific cognition, Popper in fact offers an idealistic epistemological alternative. To substantiate his understanding of the progress of scientific cognition, Popper introduces a concept of verisimilitude. In his opinion, the verisimilitude of a theory consists in the superiority of a multitude of true logical consequences of this theory over a multitude of false logical consequences. From this viewpoint, of crucial importance is the content of a theory. It includes a class of all logical consequences, both true and false. Popper intends to divide the system, evidently infinite, into two subclasses, the true and the false consequences of the given theory, and to discard successively those which themselves ensue from false consequences. It should be noted that the very notion of logical consequence is not used by Popper with due accuracy. Individual statements, some of which are based on or expressed in theories, evidently have no consequences at all. A consequence is only possible in situations where certain initial conditions are indicated. In that case, however, the number of consequences will be equal to the number of statements contained in the description of initial conditions. Most of them will probably turn out to be false in the strictly logical sense of the word, since the accuracy possible under experimental conditions can hardly compare with the accuracy of mathematical operations associated by Popper with the notions of truth and objectivity. Besides, in a situation with the infinite number of consequences, there will be only 2 degrees of verisimilitude, the maximum and the 0 one, depending on whether the true content is infinite and the false content is finite, or both of them are infinite. The vulnerability of Popper's concept of verisimilitude is noted, for instance, by American philosopher G.S. Robinson, who writes, "If scientists were to take Popper's conception of verisimilitude and progress seriously, it would have the effect of stultifying growth and progress, because what he calls verisimilitude and progress could be increased or even maximized by a policy of incurious repetition of safe experiments." Contrary to Popper, scientists do distinguish between theories and predictions ensuing from them, considering some of them truer than others. For instance, planning a flight to Venus, they are sure that the theory of relativity is more reliable than the theory of Newton, Ptolemy, or Aristotle, and that the predictions based on the former must be more accurate than those based on the latter. Of course, scientists may err in their judgments of relative probability. Their inductive criterion of truth may sometimes fail them. Yet they do use it and rely on one theory more than upon another. If Popper refuses to admit that we can and must express judgments on comparative probability based on an inductive conclusion, his theory of verisimilitude and progress proves untenable. If the predictions of an old theory have turned out false and the predictions of a new theory have turned out true, it is obvious that the new theory is closer to the truth than the old one. It stands to reason that a scientific theory owes its reputation for dependability to a successful experimental or practical test. Why, then, is its rational confirmation not possible? If any and every failure to fit were ground for theory rejection, Thomas Kuhn justly observes, all theories ought to be rejected at all times. On the other hand, if only severe failure to fit justifies theory rejection, then the Popperians will require some criterion of improbability or of degree of falsification. In developing one, they will almost certainly encounter the same network of difficulties that has haunted the advocates of the various probabilistic verification theories. 3. From Physicalism to Scientific Materialism. By Igor Naletov. The turn from positivism to scientific realism is very characteristic of the modern philosophy of science. This trend, which is only 2 decades old, has already managed to define its stand with sufficient clarity despite all the diversity of the individual approaches and opinions of its adherents. However, none of the current views of scientific realism as a methodological alternative to positivist philosophy is ripe enough to claim authority. Representing the materialistic viewpoint, scientific realism somehow falls out of line with the general historical trend of philosophical development and seems rather odd because of its apparent spontaneity. Indeed, in its attempt to evolve a new philosophical doctrine, scientific realism has started from scratch and is denying or passing over in silence any affinity with traditional philosophical trends. This is partly attributable to the fact that many of the newly converted active exponents of materialistic ideas reflect the direct needs of science rather than some purely philosophical tradition. It cannot be said, however, that new materialism is completely free from any philosophical links in general. The new school, for one, admits in some form or other to its inheritance of certain aspects, problems, and principles from positivist philosophy. Scientific realism represents an obvious attempt to smooth over the contradictions which have led to a complete break of science with positivist philosophy. This feature also accounts for the attitude of scientific realism to the problem of the objectivity of knowledge. On the one hand, the new trend discards the positivist interpretation of objective knowledge, including its latest versions. On the other, it shows an obvious influence of many positivist dogmas. Coming out against the concept of intersubjectivity, most of the realists oppose both the positivist and Popper's doctrines. Neither do they accept the Kuhn-Lakatos concept as manifestly relativistic. Yet they do not go beyond postulating reality independent of man and sidestep the main issue, the concrete solution of the question of the nature of objectivity and relationship between the objective and the subjective in scientific knowledge. This circumstance essentially weakens the position of scientific realism, exposing it to criticism on the part of its opponents. The realist, writes, for instance, Roger Trigg, starting from objective reality rather than man's knowledge of it, will not be surprised if some portions of it elude man's grasp forever. He will insist that though this limits man's knowledge, it cannot affect the nature of what exists, since reality is self-subsistent. As regards the problem of intersubjectivity, the realists maintain that the presence of some common elements in different theories is accounted for by none other than reality, whether perceptible or not. Some realists go even as far as distinguishing between the ontological and the epistemological aspects of the problem, i.e. between reality as such and the reality that we know. According to Roy Bhaskar, for instance, the positivists make a typical epistemological error considering that statements about being can be reduced to or analyzed in terms of statements about knowledge, i.e. that ontological questions can always be transposed into epistemological terms. Many adherents of the realistic trend, however, believe that ontological realism should be supplemented with epistemological relativism. This opinion is based on the well-known thesis according to which we are incapable of going beyond the limits of the particular, the concrete, i.e. the knowledge available at a given moment, though we are aware of the existence of being. In Boscar's opinion, whenever we speak of things or of events etc. in science, we must always speak of them and know them under particular descriptions, descriptions which will always be to a greater or lesser extent theoretically determined, which are not neutral reflections of a given world. Epistemological relativism, in this sense, is the handmaiden of ontological realism and must be accepted. The confusion regarding the relationship between ontology and epistemology, the objective and the subjective, sometimes leads the realists to counterposing realistic and materialistic viewpoints. A distinction between them does exist, of course, but its actual significance, in the realists' /thin space opinion, evidently lies elsewhere. Trigg contends that realism represents a broader viewpoint than materialism, as it permits accepting the reality of what is not material. Even a theist, he writes, can assert a realist notion of God existing independently of men's conceptions of him, and not espouse idealism, because he also accepts the independent reality of the material world. Realism and materialism, according to Trigg, are different in the sense that realism pretends to be a neutral doctrine taking no interest in the content of reality. In Trigg's opinion, many idealistic trends insist only on the independence of reality from human consciousness or sensations and do not accept the existence of God, whereas numerous forms of empiricism could be anti-realistic and atheistic at the same time. According to Trigg, the controversy between realists and anti-realists was of crucial importance for philosophy. Realism opposes the doctrine which accepts the dependence of the external world on man and restricts the world to what man knows about it. Is the world indeed what we take it for? Asks Trigg, and answers emphatically, no. There may exist galaxies we cannot even conceive of. Besides, many of our scientific beliefs are probably wrong. It is exceedingly rash, he says, to equate reality with the views we happen to have at the moment. In a sense, reality is considered to be mental rather than material, as the reason which comprehends it simultaneously creates it in one way or another. Whereas realism underscores the existence of reality independent of our notions of it, idealism considers everything to be a function of reason and regards being in terms of man's mental images or perceptions. Hence, subjective experience may be in contradiction with what is considered true by general consent. According to Trigg, /thin space subjective can be the opposite of intersubjective rather than objective. To put it another way, the word objective can refer in a weak sense to what is agreed on, rather than in a strong sense to what is really the case. In Trigg's opinion, the anti-realist will prefer to emphasize the necessity for intersubjective agreement. Anti-realists are inevitably forced, if they conceive the problem in terms of the opposition of mind and matter, to admit the independent reality of other minds. Idealism inevitably becomes objectivist even when objectivist is understood in its strong sense. Epistemological realism, according to Trigg, is sometimes distinguished from the ontological sort, so that one can be an epistemological realist and an ontological idealist. In that case, he writes, only minds would exist, but there would be an external world beyond our judgments. What we know would be in no way dependent on our knowing it, but the reality which is the source of knowledge would be ultimately mental. This means that reality is not ultimately independent of judgment as such. It may be unconnected with what you think or what I think, but it is not unconnected with all minds. Trigg asserts that the only alternative to epistemological realism is solipsism. Epistemological realism is the inevitable consequence of accepting that the world is not one's own creation, and that as a result one may be mistaken about its nature. According to Trigg, the principal disagreement between the realists and their opponents springs not so much from the difference in their understanding of the relationship between reality and man in general, as from the distinction between the weak and strong objectivity, between intersubjectivity and objectivity. In Trigg's opinion, one should not identify objectivity with what one believes in here and now. The history of science shows that even the most firmly established theories can be modified or even refuted. Scientific realists generally avoid identifying their stand, even on special issues, such as the mind-body problem, with the concepts of dialectical materialism. Expounding his views, Trigg definitely dissociates himself from materialism, considering its approach too narrow. He strives to justify his prejudice against materialism by alleging that it disregards subjective reality and grants the status of being to matter only. The origin of this prejudice is not far to seek. Trigg, like many Western philosophers who cannot boast of too close an acquaintance with the materialist tradition in philosophy, particularly with the essence of dialectical materialism, equates materialism with physicalism. As a result, Trigg identifies Lenin's views with physicalist concepts widely spread in Western literature, overlooking the fact that it is just against physicalism and its understanding of matter, space, time, and causality that Lenin has directed its main philosophical work, Materialism and Empiric Criticism. The irony of the situation consists in that Trigg, coming out in defense of realism, opens a wide door for fideism and actually sets it on an equal footing with science. As we see, the response of scientists to the disintegration of positivism does not always accord with the needs of scientific cognition. Despite the repeated assurances that he is opposed to idealism and anti-realism, Trigg, in fact, sees no possibility of passing beyond the bounds of experience and language. We cannot, he writes, talk or think about reality without talking or thinking about it. We cannot have a conception of something without employing the conceptual scheme we have at our disposal. We cannot conceptualize reality and then check the concepts we have produced against reality. It is self-defeating to attempt to think of reality as it exists beyond our thoughts. There is no way that we can somehow hold our concepts in suspense, while we compare them with reality. Trigg's realism consists in that he accepts the existence of reality beyond the limits of man's present knowledge, this reality including not only what is not yet known, but also, it appears, what is unknowable in principle. He writes, realists leave open what is to be meant by the world. We have used the term rather broadly to mean what there is. The realist can accept that mind, matter, and even other kinds of entities might exist. His argument with the idealist is not concerned with the reality of mind. He is merely concerned to hold that the mental does not exhaust reality. Trigg draws a purely external line of demarcation between what appears to be two different worlds: the reality which is independent of man and has not yet become the object of his knowledge, and the reality which has already been drawn into the sphere of man's cognitive activity and is no longer independent of his thoughts. Such an external border does not seem to be a good solution, as it makes it impossible to correlate more accurately the objective and subjective realities and investigate their relationship in the second world. As a matter of fact, the same applies to Trigg's first, unattainable, world, since it exists beyond our thoughts and cannot, according to his logic, be extracted from our conceptual scheme by any means. The concept of God, for that matter, can also be regarded as one of the versions of conceptualizing the uncognizable. Dialectical materialism is far from ignoring the reality of the concept of God as an element of religious systems. Moreover, it regards this false concept as a reality which should be eliminated by practical means. Marxism not only admits the reality of religious rites but also takes it in all seriousness. It is obvious to any Marxist that religion is only one of the elements of a highly complex and heterogeneous subjective reality which includes man's entire spiritual world with all its diversity and contradictions. Trigg and other realist authors may rest assured that their intellectual stand as well as the books they publish are real to us in a no lesser degree. Trigg's realism is a graphic illustration of the confusion resulting from the application of loose criteria of objectivity and lack of dialectical flexibility in the philosophical analysis of scientific development. What is more, after such a cultivation, vast areas of terra ignorationis are allowed to lie fallow, grow thick with weeds and spread pseudo-scientific seeds all over the adjacent areas of science and philosophy. These weeds often infect the still healthy field of scientific realism which, according to Trigg, is called upon to give an accurate theoretical description of reality. In Trigg's opinion, a scientist will always aspire for the true knowledge of the world, though not all reality can be accessible for observation. Some theories may be true at all times, others may need modification, yet they all reflect reality to some extent, though we do not know how profoundly. The realist in science, writes Trigg, does not merely oppose the empiricist's view about the pivotal role of observations. He also emphasizes that science is about something and that theories attempt to capture reality as it is. It follows that only one completely correct account of the world is forthcoming. Different, competing theories will each view the world differently, but the realist will not be as content with that situation as Feyerabend seems to be and will want to ask which is the right one. Contrary to Trigg, Quine contends that competing theories of reality do not give a unique and simple picture of the world. Defending all the basic propositions of realism, he writes, "We have no reason to suppose that man's surface irritations even unto eternity admit of any one systematization that is scientifically better or simpler than all possible others. Scientific method is the way to truth, but it affords even in principle no unique definition of truth." Quine also appears to be appreciably closer to positivism in his attachment to the concept of intersubjective test. In his opinion, intersubjective contact assures a single dimension deriving from the similarity of sensuous stimuli. This intersubjective contact provides a basis both for the language of learning and for the construction of a scientific theory. The relevant circumstances attending the utterance of statements are combined by Quine in the notion of intersubjective observability. Intersubjective contact enables the child to learn when to assent to the observation sentence. And it is this also, intersubjective observability at the time, that qualifies observation sentences as checkpoints for scientific theory. Observation sentences state the evidence, to which all witnesses must accede. According to Quine, this rules out solipsism, since the general accessibility of circumstances attending the utterance of observation statements ensures that we learn one and the same language and that a scientific theory may have a solid foundation. The leaning towards realism gets the better of Quine in his concept of self-sufficient reality, though he underscores that true judgments can only be made after the adoption of a theory. It causes him, like Feyerabend, to regard theories as being relatively true, but here Quine escapes relativism characteristic of Feyerabend. Any statements, in his opinion, can only be made within the framework of a conceptual scheme and serve as its expression. As a result, no reality is conceivable except through a conceptual scheme which we ourselves adopt. Hence, the real world which does exist must be described in terms of our conceptual scheme. Quine avoids speaking of things in themselves or of any philosophical interpretation of scientific propositions. In his understanding, a scientific theory is something taken at its face value. As an empiricist, Quine says, "I continue to think of the conceptual scheme of science as a tool, ultimately, for predicting future experience in the light of past experience. Physical objects are conceptually imported into the situation as convenient intermediaries, not by definition in terms of experience, but simply as irreducible posits comparable, epistemologically, to the gods of Homer. For my part I do, quale physicist, believe in physical objects and not in Homer's gods, and I consider it a scientific error to believe otherwise. But in point of epistemological footing the physical objects and the gods differ only in degree and not in kind." Quine, thus, refuses to admit that there is any difference between the posits of a theory and reality. In his opinion, reality is what we believe to be existing. It is significant, however, that physicalism remains a characteristic feature of scientific realism and its understanding of the problem of objectivity. This circumstance complicates the task of distinguishing between the positivist and realist ideas of objectivity. The distinction, rather a subtle one, consists in that for scientific realism the program of the physicalist reduction of scientific knowledge combines with the program of constructing a scientific ontology. Scientific realism not only strives to reduce the language of any science to the physical language and theoretical propositions to observation statements based, in the final analysis, on physical experience, but is bent on reducing chemical, biological, geographical, psychological and other processes as such to physical processes. In other words, it seeks to explain all objects and phenomena of reality through their physical properties and mechanisms. What is more, it regards such reductionism not as a purely scientific procedure intended for a physical explanation that would be quite justifiable, but defends it as a universal all-embracing scheme, thus giving it a status of a philosophical or, in relation to the problem of objectivity, an ontological principle. Understandably, the true significance of this feature can only be assessed in the context of the entire philosophical program of scientific realism. The emphasis on the objectivity of biological, physiological, and other processes and the attempts to explain them on the basis of the laws of physics represent a manifestly realistic or even materialistic trend, requiring, however, further methodological development. On the other hand, the epistemological reductionism, consisting in attempts to interpret biological, physiological, or mental phenomena in terms of physical notions with a view to overcoming metaphysics, identifies scientific realism with one or another variety of positivist physicalism. The distinction between them is often quite impalpable and reveals itself in the general tendency and orientation rather than in some tangibles. But then certain atavistic features of the new school are not to be wondered at if we bear in mind that the realistic methodology of science is still in its infancy. The subtle difference between the positivist and realistic programs can already be discerned in the philosophical concept of Herbert Fagel, formerly a member of the Vienna Circle, whose evolution has reflected numerous contradictions and vicissitudes of the transition from the positivist paradigm to the scientific realist worldview. The watered-down variants of the main dogmas of the logico-empiricist doctrine, the doubts regarding the distinction between the analytical and synthetic statements, the greater flexibility in the interpretation of the empirical criteria of scientific value characteristic of Fagel's early works gradually gave way to a more radical departure from the positivist tradition. Physicalism, which still holds in Fagel's concept as the hangover of the early period, is evidently regarded by him as the foundation of the new system. Having outlined his general methodological views mainly with reference to physics, Fagel later devoted much attention to the mind-body problem, i.e. to the relationship between the brain and consciousness. He was at first inclined to regard statements on mental and physical phenomena as two different languages referring to the same facts, but later gave preference to the monistic theory or the theory of identity, in which the data of experience and certain deduced notions of neurophysiological structures have one and the same reference object and are regarded as two different ways of cognizing one and the same thing. Such an identity of the mental and the physical is not yet tantamount to the logical identity of mind and body. Parallelism between them should be established by science, but not by philosophy. Fagel believes that such parallelism is already in evidence and the further drawing together of the two systems is inevitable. From the standpoint of common sense, this eliminates any basis for the hypothesis of the existence of two different entities. This line of reasoning brings Fagel to the conclusion that the referents of mental terms are identical with those of physical terms. Fagel's evolution from positivism to realism vividly illustrates all the most essential stages or steps of this transition: passage beyond the bounds of a purely linguistic approach to the problem, extension of the scope of semantic analysis, emphasis on objective neurophysiological processes as referents of the corresponding theoretical terms. Fagel distinguishes two different meanings of the term physical, the broader and the narrower ones. He writes, "By physical one terms I mean all terms whose specification of meaning essentially involves logical connections with the intersubjective observation languages. By physical two I mean the kind of theoretical concepts which are sufficient for the explanation, i.e. the deductive or probabilistic derivation, of the observation statements regarding the inorganic domain of nature." According to Fagel, the mental or the so-called raw sensations are identifiable with physical two. Fagel regards the volumes of these terms to be equal if the theory of identity is true. However, in case of emergence, i.e. logical non-deducibility of organic, mental, and social phenomena from physical phenomena, the sphere of physical 2 is obviously narrower than that of physical 1. As we see, Fagel's program implies the reduction of all sciences to physics. One cannot but admit, however, that it is not entirely divorced from the existing practice of theoretical investigations. The peculiarity of this practice was aptly expressed by Einstein, who once said that reason was commonly believed to be an unseemly word that ought to be avoided in a society of well-bred scientists. Reductionism, as we have already pointed out, is a kind of a semi-official ideology of the modern biological establishment. The practical significance of this tradition, however, is not very large, as it reflects a transitory stage in the development of biological, as well as psychological sciences. As Soviet scientists Ifrelov and Byudin have justly observed, reductionism is evidently the natural consequence of every situation in which investigation methods and experimental facilities come to the foreground in scientific research and dictate the selection of problems. Under such conditions, the issues prompted by the inner logic of scientific development are relegated to a secondary plan, and preference is given to problems whose solution is made possible owing to the application of specific research techniques or experimental facilities. Fegel's concept reveals strong links not only with physicalism, but also with empiricism. According to Fegel, knowledge starts with direct sensory experience, sensory acquaintance, as it were. He notes that the meaning of scientific statements actually consists in that they state the conditions of truth. These conditions, in turn, are evidently represented in the factual content of the relation of the stated knowledge, which is represented by sensations. Hence, Fegel understands the theory of truth as a theory of correspondence. The meaning of a statement, in his opinion, should be identified in its factual relation, whereas the meaning of scientific terms should be adapted to the set reality. As distinct from the positivist concept of the Vienna Circle, according to which the meaning of a statement determines the method of verification, Fegel lays special emphasis on a different aspect. After the recovery from radical behaviorism and operationism, we need no longer hesitate to distinguish between evidence and reference, i.e., between manifestations or symptoms on the one hand, and central states on the other. As has already been noted in the first chapter, scientific realism is characterized in most cases by very arbitrary attempts to join or separate various empirical and theoretical premises of general philosophical nature. A similar tendency manifests itself in the solution of the mind-body problem. Underscoring the empirical status of the identity of mind and body, Fegel, Smart and other realists often resort to metaphysical principles in order to substantiate the theory of identity. Moreover, the problem itself is regarded by them as metaphysical. Sometimes the metaphysical nature of the terms mental and physical, as well as of the problem of their relationship, is emphasized deliberately in defiance of the positivist doctrine. The term physical in this sense apparently acquires a new shade of meaning which does not fall within the framework of physical 1 or physical 2. It approximates the concept of the world as a whole and can be regarded as physical 3, gravitating to, though not coinciding with, the materialist concept of matter. The presence of 2 or even 3 levels in the understanding of the physical complicates the mind-body problem, difficult as it is, the more so as the above levels are not defined accurately enough. As a matter of fact, the description of the physical in terms of space-time and causal relations is characteristic of any theoretical science. Physical 1 related by Fegel to this description can be related to any other scientific description. From my realistic point of view, writes Fegel, it makes perfectly good sense to explain in terms of physical, psychophysical, and psychophysiological theories how, e.g., a bell by reflecting light, producing sound waves and being a solid, hard body affects our retina, cochlea, and our tactile nerve endings and thus produces the visual, tactual, and auditory data in our direct experience. This is indeed the causal theory of perception so much maligned by phenomenalists. The excessively broad definition of the physical is in fact at variance with the real meaning of this term in physical science, which alone gives it quite definite methodological significance. The extension of its limits leads to undesirable methodological paradoxes. Such an expansion, as is justly noted by Soviet scientist D. Dubrovsky, is tantamount to the absolutization of the physical, either by postulating a single all-embracing physical substance, or, given the epistemological emphasis, by implying the unavoidable absorption by physics of all other scientific disciplines. Physicalism is thus linked with the extension of the concept of the physical, and this alone is bound to have an adverse effect on the development of physics, condemning it to endless and futile wanderings. If unduly extended, the concept of the physical loses its concrete meaning and turns into an empty abstraction. Hegel's doctrine leads to the identification of any objective reality with physical reality. The world is nothing but physical reality painted in different colors. All phenomena are essentially physical processes. This applies also to mental phenomena, which are but a subclass of physical phenomena. The mental is identified with the physiological, i.e., with the processes which take place in the human brain. In turn, neurophysiological or biological processes are explained in terms of physical phenomena. This double reduction, given the extension of the chain, must be applied to developing neurophysiology, biochemistry, biophysics, etc. The tendencies in modern natural science are alleged to hold out much promise for such development. According to the new doctrine, materialist philosophy loses its status of a theoretical premise and turns into just another ontological hypothesis which is yet to be proved. This pretentious claim, by the way, underlies the title of scientific materialism assumed by the new school in an attempt to define its own place among the numerous trends representing the modern philosophy of science. True, physicalism has also sprouted in biology and cybernetics, but its models in these fields add but little to the basic physicalist concepts from the methodological angle. Hegel singles out a theoretical level represented by physical one, or the physical in the broader sense of the word, linking it with the categories of causality, space, time, etc. As a result, one may get an impression that this level is identical with the general philosophical concept of matter. Hegel also links this level with the intersubjective perception of language, though he gives no clear indication regarding the scope of such intersubjectivity. For Hegel, it is, evidently, confined within the limits of the physicalist theory. As regards his interpretation of the category of causality, it is based, as one can gather, not on a philosophical, e.g. dialectical materialist concept of cause, but on the so-called causal theory of perception. This theory, instructive as it is and containing not a few interesting ideas, has not yet been properly elaborated from the philosophical standpoint. Thus the identity of the mental and the physical in Hegel's concept rests on the identification of cause and consequence, as it is assumed that both the causes and their consequences must of necessity possess all characteristics of matter. Hence, Hegel's crucial concept of physical one is also implicitly based on empirical observations. This concept is unacceptable, for instance, to a theoretical physicist investigating the problems of quantum mechanics, as it is quite obvious to him that a physical theory at its present level cannot be adequately translated into the language of sensory experience, even if it is the intersubjective language of observations, as conceded by Hegel and other advocates of the identity of the mental and the physical. The qualitative difference between the theoretical and empirical levels in the reflection of objective reality has made it clear to many theoretical physicists that one cannot be reduced to the other in principle. The illusions that such a reduction is possible have already revealed their groundlessness in physical science. The more groundless are such illusions with regard to the reducibility of, say, the physiological to the physical. The exponents of the identity of the mental and the physical often refer to their empirical identity, and that in spite of the fact that the empirical language proves inadequate to express the theoretical content of unobservable phenomena even in physics itself. It holds even more true of mental phenomena characterized by a higher level and greater complexity. The vulnerability of Hegel's concept lies already in his assumption of the mental identity of physical one and physical two, since the former as the theoretical level in the investigation of phenomena and processes is restricted, on the strength of its definition, to the limits of intersubjectivity, i.e. the empirical level of cognition. Consequently, this assumption is untenable even from the viewpoint of physical science itself, which has developed a keen insight into these problems. The controversies in quantum mechanics are in fact much more instructive in this respect than some authors are inclined to think. These questions will be discussed later when characterizing the dialectical materialist methodology of science. Of course, the problem of causality has its own gradations, and qualitative at that, in different fields of modern science. The analysis of the specificity of this problem in physics, biology, chemistry, physiology, psychology, and other fields could be helpful in preparing scientists for the acceptance of perhaps even a greater specificity of mental processes and causal relations in the boundary area of psychic and neurophysiological phenomena. Yet the works published by scientific materialists have not revealed, so far, any evidence of such a tendency, nor any sufficiently differentiated approach to processes which could be regarded as psychological, psychophysiological, neuropsychological, neurophysiological, biopsychological and biochemical psychological. It stands to reason that the oversimplified idea of the relationship between different levels of reality falls an easy prey to all critics of scientific materialism, ranging from the less orthodox adherents of physicalism to the supporters of psychophysical dualism and interactionism. In the context of such criticism, their stand is presented as purely positivistic. In point of fact, this accusation is not entirely groundless, particularly in the case of Hegel. His present viewpoint differs from the empiricist program of positivist philosophy by its general orientation, promises and expectations rather than by the actual content. Indeed, Hegel does not go beyond proclaiming the need for an ontology and accepting, together with the entire school of scientific realism, the ontological existence of physical reality independent of man and his consciousness, though he restricts their relationship to the extent of identifying the mental with the physical. Hegel's special emphasis on the ontological aspect of the causality problem must serve as a warning against equating his stand with the paradigm of logical empiricism, i.e. positivism in its latest variants. Poulton, like other Hegel's critics, disregards this warning and confuses Hegel's viewpoint now with the positivist stand, now with the dialectical materialist concept, thereby revealing a not too profound knowledge of the Marxist views. Nevertheless, he does find the weak spots in the theory of identity. Now, he writes, scientific materialists are committed to hold that all causes and effects have all characteristics of matter. Yet I maintain that the causes of what I distinguish as outer sense are indeed always physical, but the ultimate phenomenal effects, the data which are directly experienced, are mental without exception. I go on to claim that the causes or grounds of what I distinguish as inner sense cannot be exclusively physical, and that the ultimate effects are also mental in nature. In substantiating his viewpoint, Poulton reasons as follows. Some material cause Z, which is Lake Ontario, produces probably identical consequences, similar perceptions on a sensory, empirical level of two different observers A and B. This does not mean at all that the same lake will be the cause of similar perceptions of Lake Ontario with other observers. Should we consider not external, but internal perceptions, we shall have to admit that not only the consequence, but the cause itself cannot be subjected to a material test. When our imagination is building up castles in the air, they have nothing in common with material objects. They are purely mental attributes of one man, and nobody else is capable of seeing these castles in his brain. The causal theory of perception is based on the principle identical causes, identical consequences, and does not identify causes if they do not produce identical consequences. Proceeding from this principle, Poulton infers that physical and mental processes are independent of one another and that mind is not identical with the central nervous system. But he goes further. Without any profound and concrete analysis, he postulates parallel existence and mutual independence of physical and mental processes, asserting, on the one hand, the presence of the world of things in themselves as the external cause of material phenomena belonging to the sphere of perceptions of the external world, and, on the other, the presence of the world of mental events as things in themselves, or the world of pure myself as the cause of mental phenomena belonging to the sphere of perceptions of man's internal state. Having thus defined his concept, Poulton, as is often the case, begins to doubt the soundness of the dualistic viewpoint, since he proposes in the end to deduce the existence of the physical world from mind, and it ought not to be supposed that mind is anything derivative in this relationship. On the contrary, mind matters in perhaps every relevant sense, psychologically, chronologically, epistemologically, logically, normatively, and ontologically. True, he hastens to specify that this assertion is not substantiated in his work, which means that he adheres for the present to a more moderate opinion seeking to prove that mind does exist and that it is different from matter. It goes without saying that matter is understood by Polton in the purely physicalist sense. It is perhaps of some interest to note, he writes, that Fegel's physicalist definition of existence is quite like the Marxist-Leninist account of matter. Any Marxist text will repeat the definition of Lenin that the sole property of matter is the property of being objective reality, existing outside consciousness, given to us in sensation. Of course, even consciousness is material for Marxists, as for Fegel. We do not mean to say that Polton deliberately distorts the Marxist viewpoint. We are rather inclined to think that Polton has rather a vague idea of it and very scanty knowledge of the corresponding works by Marx, Engels, and Lenin. In any case, his views on the Marxist-Leninist account of matter are very far from the truth. First, the dialectical materialist concept of matter does not coincide with the notion of the physical as understood by Fegel, even if we compare it with his more general interpretation of the physical as physical one. Besides objective reality, Marxism recognizes subjective reality, the reality of senses, emotions, thoughts, ideas, etc. Moreover, Marxism not only recognizes these realities, but demands that they be considered in their interaction. In this context, it would be in place to recall Lenin's well-known words, of course, even the antithesis of matter and mind has absolute significance only within the bounds of a very limited field, in this case exclusively within the bounds of the fundamental epistemological problem of what is to be regarded as primary and what as secondary. Beyond these bounds, the relative character of this antithesis is indubitable. Second, Lenin's stand has very little in common with positivist empiricism, which is characteristic of Fegel's views, since sensations to Lenin are by no means the only source of knowledge and the only means for the cognition of reality, but they are indeed the only form of man's connection with the surroundings and even with his own inner world. Every philosopher more or less familiar with Lenin's works knows perfectly well that Lenin made a clear distinction between the physical concept of matter subject to elaboration with every new significant discovery in physics and the philosophical or epistemological concept representing the sole property of the infinitely diverse objects and phenomena of the world, the property of being an objective reality. None other than Lenin, developing the ideas of Marx and Engels, came out against the identification of these different levels in the cognition of reality. Later on we shall dwell on this aspect of the problem at greater length, but at present our point is to emphasize that Polton's criticism of scientific materialism in the person of Fegel, Smart, Armstrong and others distorts their viewpoints in at least three aspects: in their attitude to positivism, i.e. logical empiricism, in their attitude to dialectical materialism, and in the confusion of the methodological and ontological treatment of the mind-body problem. As we see, the viability of the program of scientific realism depends primarily on its ability to overcome the physicalist viewpoint. It is all the more important as physicalism is in fact entirely alien to true philosophical materialism and seriously limits its theoretical and methodological possibilities. Physicalism, as well as reductionism in general, restricts the scope of scientific investigations and tends to turn them onto a beaten track paved with elaborate physical theories. Everyone knows how easy it is to tread along such tracks, yet every true scientist is equally aware that the easiest way is not the shortest one. Science, which represents the forefront of human thought, has always followed and will follow untrodden paths. Widely known are Marx's winged words: "There is no royal road to science, and only those who do not dread the fatiguing climb of its steep paths have a chance of gaining its luminous summits." Of course, physicalism and reductionism are not a transient phenomenon. They are not brought about by some specific concurrence of circumstances in scientific development, but make themselves manifest each time the philosophers, natural scientists, or sociologists attempt to apply certain general principles and methods of scientific explanation beyond the sphere where they hold good. Reductionism can be likened to intermittent fever of scientific cognition, which seizes now this, Now that field of science. It is essentially connected with the passage from one level of knowledge to another and plays an important part in a scientific explanation, though it is evidently not confined to the limits of this cognitive pattern alone. Physicalism is but one of the forms of reductionism which seeks to translate specific phenomena and processes into the language of physical mechanisms and laws. It should be noted that we do not apply the terms physicalism and reductionism to scientific explanations which reflect the laws of objective processes and fall in line with the trends of scientific cognition. With us, these terms always carry a negative meaning denoting an attempt to squeeze certain phenomena into the Procrustean bed of known laws relating to different systems and phenomena. The modern philosophy of science is characterized by complex internal processes and sweeping reappraisal of values. No sooner had Michael Ruse published his philosophy of biology, advocating reductionist and patently logico-empiricist views, than the scientific community produced other works, such as David Hull's philosophy of biological science, which treats practically the same range of problems, but from an entirely new position, claiming to represent the realistic approach. Contrary to Ruse, who denies theoretical biology the status of a science, Hull proceeds from the actual status of biology in a typically scientific realist manner. For him, the existence of a highly ramified and systematized biological science featuring a high level of theoretical development needs no proof, it is self-evident. Understandably, this initial premise lays a foundation for an entirely different system of reasoning. Defining his attitude to positivism and its methodological program, Hull declares that the logico-empiricist analysis of reduction is at best inadequate, and at worst utterly wrong. The paradigm of physicalism proceeds from the possibility of solving all problems at the lowest level of analysis, i.e. at the level of quantum mechanics, whereas biologists use not only analysis, but also synthesis to investigate the phenomena in interest, since they deal with highly organized living systems. Between the living and the dead, Hull sees not only a quantitative, but also a qualitative difference. This is particularly true of man as a living being. It is certainly true, he writes, that nothing is more obvious in the study of nature than the existence of complexity and levels of organization. Now here are the levels of organization more stratified and the complexity more complex than in the organic world. But ontological levels, individuals, parts, wholes, and so forth are hardly the givens of experience. Rather, these notions emerge as phenomena are investigated and need not coincide with common sense notions. Man is qualitatively different from other species. It is also indicative that Hull stands for the independence of biology as a science not only on the empirical, but also on the theoretical levels, recognizing the right of biology to have its own laws and theories which have not been formulated by physics and are not reducible to physical laws and theories. Biology, in his opinion, provides convincing evidence that the concept of life leaves no room for any metaphysical entity. The ability to create and reproduce ever more complex structures is inherent in the elements themselves which constitute living matter. The ascent from elementary particles to man includes a series of different integration levels and interruptions in development. Yet it is a continuous process, both in time and space, with no vacuum to be filled with immaterial entities. The transition from inanimate nature to the world of living beings is so continuous that the analysis of molecules and organelles of the cell has already got into the hands of physicists. This does not mean, however, that biology is turning into an appendage to physics and that its field of investigations is becoming, so to speak, a subsidiary to a more complex system. Each level of organization features new properties and new laws. Not a single separate molecule can reproduce itself. This ability is only inherent in such a formation as cell. Yet the emergence of life changes the rules of the game. Natural selection makes a greater demand on a higher level system, such as a population of cells, yet simultaneously offers it new forming possibilities. Living organisms remaining subject to the laws that govern inert systems acquire new properties which do not play any part at a lower level. Biology calls for a new theory. Of certain interest is also Hull's criticism of vitalism. In his opinion, the vitalist doctrine results from the failure to understand the connection between such key categories as things and substances, on the one hand, and properties, on the other. Life, according to Hull, is nothing but time, space, gravitation and magnetism. To this must be added the organizational property of living systems. The materialistic approach to the problem of life is quite obvious here, at least within the limits typical of scientific realism. Hull offers to explain life by the specific features of the organization of living matter itself, but not by postulating some spirit or vital force. Hull agrees with some anti-reductionists in that the successful development of biology calls for the ontology of many levels, stressing at the same time that it is far from sufficient to divide all reality into several layers and levels. The main thing is to determine the specific properties and laws characteristic of each of them. Hull's recognition of the existence of specific, qualitatively different levels, important as it is, cannot yet ensure the solution of the problems facing modern biology. His approach, though essentially materialistic, is still limited. Hull has inherited from positivism its special accent on cognitive structures and carries it onto static organic structures. Yet one of the fundamental properties of living matter at all levels consists in its ability for development and self-reproduction. Hence, one can hardly expect any essential progress in the creation of theoretical biology without a general theory of development, i.e. dialectics. Moreover, such progress cannot be ensured by mechanically applying dialectics to the analysis of living systems. It calls for a new approach which is to be worked out by biological science itself. It means that the processes of differentiation should be considered in unity with those of integration, synthesis, and that the structural approach should be combined with the historical one. In order to study differentiation phenomena, the scientist must possess some kind of an analytical instrument. Good headway has already been made towards this goal in the field of investigation of molecular biological mechanisms. More difficult appears to be the development of a comprehensive approach to such regulating and controlling systems as the endocrine or nervous system, as it must take into account the specificity of each system and each level of living matter. Biology could evidently greatly benefit from the principle of historicism, which would help it to explain the reactions of a developing organism to changing external conditions in terms of adaptability, i.e. to regard the interaction of the organism and the environment as a unity resulting from a prolonged adaptive evolution. Without a historical approach, all reactions of an organism may look like a heap of absurdities determined exclusively by the internal factors of development, quite fortuitous at that and in no way connected with external condition. In order to use to advantage all available analytical means of investigation, the biologists must first of all overcome their prejudice against dialectics and get down in earnest to studying its real theoretical and methodological content from classical works permeated with truly creative spirit. The results achieved in molecular biology could not have been duly appreciated if it had not been for the intensive development of the idea of self-development and for the turn to Darwin's theory of evolution. The synthesis of genetics and the evolution theory carried out in the 1930s and expounded by S. Chetverikov, R. Fisher, S. Wright, and other scientists undoubtedly played an important part in paving the way for the ideas and methods of molecular biology. The concept of microevolution, disputable as it is, has had a beneficial influence on the development of biology, if only for its role in preparing appropriate coordination between structure analysis and evolutionary research, i.e. in the integration of experimental biology and theoretical investigations. It should be remembered that though the elimination of the principles of integrity and historism in favor of analytical methods and means does produce an immediate effect and gives tangible and demonstrable results, it can never be anything more than just the first, though sufficiently flexible, approximation to the truth in the process of cognition of living organisms. As Azant Georgi has figuratively put it, with reductionism employed as a universal method, life passes, as it were, between one's fingers. The significance of each of the above methods in the development of modern biology can only be assessed from the standpoint of dialectics as a science concerned with the most general laws of development. Numerous philosophers and biologists showing interest in the above problems note the paradoxical fact that such outstanding physicists as Schrödinger, Bohr, Heisenberg, and Wigner have sided of late with the most resolute opponents of reductionism in many fields, including biology, which is far removed from their special interests and which is regarded by some physicists as a kind of their private domain. In making such observations, they overlook the fact that physics has already recovered, in the main if not completely, from this intermittent fever. There are few physicists now who still hope to reduce the theory of relativity in its present dominion to the principles of classical mechanics or to translate quantum phenomena into the language of classical Laplacian determinism. It becomes increasingly clear to scientists that reality cannot be reduced to the totality of observable facts and that epistemological reduction as one of the dogmas of positivism is untenable. It should be noted in this context that physics with its philosophical theories appears to be again far more instructive to biology than vice versa. As regards the approach to the problem of objectivity, the solutions offered by physics and its philosophers feature a notably higher standard of both empirical and theoretical investigations. It looks as if experimental biology were only approaching the stage at which it will be confronted with the problems of the inseparable connection between the object, subject, and instrument, and the relations between the object and the means of measurement. So far, we have not yet come across a philosophical work discussing these problems in the light of experimental investigations in biology. The theoretical level of biological science is evidently not yet high enough to permit a serious philosophical analysis of the means of the objective cognition of biological phenomena. By contrast, all these problems are not only given extensive coverage, but are also treated at a high theoretical level in the literature on physical problems, e.g. in the works by scientific realist Bungay. This philosophical trend occupies far more advanced positions in physics than in other fields of science. One of the important aspects of Bungay's concept appears to be his analysis of the problem of the conceptual representation of facts in theory. In his opinion, theory can hardly be regarded as simply an image of reality, something like a picture. It is rather a conceptual reconstruction of reality. Yet conceptual representations of facts are no less objective, though they are only partial and provide at best but an approximation to the truth. Not every theoretical construct represents something. For instance, logical notions are not representative at all, even if they have their referents. According to Bungay, reference and presentation are independent of each other, since non-referential constructs, such as multitudes, can be used for representation, whereas non-referential constructs, e.g. a tautology, may be completely unrepresentative. The truth is that scientific theories can be both referential and representative. The difference between the referent and the representation is of no small significance for philosophy. According to Bungay, biologists are more and more frequently engaged in controversies over which of the three biological systems is the true referent of the synthetic theory of evolution: the individual organism, the population, or the species. No convincing argument has been presented so far in favor of any of the contending theses. The difference between the referents and the representations becomes clear in developed sciences, such as theoretical physics. Here a certain function probability will refer to some system or state, whereas the values of this function may represent certain dispositions of the system, like, for instance, the function of mass refers to bodies in general, whereas its particular value will represent the mass of a given body. In quantum mechanics, each dynamic property of a system, such as a pulse, is represented by a certain operator in the Gilbertian space, i.e. a given operator represents a certain property of its referent. If the relationship of reference in factual sciences compares constructs with things or with aggregates of things, the relationship of representation compares a construct with a certain aspect or property of a given thing or an aggregate of things. Hence, the purpose and the result of a theory is not the representation of selected aspects of alleged things. Theoretical notions are nothing but developed mathematical structures which cannot be defined in terms of empirical operations or constructed as logical functions on the basis of given observations. Empirical checks consist of operations planned in the light of subsequent theories. Besides the experience bridging the gap between theory and reality, there also exists a semantic bridge constructed with the help of the semantic propositions of the given theory. According to Bungay, the ideal of objectivity characteristic of factual theory is preserved in quantum mechanics to no lesser degree than in classical mechanics. The object neither disappears nor merges with the subject. The only change consists in that our modern notions of micro-objects are incorporated in a whole chain of connecting links. The subject, notes Bungay, does not occur among the basic predicates of our version of QM. Neither does he occur in the theory of measurement. Indeed, physical theory is unconcerned with the psychical events going on inside the observer's skull. A physical theory of measurement is concerned only with the physical intersection between two or more physical entities, at least one of which must be a macrosystem. From Bungay's viewpoint, the standard formalism of quantum mechanics can be adequately expressed in terms of physics without any reference to the subject, i.e. psychology. In other words, quantum mechanics can be interpreted in the same way as classical mechanics on the assumption that the entities referred to by theory, such as electrons, atoms, molecules, etc., have an independent status. That does not mean, of course, that the experimentalist cannot modify them, for instance, by filtering out certain states or by providing evidence that some microsystems are purely imaginary. Yet to achieve this aim the experimentalist must use physical means without summoning the ghost of the Copenhagen school. Bungay views the observer as an entity capable of influencing physical events with the help of physical means, either directly, through the agency of his body, or indirectly, through the mediation of automated devices. The physicist's mind invents formulae used for prediction of physical events and for interpretation of physical phenomena under investigation, and therefore has no direct bearing on theory itself. For objective interpretation of quantum mechanics, Bungay proposes to free it, first, from the notion of observable value and, second, from subjective probability. In his opinion, it is irrelevant to speak of an observable value, of the observer changing it, of obtaining the true knowledge of the observable value, etc. All of these notions relate to the subject, as well as to some of his actions and mental states. Typical quantum properties are not observable, and changeable values are nothing but approximations to values calculated theoretically. The notion of certainty is no less alien to physical theory. The latter must contain the objective interpretation of probability as an ordinary physical property, but not as a degree of faith or a measure of certainty. According to Bungay, the axiomatization of the existing quantum theory is the radical means of its restructuring. Axiomatic substantiation should rest on such notions as the microsystem, the surroundings, the conventional space or the space of states, the property of the microsystem, the operator representing it, etc. These notions will give the quantum theory a kind of an initial basis subject to no further determination. The postulates of this realistic version of quantum mechanics determining each of the initial notions must be justified by their ability to give successful theoretical explanations of experimental facts. Hence, axioms are determined both formally and semantically. Measurements only come into play at the checking stage. As regards the properties of the microsystem and their conceptual representation, Bungay always strives to avoid the term observable. He contends that, first, they cannot be perceived, though they are amenable to indirect investigation; second, there is no complete clarity about the specific methods of their measurement. In Bungay's opinion, the subject should be barred from theoretical physics if we do not wish to confuse it with psychology or epistemology. The subject's role consists in constructing and checking a theory, but not in posing as its referent. It is for these reasons, according to Bungay, that we should not use the word observable with dynamic variables in quantum mechanics. Specific parameters inherent in quantum mechanical systems are chance variables in the sense that they are associated with a definite distribution of probabilities. It is true, in particular, of the position and momentum of a microsystem, which should rather be called a quantum position and a quantum momentum, to emphasize their non-classical nature. Bungay points out that the function representing the quantum state meets the axioms of the calculation of probabilities. It means that quantum mechanics today contains no latent variables. According to Bungay, Bohm's prohibition of latent variables directly ensues from the conventional approach to the notions of the axiomatic system and from the proof of the chance character of all dynamic variables. In Bungay's opinion, the fundamentalism of quantum mechanics can be understood in two different ways. One way is to assume that it refers not to an individual quantum, but to a statistical ensemble. From this assumption it logically follows that different components of a certain ensemble in a given quantum state have different values of the coordinates and of the momentum. Yet quantum mechanics is also applicable to an individual microsystem. The theory is not checked by means of large quantum ensembles. Thus, a calculated distribution of positions is compared with a diffraction pattern on the screen when the number of collisions increases. In other words, the function of the state refers to an individual quantum and its exact form is checked with the help of the quantum statistical totalities. The other way referred to by Bungay consists in regarding quantum mechanical properties as latent or potential rather than actual, i.e. as properties which reveal themselves in the interaction of the system with the measuring instrument. During this interaction the properties become dependent on the observer, since it is in his power to conduct or suspend the experiment. Yet here, too, Bungay strives to free quantum mechanical properties from the subject's influence. As a rule, a quantum has neither an accurately defined position, nor a definite momentum, possessing only point distributions. These distributions change with time under the influence of the environment irrespective of whether this environment is included in the experiment or not. Specifically, a quantum can be fairly well localized in space, for which purpose it is necessary to fulfill appropriate operations in order to prepare a localized state. Such operations quite often take place under natural conditions. According to Bungay, we only repeat the experiments staged by nature itself by fixing, for instance, the position of the atoms or by producing a monochromatic electron beam. From Bungay's viewpoint, the quantum theory does not lend itself to an empirical interpretation since none of its basic symbols has any empirical content. Moreover, not a single basic symbol of quantum mechanics can be explained in empirical terms, whence it follows that the quantum theory has no empirical content whatsoever. It does not mean, however, that it is not testable. It simply means, in Bungay's opinion, that its facts are quantum transitions lying above the level of sensory experience. Here Bungay somewhat exaggerates the existing gap between classical and quantum mechanics, sensory experience and theory, observability and non-observability. Though not directly observable, many quantum mechanical formalisms and symbols can at any rate be visualized and therefore lend themselves, at least partially, to empirical interpretation. Besides, an empirical test involves the use of additional theories connecting microprocesses with macroprocesses, as well as theories explaining the behavior of the macrosystems included in the process of measurement. The semantic content of the quantum theory is thus determined not only by the factual level reflected in theoretical concepts, but also by concepts which can be translated, at least partially, into the empirical language. To be sure, this circumstance makes the test of the quantum theory much more difficult and is accountable for the controversies over the possibility of the interpretation of quantum mechanics. Bungay strives for the simplest and most radical solution of the problem of objectivity in quantum mechanics, proposing complete separation of the empirical and theoretical levels and banishment of all observable and measurable values from theory. In point of fact, it is the reverse of ousting metaphysics. This way can hardly lead to a satisfactory result. Just like an experiment cannot be freed from its theoretical canvas, so the quantum theory cannot and evidently need not be relieved of all the observables. If compared with the stand of the Copenhagen school, it is just the other extreme, prompted by the desire to solve the problem of objectivity in quantum mechanics by surgical means. One will hardly take exception to Bungay's contention that a notion cannot be defined as primary or secondary outside a definite theoretical context, that the axiomatization of the theories of relativity and quantum mechanics has made it clear that they deal with objects rather than measurements, and that these theories are not directly related to the observer and his mental states. It is not quite clear, however, in which way the axiomatization of the above theories helps to reveal their objective content or, the more so, serves as a means for making knowledge more objective. Nevertheless, Bunge's idea appears to be constructive enough, particularly if the proposed axiomatization could be supplemented with other methods of the objective interpretation of the quantum theory. As we shall try to show later, such possibilities should evidently not be discarded. Besides the weaknesses noted above, Bunge's concept is depreciated by the mutual isolation of classical and quantum mechanics. He draws a sharp line of demarcation between the two theories, leaving just one connecting link, the instrument, whose indications are described in terms of classical physics but at the same time do not yield to empirical interpretation. Here Bunge appears to be unable to fit things to one another and shape them into a streamlined philosophical methodological system. He stops in hesitation when confronted with the need for a more flexible, i.e. dialectical, approach to the relationship of theories. What is needed, however, is not only a more flexible apparatus to investigate the relations and links between theories, as well as between a theory and its empirical basis. Of crucial importance, alongside a greater determination to delimit theory and sensory experience, is an effective methodological concept of development. A concept of this kind is necessary not only for understanding the interdependence of the classical and quantum theories, but also for defining the future trends of the development of modern physics. It is very important, for instance, to envisage the prospects of the modern non-relativistic quantum theory and the theory of relativity, as well as the effect of their possible integration on the theory of elementary particles. It is quite obvious that the solution of these problems calls for a dialectical approach to the analysis of modern scientific knowledge and for abandoning the view that the quantum theory revised in accordance with Bunge's requirements is the ideal for all sciences. The materialistic substantiation of the latest physical theories cannot be complete without dialectical analysis. It is not fortuitous that the weakness of this link in the system of Bunge's views leads him to a number of idealistic conclusions. As has been shown above, Bunge's approach to the interpretation of quantum mechanics, the general problems of the relationship of philosophy and science, as well as to the mind-body problem cannot but suffer from certain eclecticism due to his prejudice against dialectics. Bunge's concept features rather a contradictory and even odd combination of the objective understanding of probability in quantum mechanics with the mechanistic interpretation of causality. Bunge's mechanicism in this field is traceable to his earlier works and, as his latest ideas show, has not been completely cured. It must be admitted that Bunge has come out with argumentative criticism against the Machist concept of causality and opposed the attempts of Schlick, Frank, and Mach himself to substitute functional dependence or the connection of states for causal relations. He repeatedly disclosed the futility of all attempts of positivism to contrast causality and quantum mechanics and to undermine the idea of causality by counterposing it to Heisenberg's correlation of uncertainties. His efforts, given a most serious attitude to dialectics, could be very fruitful in achieving a common goal to give an objective substantiation to the micro-world theory. However, Bunge has always refused to avail himself of this methodological support. Bunge's stand is largely attributable to the fact that his concept of causality is based on the simplest form of causal relations lying on the surface in everyday experience, the action of one object on another. Expressing the principle of causality in a more strict logical form, Bunge presents it as follows: if C happens under the same conditions, then E is always produced by it. According to the author, this formula includes all the obligatory components of causality, namely, the conditionality of the consequence upon the cause, the uniqueness of the connection, the unilateral dependence of the consequence on the cause, the constancy of the connection and its genetic nature. Ascribing such features as uniqueness and necessity to causal relations, Bunge discards by his formula the possibility of one and the same consequence being brought about by different causes. In his analysis of different definitions of causality, Bunge gives preference to the one identifying the cause with the necessary and sufficient condition. He includes all the accompanying conditions in the concept of the efficient cause. In his opinion, if the accompanying conditions were contingent upon the cause, the formula of causality would express more than a simple, direct causal bond, and the cause would then be regarded as the unchanged daner or triggerer of a process. Bunge's formula, however, complicates the problem of the relationship of the internal and external conditions in the analysis of some complex process, particularly in a living organism or any developing system. No less difficult becomes also the analysis of the behavior of a quantum mechanical system, which figures prominently in Bunge's works. The solution to the internal-external dilemma in the causality problem proposed by Bunge is very, if not too, simple. He identifies both the internal and external conditions either with the necessary or with the sufficient conditions required to ensure the causal process. This brings him in obvious contradiction with his own concept of determinism. It should be noted that Bunge distinguishes between the principle of causality and the principle of determinism. The latter rests on a broader notion of determination which includes the processes of simple causality. One might infer from this stand that causality in its simplest and clearest form must underlie any kind of determination, including the statistical one. Yet Bunge, though never giving a clear-cut definition of necessity and chance, makes it quite plain that the changes contingent on the very nature of phenomena and resulting from the operation of internal factors should be regarded as the necessary ones. Chance, according to Bunge, is what results from external circumstances. Now let us see if this approach will help in any way to understand the nature of quantum mechanical processes or throw additional light on the problem of completeness of the quantum theory. In his book on causality, Bunge still regards with favor Bohm's hypothesis of the existence of latent parameters determining the statistical behavior of microparticles and contends that, once defined, they would enable the scientists to abandon the probability interpretation of quantum mechanics and of the behavior of microparticles. Yet in his philosophy of physics, written later, he changes his views and offers a different program, to eliminate completely the subject from the quantum theory. In this way he evidently seeks to eliminate the subjective interpretation of probability as well. To this end Bunge uses the expression mean value instead of the psychological expectation value and prefers the terminology of probability of quantons presence in a given volume to the vocabulary of the Copenhagen School and Percy Bridgman's operationalist concept. Bunge goes even as far as substituting the terms scatter and spread for uncertainty and indeterminacy. Here, however, a tricky question suggests itself. Is it to be inferred that a statistical process proceeding at a certain level of the organization of matter is a direct effect of the cause operating at a deeper level? Schrödinger's equation is known to be in some sense mechanistic, just like Newton's. Both equations describe the changes caused by external effects, yet the latter, unlike the former, represents a simple causal relationship. The quantization of states brings in a new qualitative element which distinguishes modern from classical mechanics. The essential difference consists in that the former equation regards matter as a wave process, whereas the latter one treats it as the totality of particles. The difference here is brought about by the inner quality and not by external forces. Yet in both situations the principle of causality is used to explain motion in terms of mechanics. Should it be assumed, then, that simple causality rejected at one level owing to statistical interpretation must be restored at the next basic level as being better suited for the explanation and prediction of processes? When we pass on to microprocesses, we encounter a relative increase in the role of internal factors and a corresponding decrease in the role of external factors in determining the properties of physical systems. Here again, how are we to tally necessity resulting, according to Bunge, from the operation of internal factors of physical and all other phenomena, and chance regarded by him as a totality of external conditions with the view that any future theory explaining the mechanical displacement of microparticles in space and time will be a statistical theory? Suppose now we still hope that one fine day it will prove possible to describe the behavior of microparticles in terms of simple causal relations. All the same, the lessons taught by quantum mechanics have not been lost on us, and we now understand that causality need not at all be rigidly and forever linked with necessity, and that necessity, for that matter, cannot be divorced from chance, except by the sheer force of abstraction from concrete conditions. Hence, Any causal connection includes both necessity and chance. If that is so, as surely it is, causality can never be separated from probability unless it is viewed as a fixed relationship, something in the nature of a bronze casting, which cannot be different from what it is. So, we are again bound to come to the conclusion that disregard for dialectics and the inapt use of its instruments let down even the most talented representatives of scientific realism and account, directly or indirectly, for their inconsistencies and concessions to idealism despite the ostensibly materialistic premises of their concepts. Chapter 3. Dialectical Bearings. 1. Overcoming Hegel. By Igor Naletov. While assessing the significance of various schools of the modern philosophy of science and comparing their programs and views on fundamental methodological problems, we have never missed an opportunity to outline, if only schematically, the attitude of dialectical materialism to each issue under consideration. Now, in order to characterize materialistic dialectics as an alternative to positivism, we ought to take a somewhat closer look at its basic concepts and present them in a broader perspective. Of course, it would be presumptuous even to attempt to give an exhaustive account of Marxist philosophy within the scope of this publication. We shall therefore confine ourselves to the relationship of philosophy and special sciences, the objectivity of scientific knowledge and causality, i.e. to the main problems which we have already discussed in connection with the crisis of positivism and with the programs of alternative doctrines within the framework of the modern philosophy of science and which constitute, as we have shown, the core of any methodological program. From its very first steps, Marxist philosophy, continuing the materialistic and dialectical traditions of all previous philosophy, has been the antipode of positivism. There is no need to reproduce here the history of their struggle, the more so as its outcome is well known. The prestige of materialistic dialectics as the methodology of cognition and as the worldview is steadily growing, winning over to its side the most prominent representatives of modern science. Marxist philosophy, assimilating every new achievement of social and scientific progress and constantly enriching itself, is extending its influence to ever new regions of the world, the only means of its expansion being, as before, the logic of truth. It is precisely this logic, confirmed by life itself, that underlies its high scientific repute. By contrast, positivist philosophy, represented now by a dozen or so of its champions, the living relics of the past, is undergoing a profound ideological crisis, evidently marking the closing stage of its history. The dramatic story of the struggle between Marxist philosophy and various trends of positivism suggests certain conclusions which appear to be particularly instructive in the light of the present-day debate on the methodology of scientific cognition, as they are directly related to the main controversial issues. In this connection, special importance attaches to the difference between the Marxist and positivist views on the relation of philosophy to special sciences, as well as on the relation of science in general to the unscientific forms of consciousness. As we have earlier indicated, one of the key points in the programs of all positivist schools without exception has always been the opposition to metaphysics, i.e. to everything that passes beyond the limits of scientific knowledge. Indeed, the only difference between the successive stages or phases of the evolution of positivism consisted, perhaps, in the difference of the concepts of scientificity and, consequently, in different lines of demarcation between science and non-science. This circumstance, however, has nothing to do with the ill luck of positivist philosophy, since the delimitation of these two spheres of human and social consciousness is indeed absolutely necessary. No one in our time, except, perhaps, theologists, would raise any objections to the separation of science and religion if only for the simple reason that they represent entirely different forms of social consciousness with their own traditions, specific features, and functions in society, not to speak of the religious prejudices that have always been a formidable obstacle in the way of scientific progress. Besides religion, there exist other forms of non-scientific consciousness, such as, for instance, aesthetic consciousness and common sense. They should also be distinguished from science as such, though there is no sharp line of demarcation between them. Indeed, Scientific knowledge grows on the rich soil of man's everyday experience, and the artistic perception of the world inspires creative scientific endeavor. It would be impossible to understand science, its origin, motive forces, and the nature of scientific thinking itself if we left out of account the blood vessels connecting science with living humanity, its everyday needs and aspirations, as well as the enormous wealth of labor experience accumulated by mankind. Said Goethe, all theory, dear friend, is grey, but the golden tree of actual life springs evergreen. The fact that the links between science and the arts have not yet been properly explored gives no grounds for ignoring their obvious mutually beneficial influence. On the contrary, the more complex and uncommon their relations, the greater should be the philosopher's desire to get at the root of their extraordinary alliance, since they may find there a clue to the mystery of human thinking. The discoveries that may await them on this path are being eagerly looked forward to by science, as they will essentially affect the further course of scientific and technological progress, rationalize the development of technology and raise the intellectual standards of human life. There is no need to discuss these problems in detail, since our purpose at present is to underscore the importance of demarcating science and non-scientific knowledge. However, such a demarcation cannot be an aim in itself. The close links existing between science and everyday life, science and the arts, common sense and true knowledge, as well as between science and other fields of social life indicate that it should be but a preliminary stage for further investigations. When social life and social consciousness are divided respectively into more or less independent spheres and forms, the next step will be to focus our attention on their interconnection. This stage, however, will hardly be the final one either, since the investigation of their links will lead to a more profound and concrete understanding of differences between them. This process, alas, has no end, just like the process of cognition in general. We may sound not very optimistic, but one of the tasks of science, as distinct from religion and other forms of myths, consists in giving man correct ideas of himself and of the surrounding world, the ideas that would be concrete, connected with reality and therefore testable, rather than in his illusory consolation. As to the arts and common sense, science differs from them by the precision of its statements, accuracy of calculations and forecasts, as well as by the reliability of its conclusions. As is seen from these considerations, very general and sketchy as they are, the nature of scientific knowledge can only be understood after it is singled out of other forms of human consciousness and presented as a historical process, i.e. with its essential links, both logical and historical. It should be noted that the rapid scientific development over the past decades and the crucial changes of many fundamental concepts of the world have exposed the links between science and other social activities and made their interdependence common knowledge. The immaturity of these links in the period of the inception of positivism, however, cannot justify this philosophy for their methodological distortion, particularly at the later stages of its evolution when these links became more apparent. As early as the beginning of the 19th century, Hegel defined the basic principles underlying the approach to this question. These principles, though in idealistic attire, carried profound dialectical meaning which ensured their viability till our time. All that was needed in order to solve in principle the problem of the relationship of science to the non-scientific forms of human consciousness was dialectics. It was to show the complexity and the contradictory nature of this relationship, on the one hand, the opposition of science and religion, of scientific and pictorial thinking, intuition and logic, practice and theory, on the other, the diversity of bonds, mediating and intermediate links, as well as the transitions from one form of consciousness to another. The question of the scientific value of philosophy aroused Hegel's special interest. In 1802, he emphasized the importance of this question in the Critical Philosophical Journal and discussed the attitude to it on the part of Kant and Fichte. Philosophy, wrote Hegel, since it is to be ordered knowledge, cannot borrow its method from a subordinate science, such as mathematics. In his opinion, philosophy was capable of being an objective, conclusive science based on the imminent development of the notion and the absolute method of knowledge. The content of logic as the highest type of philosophical science is its scientific method, the notion of science itself which is its ultimate result, as well as the concept of its subject matter, thinking in concepts which is engendered in the course of development of the science, and therefore cannot precede it. According to Hegel, the one and only thing for securing scientific progress is understanding that the method of logic is spontaneous development of its content and that its essence is a dialectical, i.e. definite negation. Having mastered Hegel's dialectics, Marx and Engels gave a profound comparative analysis of their own and Hegel's views proceeding from the materialistic idea of the primacy of social being over social consciousness, of the determination of consciousness, its content and structure by the content and structure of the social, practical activity of man. Reuniting dialectics and materialism, Marx and Engels turned dialectics into a real science, and this in the terms that have preserved their validity till nowadays: objectivity, connection with reality and testability of its propositions in practice. Having retained the universality of logical categories and principles, materialist dialectics at the same time got rid of the speculativeness, scholasticism, and abstractness which were characteristic of German classical philosophy. Disclosing the mystified form of Hegelian dialectics in his economic manuscripts of 1857 to 1859, Marx described his own method as being the direct opposite of the Hegelian method. One of the features of Marx's method, also contrasting with Hegel's idealistic dialectics, consisted, according to Marx, in that it leads from abstract definitions by way of reasoning to the reproduction of the concrete situation, as a summing up, a result, and not as the starting point. The categories and laws of materialistic dialectics are indeed universal and in this sense irrefutable. Yet their status is entirely different from the status of a priori, absolute Hegelian ideas. The universality of the categories and laws of dialectics interpreted materialistically does not mean that they can be used everywhere, at all times, in all cases and under any circumstances. They are only universal in the sense that they apply to all fields of reality, namely, to nature, society and thinking. When we say that they are universally confirmable, we mean that they are confirmed in all fields of reality. This, and only this, is the meaning of universality characterizing dialectical laws and categories. Of course, such an understanding of universality limits the competence of philosophy, which claimed to be the science of sciences, by denying it the right to explain or analyze every individual object or phenomena, every relationship or dependence. One can speak of dialectics as the science of sciences in a figurative sense only, meaning that it rises above particulars, trivial problems, and petty everyday situations. If Marx and Engels had not risen above their surroundings, they would hardly have managed to discern the essence of capitalism, its basic laws and working of hidden mechanisms behind the Mont Blanc of individual facts. Moreover, had they not risen above reality, they would not have been able to see the outlines of future human society. This looking from above has nothing in common with looking down upon something, and does not by any means imply a derogatory attitude to specialized sciences, everyday human life and their specific reflection in human consciousness. It is rather an epistemological position indicative of the relative independence of philosophical knowledge and of the specific character of the subject matter of dialectics as a science. Philosophy and dialectics should be concerned with more general problems than those which come within the scope of special sciences. It stands to reason that the links and relationships connecting the most general properties of objects and phenomena of reality are different from those connecting specific objects and phenomena. They constitute a specific field of knowledge which cannot be covered in full measure by physics, chemistry, biology, history, or any other particular sciences. On the other hand, the tree of science would hardly be able to flourish without its crown transforming the power and tenacity of philosophical ideas into the energy of scientific cognition. Having preserved the universality of dialectical categories which reflect eternal human problems and link the wanderings of man's spirit in the depths of outer space, atom, or living cell with his earthly existence, Marxism has shown at the same time the real connection of most general philosophical problems with man's social life, practical activity, and problems of special sciences. In that sense, Marxism revealed the specific nature of philosophical categories and, consequently, showed the way to test them, i.e. to confirm true ideas and views and to refute false ones. This idea of the unity of the universality of philosophical knowledge and its concreteness was beyond Hegel's understanding owing to the speculativeness of his philosophy, its detachment from real being rooted in the conception of the identity of being and thinking. This idea, however, is also beyond the comprehension of modern positivism with its fixation on the direct empirical testing of any scientific knowledge and obsession with the struggle against metaphysics condemned together with dialectics by the positivist court of verification or falsification. The irony consists in that dialectics, which had provided the real basis for alliance between philosophy and science way back by the middle of the 19th century, has become one of the main objects of positivist attacks against metaphysics and speculativeness. One of the greatest achievements of human mind was treated by the philosophy of science equally with religion and other distorted forms of social consciousness. Fighting against dialectics and striving to tear it away from science, positivism was at the same time pretending to give a correct explanation of the nature and essence of scientific cognition, distinguish science from other forms of human activity and delimit religion and mythology. It is this paradox that lies at the root of all the misfortunes of positivism. The evolution of positivism, which is now almost 1.5 centuries old, has not brought about any appreciable change in its attitude to dialectics. Spencer and Comte underscored the empirical untestability of the categories and laws of dialectics. Mach and Avenarius opposed the dialectics of Marx and Engels even more uncompromisingly. Attempting to disprove dialectics, the logical positivists have seized upon the criterion of verification, and their arguments, if only slightly modified, are now currently used by all modern representatives of the philosophy of science. They allege, for instance, that dialectics is being substantiated by non-scientific methods and that its propositions are just illustrated by examples instead of being mathematically correlated with experience. In support of their charges, they usually refer to textbooks on philosophy which sometimes do expound dialectics in an oversimplified didactic manner. Such accusations, however, cannot be taken seriously. Criticism of dialectics requires a far more profound knowledge of the subject than just superficial acquaintance with students' aids. The real thrust of positivist criticism consists in the contention that dialectics is nothing but natural philosophy, since it concerns itself with the most general laws of being. A philosopher, according to positivism, has no right to express his views not only on reality as a whole, but even on any of its components. One of the most serious positivist arguments against dialectics is the assertion that it has no empirical content and that its propositions are nonsensical in cognitive terms. According to the positivist critics, this conclusion is borne out by the impossibility of any empirical verification of dialectical statements. It is commonly argued in present-day positivist literature that dialectics does not disprove anything and that its propositions are universally confirmable, i.e. not falsifiable. In contrast to Russell, Schlick, and Wittgenstein, who underscored the empirical non-testability, non-verifiability of dialectics and therefore qualified it as metaphysics, Popper and his numerous followers apply a different criterion in the assessment of dialectics. Yet one would vainly expect them to recognize it as the methodology of scientific cognition. Significantly, in Popper's system, which is based on an entirely different and even, in a sense, the opposite approach to the problem of testability of scientific knowledge, dialectics, nevertheless, is again classified as metaphysics, this time, however, on different grounds. Since the Occam razor for Popper is falsifiability, he condemns dialectics for universal confirmability or non-falsifiability of its propositions and principles. In Popper's opinion, no facts can be cited which would run counter to the principles of dialectics, if only potentially. At the same time, dialectical statements are not analytical like those of logic or mathematics. Their fallacy therefore is inherent and can be neither circumvented, nor neutralized. That, according to critical rationalism, means that dialectics is just another kind of metaphysics and its statements have but a semblance of empirical content. However, Popper's prolonged debate with the Vienna school was bound to effect a serious change in his views and to make him reproduce increasingly though unconsciously, the ideas of German classical and, in particular, Hegelian dialectics. The more anti-positivistic he became, the louder sounded the Hegelian notes in his concept of objective knowledge, inherent knowledge, cosmic, physical, biological and cultural evolution. Popper's militant anti-historicism was giving way to evolutionism, etc. Seeking a clue to Popper's spontaneous gravitation to Hegelian metaphysics, one should take into account the similarity of the situations in European bourgeois philosophy in the middle of the 20th and the early 19th centuries. Like Hegel's dialectics born in the midst of the struggle against the mechanical naturalistic and empirical phenomenological forms of philosophy, as well as against the reductionist concepts of consciousness, Popper's evolution towards the dialectical forms of thought takes place in the atmosphere of criticism of the mechanistic dogmas of neopositivism, the static cumulativistic concept of science, the empirical and inductivist methodology, the physicalist theory of cognition, etc. Referring to the universality of dialectical categories and laws, representatives of the modern philosophy of science speak of the triviality of its conclusions. In their opinion, dialectics applicable to all cognitive situations without exception is nothing but a set of tautological assertions which give no grounds for any differentiations and, consequently, are devoid of analytical possibilities. They further argue that a philosopher does not base his conclusions on sensory data and does not resort to an experiment. He can only reason within the limits of his professional capability. Hence the conclusion, philosophy must not claim to be anything more than logic. Since formal logic is the development of its own postulates and not related in any way to the outer world, it must not be regarded as knowledge of anything. The logician and, consequently, the philosopher must look after the scientist, ensuring that his formal calculations are not nonsensical, but the calculations themselves should be based on linguistic agreements. For the philosopher, as an analyst, writes Ayer, is not directly concerned with the physical properties of things. He is concerned only with the way in which we speak about them. Philosophy is a department of logic. For we shall see that the characteristic mark of a purely logical inquiry is that it is concerned with the formal consequences of our definitions and not with questions of empirical fact. Whatever the viewpoints as to the scientific value of various propositions, the difference between them consists in the adherence to a definite method of comparing such propositions with sensory experience. Laying aside the details, i.e. the question of the methods of checking which are in fact diametrically opposite in each of the concepts and equally one-sided, each concept centers around the problem of testability, at least in principle, of various statements and refutability of false ideas. It stands to reason that Marxist philosophy also regards the testability of any assertion, i.e. its confirmability or refutability, as the main criterion of scientific knowledge. Marxism holds that the testability of propositions presupposes their concreteness and meaningfulness, and this is just the crux of the matter. If philosophy is a system of abstract knowledge, the testability of its propositions, in contrast to specialized or positive sciences, is entirely out of the question. Since the categories, laws, and principles of dialectics and materialism are indeed expressed in abstract terms, positivism may seem to be justified in asserting that dialectical propositions are nonsensical, unscientific, and metaphysical. True, the categories of materialistic dialectics are the most abstract, i.e. the most general concepts which constitute the initial postulates not only in the system of special knowledge, but also in philosophy itself. These are the ultimate, most comprehensive concepts, Lenin wrote, which epistemology has in point of fact so far not surpassed. These Lenin's words characterizing the concepts of matter and consciousness are fully applicable to many other categories of dialectics. They cannot be deduced in a purely logical way, à la Hegel. From other concepts they are abstracted from reality itself and raised to a level of universal philosophical generalizations on the basis of centuries-old human experience and scientific knowledge. Indeed, if we identify the concrete with sensory experience and regard as concrete an individual object or a phenomenon given us in direct sense perceptions, dialectics will inevitably appear as an abstract science, A field of abstract knowledge free from any sensory experience and concreteness, since it is far removed from the sensuous world and is least of all concerned with individual phenomena and objects, concentrating primarily on their general properties and relations. It is just this understanding of the abstract and the concrete, in which the former represents the universal properties and relations, and the latter, the sensually perceived individual objects, that is prevalent in literature and underlies the attempts to counterpose philosophy and special sciences. Before we proceed to philosophical categories, let us have a closer look at the most concrete, at first sight, knowledge, the knowledge of what is given us in everyday sensory experience, and see how concrete and, consequently, testable it is. What can be said about sensory experience as the primary source of our knowledge? If we are to rely upon it for its critical and informative values as proposed by positivism, it must be the real standard of clarity, and we should have no doubt as regards its content or possible limits. Yet the very first pages of Hegel's Phenomenology of Spirit show that there is nothing more obscure than sensory experience. If we want to get pure sensory experience and abstract from all rational elements, all structures of the mind, we shall find ourselves in possession not of the richest, but of the poorest content conceivable. We shall have to throw away all universal or rational forms, all categories such as quality, contradiction, necessity, matter, etc., in order to find absolutely possible pure this, here, now. Having arrived at this point, we shall realize that instead of a well of knowledge we have got an iridescent soap bubble ready to burst under the slightest whiff of scientific air, and absolutely empty at that. What we find, writes Hegel, is in itself unstable and indefinite, since even with a minor change of our view or attention we find a different this here now. However, even these categories must preserve some remnant of the abstract, if they are to have any sense at all. This, here and now, turn out to be the least definite of all categories when we attempt to define or fix them with the help of experience. They acquire their stable meaning due to the work of mind only. Hegel's concepts of the abstract and the concrete are much more refined and promising, if only for the fact that he does not necessarily connect the concrete with sensual perception. A murderer is an abstract definition for a crowd of idlers, not because it is a legal notion abstracted from man's other definitions, but mainly because he ceases to be anything else but a murderer for an onlooker watching the execution. A handsome murderer? Can one think so badly? Can one call a murderer handsome? His personality, with all the richness of his life, his appearance, upbringing, etc., are all squeezed into a single definition, severing all other ties and relations with the world. The abstract for Hegel is the separate, isolated, alienated from the multitude of ties and relations of an object. By contrast, the concrete is the richness of the fully reproduced properties and qualities in their totality. According to Hegel, a wise judge of human heart thinking in concrete terms will consider the entire course of events shaping the criminal's character, trace the influence of bad relations between his father and mother on his life and his upbringing, reveal, perhaps, the injustice or cruelty to which he was exposed, etc. Hegel evidently intended to reconcile society with itself, the society which, on the one hand, disregards abstract thinking without suffering the pangs of remorse, and, on the other, feels at heart certain respect for it as for something elevated, and avoids it not because of contempt for it but because of glorification, not because it seems something commonplace but because it is taken for something notable or, on the contrary, for something special. Yet Hegel's irony, which, for that matter, permeates his entire article, is too obvious to make the opponents of the abstract more tolerant. The examples of the average man's concrete thinking displayed by Hegel are too unattractive to make his eulogy of concrete thinking flattering for the champions of empirical concreteness. Here Hegel hasn't got the slightest chance to win their sympathy. It is the more regrettable as even this publicistic article is, in fact, very instructive. Hegel convincingly shows that what appears at first sight very concrete knowledge with lots of down-to-earth and juicy details turns out to be extremely incomplete, i.e. abstract. True, Hegel hardly shows here the depth of the abstract, the concreteness of general determinations. The abstract and the concrete do not yet merge in organic synthesis. They are still held apart by the idea that knowledge can be concrete and abstract, and that abstract knowledge can pass into concrete knowledge through ever more substantive determinations. We should not, however, demand too much from Hegel. What he said gives grounds for further inferences and suggests, if only implicitly, new ideas. Hegel is known to be helpful in overcoming Hegel and in enabling his successors to open up new horizons, standing on his own shoulders. Hence, none other than Hegel enables us to make the first critical remark about positivism. The highest positivist criterion of meaningfulness and scientificity proves itself to be extremely indefinite and badly needing clarification. Yet neither definiteness, nor clarity can be borrowed from the formal logic, which is nothing but a set of conventional rules for formulating statements. Of course, sensory experience can play the part of a cognitive method, but it can only be defined and harmonized within a broader rational system, such as the one conceived by Hegel, but not within sensory experience itself or the logical syntax. Positivism strives, so to speak, to freeze arbitrarily the cognitive method at one of the levels, important though it may be. Since the criterion of sensory experience is itself uncertain, one should not be surprised at the controversies flaring up now and again within positivist philosophy over the nature of experience. Experience was first believed to consist of fragmentary sensory data. Later it became clear that such fragments were themselves abstractions singled out by the mind from more concrete and continuous whole. What were then the pure sense data? Were they to include relations having different abstract components? Nor was it clear which categories expected to be discovered within the sphere of pure experience were genuine, and which were purely logical, i.e. verbal structures. More, was sensory experience to be regarded as the manifestation of something called qualities, and wasn't even the most primitive experience mingled with our conviction surfacing, for instance, in the vagueness of assertions and statements on facts and situations? Finally, whence the assurance that sensory experience was to be placed in the foreground? It is again Hegel who helps us reveal this important omission of positivist philosophy. The mind is denied the ability to comprehend reality, since every statement about reality must, by force of its synthetic nature, express pure chance, and the mind does not produce anything but only elaborates the conclusions obtained from clear verbal statements. For Hegel, statements of chance represent but a moment which is barren of any thought and signifies that mind has already completed its work. Positivism, on the contrary, regards as meaningful only those statements which relate to accidental facts. Yet to point out a fact does not mean to comprehend it. A synthetic statement a posteriori is nothing but a record of what has occurred, but it has no explaining force. Such statements cannot become explanatory through generalization processes. They remain synthetic irrespective of whether they refer to one, some, most or all objects. A statement which is now called law remains a simple assertion that something is accidental and gives no understanding of the causes of the given occurrence. It is obvious that the process of generalization enhances the force of prediction. To speak of the object as a whole is to give a more reliable prediction of the future state of affairs. Yet the ability for prediction is something different from comprehension. Even if we eventually succeeded, through hard work, in obtaining generalizations covering the broadest possible field of events and were able to predict the course of every experiment, we would not take a single step towards understanding any of them. The function of the mind, according to Hegel, is neither the singling out of tautological statements, nor the generalization of synthetic statements of facts. Its function is comprehension. Rational comprehension for Hegel results from at least two factors: the ontological status of the mind and the impossibility to find something which can be completely determinable or completely comprehensible. The first factor prevents logic from being conventional and purely verbal, the second factor does not allow it to bog down at the very beginning. One of the obvious meanings of the concept concreteness is that our knowledge reflects empirical objective reality, and that every notion, judgment or scientific theory has quite definite objective content which we call empirical. The empirical concreteness of our knowledge is its conformity with sensory experience. Our everyday experience, practical activity, the experimental side of scientific cognition evidently possess the highest degree of empirical concreteness. But does it mean that empirical concreteness is not inherent in the theoretical knowledge of special sciences? Besides, can we make a categorical assertion that the knowledge resulting from empirical investigation is really the most concrete knowledge? It is indeed concrete in the sense that it is close to reality and rich in detail and color. Yet one cannot help feeling that such knowledge of details can very easily turn into a useless toy if it fails to distinguish the main, the significant, the essential, the necessary. The empirical knowledge of separate isolated facts permits tearing out individual parts or features of a whole and turning them into an absolute, a senseless abstraction. If the concrete is understood as the direct connection with the objective world, as the exact reproduction of sensually perceived properties and sides of an object, such knowledge will be the most concrete. On the other hand, if concreteness is understood as the fullness of all determinations of an object or a phenomenon, as a unity in the diversity or a diversity in the unity, such knowledge should be regarded with good reason as abstract. Conversely, if abstract knowledge is characterized by the separation, isolation of one or another element from the totality of other determinations, empirical knowledge which does not reveal all links and relations of a given object with the multitude of other objects can also be called abstract, sometimes even in the worst sense of this word. A purely empirical idea of a tree growing under my window and having, for instance, slightly drooping branches, a trunk reaching the height of the first floor and covered with gray-green bark, with light green buds on its branches the size of a wheat grain, etc. will be an abstract description despite the fact that I could add to it lots of such details which are known to no one but myself, since this tree was and will hardly be interesting for anyone as a possible object of an empirical description. Hence, the concepts of the concrete and the abstract themselves need a serious analysis. A detailed description of a tree growing in front of my window and presented to me in all its sensual concreteness turns out to be quite abstract, since my detailed description based entirely on the sense perceptions of the color of the bark, buds, the shape of the crown, the size of the trunk, etc. will hardly be helpful in determining its species. Any student of biology will find my description non-scientific and abstract, as it covers millions of trees in the middle part of Russia. Hence, an empirical description can be justly regarded as abstract, arbitrarily subjective, non-scientific, etc., since it does not permit distinguishing with certainty one object from a multitude of others. As we see, even a very detailed description of the external side of objects and phenomena can far from always be regarded as concrete knowledge without any reservations. It moans that the direct relationship between knowledge and reality, i.e. the sensual basis of knowledge, is not yet sufficient to make it concrete. Such knowledge is still incomplete and inaccurate, since it reflects but partially the real links and relations between a given object and a multitude of others. As to the reflection of the internal properties, bonds, contradictions, and laws governing the development of this object, such knowledge is even less satisfactory. Consequently, the knowledge of separate observable objects and phenomena, their properties and sides, can be regarded both as concrete, in the sense that it is directly related to reality, and as abstract, in the sense that it does not reveal the latent processes and internal laws and does not single out the main, the essential. 2. Marx and the Problem of Concrete Knowledge. By Igor Naletov. Now we come to the problem of concreteness in theoretical knowledge. If the scientific value of knowledge, the possibility of its verification and practical use derives from its concreteness, direct relation to objective reality, then the striving of scientists for ever broader generalizations, for universal statements and conclusions, must seem strange indeed, since the more general a statement, the farther it is removed from individual objects and phenomena. Again, it is evidently not without reason that theoretical notions and ideas are commonly believed to be abstract. And this would indeed be so if we identified concreteness with just one kind of it, empirical concreteness. Of course, it would not be correct to deny concreteness to sensual perceptions. Yet in dialectical logic the concrete is by no means tantamount to the sensually perceptible. The concrete in dialectics is regarded as a unity in diversity, as a full representation of different aspects and relations of objects and phenomena and, understood like this, is one of the central categories of logic, an expression of the real general, multidimensional which is inherent both in reality and in our knowledge. Another aspect of the concrete is that it represents the objective diversity of a whole object, the totality of all its relations, both internal and external. As regards the abstract as a logical or epistemological category, it expresses not only the specific distinction of thinking from reality and its sensual perception, but also represents a form of development common to both reality and cognition. In Marx, the problem of the relation of the abstract to the concrete includes not only the relation of thought to the sensually perceptible but also the problem of the internal division of any object and its theoretical reproduction in the movement of notions. The question of the relation of the abstract to the concrete presents itself in two aspects: first, as the relation between partial and limited knowledge to fuller knowledge, and, second, as the relation of the whole to its own moments standing out objectively in its content. For Marx, the abstract and the concrete express internal contradictions, the movement of which is the life of the object of investigation. It is not a pure epistemological definition of the methods of work of the human brain in which one element can be identified with the sense perception, and the other element, with the theoretical generalization of the data of sensual experience. It is not a simple definition of the different poles of cognitive activity, even if they are regarded as connected with each other, but also an expression of the internal separation of objects and links between separate sides and phenomena existing objectively outside and independently of human consciousness. Hence, the abstract, according to Marx, can express both the particular and the general to the extent to which these sides stand out objectively in the whole and represent internally dependent, but externally isolated formations. Engels shows the same understanding of the categories of the abstract and the concrete. For him, the formation of general concepts is the process of abstraction from the multitude of inessential properties, features, objects, and phenomena and of the retention of their common, stable, essential properties and features. On the other hand, the formation of theoretical concepts is at the same time a process of concretization, integration, enrichment, and retention in thought of the real content of all relations and links embraced by the given concept. It was Engels who defined exhaustive knowledge as the transformation of the single into the universal and maintained that the general law of change of the form of motion is much more concrete than any single concrete example of it. According to Marx, the coordination and combination of abstractions, the ascent from the simple to the complex is not the mental reproduction of the concrete. The method of advancing from the abstract to the concrete, he wrote, is simply the way in which thinking assimilates the concrete and reproduces it as a concrete mental category. This is, however, by no means the process of evolution of the concrete world itself. Hence, Marx regards the concrete as the unity of diverse aspects and as diverse aspects of the unity both in reality itself and in cognition. It is true of dialectically interpreted laws and abstractions, as well as of the particular phenomena they reflect. If an investigator proceeding from a general abstract law does not lose sight of the actual circumstances conditioning the operation of this law, if he takes into account the interdependence of this law and other laws and the numerous links connecting them, his thinking is concrete. The concrete concept, wrote Marx, is concrete because it is a synthesis of many definitions, thus representing the unity of diverse aspects. It appears therefore in reasoning as a summing up, a result, and not as the starting point, although it is the real point of origin, and thus also the point of origin of perception and imagination. The interpretation of the concrete and the abstract by Marx and Engels was by no means playing up to the Hegelian manner of reasoning. It was a conscious and deliberate use of Hegel's language, transformed and amended, which conveyed profound dialectical ideas. Proceeding from his concepts of the abstract and the concrete, Marx, naturally, regards the ascent from the abstract to the concrete as the only possible and therefore correct scientific method whereby the concrete can be assimilated and mentally reproduced in theoretical analysis. It should be noted, however, that some philosophers' enthusiasm about the method of Marx's analysis carries them sometimes too far, and they begin to absolutize it and even counterpose the abstract and the concrete, which is entirely alien to Marx's analysis. In our opinion, such absolutization is traceable to two inaccuracies in the interpretation of Marx. First, the abstract and the concrete as such are ascribed to reality itself, as is evidenced, for instance, from the commonly used and nonetheless confusing expression "this concrete object." Second, the abstract and the concrete as the starting and the final points of theoretical analysis are regarded as two poles in the development of scientific knowledge without taking into account their dialectical unity, mutual penetration similar to that of the magnet poles, which can only exist as a single whole. It is assumed, for instance, that the abstract and the concrete exist in reality as separate, isolated objects and phenomena. Marx's abstract labor, abstract man, abstract wealth are sometimes regarded as objective entities existing, so to speak, in a pure form. The analysis of these concepts, objective as they are, calls for a more subtle approach which would better accord with Marx's conception. The acceptance of the reality of such things as abstract labor, abstract man, etc. would be tantamount to recognizing the actual existence of matter, space, and other special entities alongside definite objects and phenomena of the objective world. Speaking of such things as abstract labor and abstract individual, Marx regarded them as clear-cut abstractions in a definite conceptual context and never treated them as actually existing independent separate entities. Some literary critic may seize upon these words in an attempt to substantiate his own opinion that it is only concrete things which exist in objective reality. To forestall his argument, we shall state at once that this current view, which is often expressed in literature and has many persistent advocates, seems to us one-sided, if only for the fact that the concepts of the abstract and the concrete are correlative and, as such, are only meaningful in inseparable unity with each other. The elimination of one concept makes its counterpart nonsensical. Understandably, this only holds true if the problem is treated from the same epistemological angle and within the framework of one and the same subject. It stands to reason that the isolation and relative independence of objects and phenomena makes it in principle impossible to form an absolutely concrete notion of an object, whereas the objectification of the concrete tends in fact to absolutizing it. A given object can never possess at a given moment all the possible properties and features which may reveal themselves in a different place and at a different time. One and the same man turns out to be different, or, at least, not quite the same among his friends, in the office and at home. In which surroundings, then, are we to consider him concrete? Evidently, in all, but each time differently. Concreteness is relative, but not absolute. Now, are all these subtleties really so important that we have to accentuate them? Maybe it is simply a question of terminology, and the objectivity of concrete objects and phenomena is identical with the objective foundation of concrete analysis. We suppose that some philosophers accepting so far our reasoning might just intervene at this point and add that objective reality has neither abstract nor concrete objects and, consequently, the concepts of the abstract and the concrete are nothing but the product of our exalted materialistic imagination inventing the absolutes of the abstract and the concrete and striving to impose them on the virgin scientific mind with its natural aversion to metaphysical concoctions. So, they may conclude, we come in the end to what they have been trying to prove all along. As regards the real existence of abstract and concrete objects, we might perhaps accept this view, characteristic of positivist philosophy, even at the risk of being censured by those who reject any shades and halftones in a philosophical controversy and recognize but one rigid scheme. We feel obliged, however, to make one important reservation and are ready to hold on to it as a matter of principle. We are convinced that objects in reality itself stand in different relations to one another, and we can speak of some objects and phenomena as being relatively abstract, and of others as being relatively concrete. When considering the relations of the first kind, we form abstract notions, categories, and ideas and then set about concretizing them. The unity of the abstract and the concrete, i.e. the unity in diversity, gives a complete idea of an object, an idea which Marx calls concrete universal as distinct from just concrete. The real links between the concrete and the abstract being established, they become correlated concepts, and not metaphysical absolutes. It is through the interaction with each other that they get the measure of their truth, as well as the measure of their concreteness. Each concept turns out to be abstract to the extent to which it reflects the separateness, isolation, and specificity which are objectively inherent in things. Similarly, category becomes concrete to the extent to which it reflects the integration, unity, and mutual complementarity of things. Logical concepts, wrote Lenin, are subjective so long as they remain abstract, in their abstract form, but at the same time they express also the things in themselves. Nature is both concrete and abstract, both phenomenon and essence, both moment and relation. Human concepts are subjective in their abstractness, separateness, but objective as a whole, in the process, in the sum total, in the tendency. The objective interpretation of the categories of the concrete and the abstract not only makes the presentation of material more difficult and the language more cumbersome. It brings in new entities which do not exist as independent objects of reality, tends to absolutize them, breaking the inseparable bonds, the unity of mutually penetrating sides of the material world, and is, in fact, incompatible with the dialectics of the abstract and the concrete. This interpretation can at best postulate the transition from one isolated concept to another, e.g. from the abstract to the concrete. Important as it is, such transition is but one of the aspects of the dialectical relationship between these categories. However, to understand their relationship in a stronger, more profound sense as a inseparable connection of two different aspects of scientific cognition, as a correlation, it is necessary to investigate the relation of these categories to objective reality and to define their counterparts in the objective world. Analyzing the transition from the abstract to the concrete, Soviet scholar E.V. Ilyankov writes, understandably, concrete knowledge can only appear as a result, a sum total, a product of special work, and the abstract, as its starting point and material. This is undoubtedly true in relation to some definite level of knowledge, theoretical knowledge in this particular case. In his analysis of the system of capitalist production, Marx strictly adheres to the principle of ascent from the abstract to the concrete. Yet in presenting the dialectical relationship between these two categories, one should also take into account the titanic work carried out by Marx in order to accumulate and screen the Mont Blanc of facts. The concreteness in the implementation of the principle of concreteness itself calls also for differentiation between different levels of scientific cognition, empirical, theoretical, applied, philosophical, etc. At each of these levels, the dialectical relationship between the abstract and the concrete inevitably acquires specific features. In this relationship, one thing only remains constant, invariable, something like the space-time interval in Einstein's theory of relativity, the inseparable unity of the abstract and the concrete in the process of cognition. There can be no absolutely abstract or absolutely concrete knowledge, just as there are no absolutely abstract and absolutely concrete notions. Certain knowledge and certain notions can be more abstract and more concrete than others. Since all our knowledge at any stage is realized through the interaction of the abstract and the concrete, it can be viewed as a constant process of transition from one level of concreteness to another and from one level of abstractness to another. For instance, from the sensual form of concreteness and its specific form of abstractness, we pass to the empirical form of their interaction at the lower floor of scientific cognition. Science ascends from the empirical forms of the concrete and the abstract to the theoretical level of their relationship and further rises to the philosophical level. It is evidently within the limits of one level of cognition only that we can speak of the method of ascent from the abstract to the concrete, meaning a strictly definite form of either category. The formation of abstractions, the deduction of the general, similar, identical has never been and will evidently never be a special aim of science. As a matter of fact, it takes no great effort to find similarity even between most different objects, such as, for instance, a shoe brush and a mammal. Science, for that matter, is notable for just the opposite tendency, the striving for mental reproduction, restoration of the concrete whole which is split in the process of abstraction. Sensual cognition also reproduces an object in its wholeness, joining, however, only its external aspects and properties in a single sensual perceptible image. Each level of cognition, be it empirical or theoretical, has its own forms of concreteness and abstractness, and the knowledge at each of these levels develops from the abstract to the concrete. On the whole, however, it passes on from one form of abstractness to another, and from one form of concreteness to another. Generally speaking, the concreteness of a notion or any other form of knowledge should be linked, in our opinion, not only with the sense perceptions of the object under investigation, but also with the degree of reflection of all its bonds and relations of mediation with other objects and phenomena, with other aspects, tendencies, and changes. Knowledge is concrete not only when it gives a detailed reflection of the properties and aspects of the object or phenomena under investigation, but also when it is capable of reproducing all its links and relations with other objects and phenomena, including their internal aspects and elements. Conversely, a notion, an idea, or any other element of knowledge are abstract to a degree to which they are isolated from other objects and phenomena connected with them. An abstraction is concrete if it mentally reproduces the unity, diversity, and many-sidedness of real objects, if it singles out and indicates those aspects of the object or objects of interest which appear to be topical or important for human activity at a given moment. An analyst can evidently always find at least one common objective feature of any two objects or phenomena whereby they can be placed into a single category. Such generalizations have no methodological value until they acquire theoretical concreteness. They are also very abstract in the sense that they do not indicate any concrete conditions under which the generalization is of any scientific significance. Scientific abstractions are a powerful means of cognition, but they remain useless without close ties with the concrete, without practice. If an abstraction is combined with the diversity of the objective content of phenomena, and thinking concentrates on those elements of this diversity which have been placed in the foreground by life itself, such thinking is concrete, scientific, and true. If scientific analysis proceeding from facts reveals underlying regularities and makes it possible to draw theoretical conclusions, we have the unity of the abstract and the concrete. Should thinking prove unable to find the unity, the order in a system, should it fail to single out the prevailing tendency in the actual diversity of phenomena, in that case a concrete approach to the problem gives way to empirical vacillations between the concrete and the abstract, and the investigator cannot see the wood for the trees. Consequently, knowledge remains abstract, though not in the empirical sense of the word, as long as it does not distinguish between the essential, necessary, and the inessential, accidental features and tendencies, and does not reveal the law governing a given process. Abstract also will be the knowledge which does not show the opposite aspects and tendencies inherent in every phenomenon or process. The number of such abstract, in the methodological sense, generalizations can be increased indefinitely, yet they would hardly add to the potential of science. Generalizations of this kind do not carry any new information, they are methodologically barren. Indeed, as Engels has wittily remarked in Anti-Düring, a shoe brush grouped with mammals will not grow mammary glands, and, consequently, such a generalization will hardly do any good to humanity. True, a lot of pseudo-scientific investigations are in fact concerned with inventing ever new abstract generalizations claiming to contribute to science. Paradoxical as it is, the empirical soundness of such investigations is usually unquestionable. Most of the generalizations of this kind are indeed based on the common features of real things. It should be noted that such tendencies are particularly characteristic of philosophical investigations aimed exclusively at generalizing the material of special sciences. The authors of such investigations can at best claim the invention of new terms of doubtful scientific value. It hardly needs mentioning that the growing number of abstract generalizations tend to clutter up knowledge with all kinds of pseudoscientific nonsense and turn science into a depot of useless ideas that will never be applied to real scientific and life problems. Every generalization which is to qualify as scientific should be concrete not only in the empirical, but also in the theoretical sense. Giving new information, it should also have a theoretical value, i.e. indicate ways for the further progress of scientific knowledge and disclose new links and relations of a given object with other objects and phenomena. As long as a concept has a heuristic value and opens up new ways for scientific cognition, it remains scientifically valid, and not only historically significant. It should be noted, however, that the actual validity of a scientific concept, a theory, or even a law is not an honorary title conferred on them in perpetuity, since methodological or heuristic value may not only be acquired, but also lost. Filling up a gap in our knowledge, scientific concepts give a fresh impetus to thought, but subsequent events may prove their empirical untenability. This problem, by the way, has given rise to continuous debates among the historians of science as to whether the concepts of ether, thermogen, phlogiston, vital force and the like should be regarded scientific. The answer to this question can never be a blunt yes or no. In order to qualify as scientific, a concept must possess at least one of the above forms of concreteness and, besides, must help towards further progress of scientific knowledge. An abstract generalization of empirical data is at best a prerequisite for scientificity. It is concerned with the knowledge already available and gives no new information, thus providing no basis for the analysis of reality, for distinguishing between separate properties and aspects of the world. Such concepts and statements result, as a rule, from the striving for unduly broad generalizations. The concept of control relating, for instance, to social phenomena will be quite concrete if used in the analysis of social development. It will evidently be also concrete when applied to animate nature, since here, too, it can be connected with the ideas of feedback, data transmission, etc. In this field, like in the field of social phenomena, a comparatively weak information signal can actuate the feedback mechanism and bring about considerable changes, and not only in terms of power. Suppose now we comply with the insistent demands of some authors and extend the concept of control to the phenomena of inanimate nature. Of course, given the will, we should also discover here certain analogies with the feedback mechanism. Yet the character of interaction in inanimate nature is different from that in living organisms, particularly in what concerns power relationships. Hence, we cannot speak of anything more than just a formal similarity between physical interaction in inorganic nature and feedback mechanisms in the organic world and in society. Any attempt to extend the concept of control to natural physical, geological, or geographical processes will result in an untenable generalization yielding no scientific results. Take another example. The scientific value of the concept 01, information is common knowledge. This concept, which is now widely used in different branches of knowledge, has played an important role in the successful development of cybernetics and in the solution of numerous problems in genetics, neuropsychology, and other sciences. It has also proved very helpful in defining the essence of consciousness and in studying the nature of the ideal as opposed to the material, since it provided a link between the processes of man's conscious activity and its neurophysiological mechanism. On these grounds, some philosophers propose to regard the concept of information as a universal one and classify it as philosophical. Here, however, they transgress the demarcation line beyond which the concept of information loses its scientific concreteness without becoming concrete in the philosophical sense. A simple generalization on the basis of empirical analogies deprives it of the necessary heuristic value. Hooker, for instance, identifies information with consciousness, on the one hand, and with brain processes, on the other, calling both information concepts. He in fact discards the problem of the relationship between consciousness and the brain by simply identifying them as equivalent information processing structures. This solution, purely phenomenalistic as it is is nevertheless regarded as sufficient grounds for proclaiming a new systematic ontology, since the proposed concept endows consciousness with time, spatial and even causal characteristics without depriving it at the same time of some properties of mental activity. It is not hard to see that Hooker's way leads to an ontology in the spirit of Plato. The current attempts to identify the concepts of consciousness, the brain, and information often go even further and tend to universalize the concept of information, which is alleged to characterize any existing system in general. To substantiate this viewpoint, references are made to cybernetics, which has purportedly provided conclusive evidence to the effect that the concept of information expresses the property of any moving matter. Such a broad interpretation of the concept of information, however, deprives it of its analytical possibilities and obliterates the border between inorganic processes in nature and the processes of control, which are distinguished by the transmission, reception, and coding of signals rather than by a specific power relationship. As is evidenced from the above, the scientific value of a concept or other form of knowledge is directly connected with its concreteness and depends on whether it gives new information in the field where it is introduced. In modern science, fruitless abstractions are still very numerous and constitute what may be called pseudoscience or metaphysics in the bad sense of the word. They are a useless ballast and science should get rid of them. In its struggle against the anti-metaphysical positivist program, dialectics definitely dissociates itself from fruitless abstractions. It should always be borne in mind, however, that the weak sprouts of new knowledge are sometimes not easy to distinguish from stunted and useless metaphysical concepts, and that they can only turn into full-fledged concrete concepts of great scientific value as a result of subsequent development. Abstract generalizations and metaphysical conclusions should by no means be regarded as just a nuisance having no serious effect on scientific cognition. In social sciences, such abstractions are not infrequently connected with quite definite ideological aims. In view of their pseudo-scientific form and apparent empirical certainty, they are taken for a solution to one or another problem, whereas they in fact detract science from the true course. The seeming concreteness of a proposed concept is but empirical concreteness, which levels up all facts and features relevant to this concept and equates the main and the secondary, the necessary and the accidental, the external and the internal traits. Such a concept, of course, is a platitude in the first place, as it gives no grounds for some differentiation and analysis in a given field of knowledge. Yet it becomes something more than just a truism, a meaningless phrase. It turns into an instrument for deliberately juggling with facts instead of conducting a concrete scientific investigation. With positivism, by the way, it was a common and rather well elaborated trick which was time and again exposed by Marx, Engels, and Lenin. Formally imitating the external features of the specialized language used in mathematics, linguistics, physics and biology, the positivist philosophers create an illusion that the representatives of these sciences understand the language of their philosophy. It sometimes escapes the natural scientists that the terms borrowed from their language lose their concreteness and turn into verbal dummies, preserving, however, the form and the reputation of scientific certitude and clarity. It is not fortuitous that Lenin has always been intransigent to play with words. The application of various terms borrowed from biology and energy physics, such as exchange of substances, assimilation and assimilation, power balance, entropy and the like, to such socio-economic phenomena as crises, class struggle, competition, capital, etc., is in a sense a verbal ornament which adds nothing to the understanding of these phenomena for all its seeming newness. Yet it is not a harmless play, particularly when it comes to analyzing the trends of social development. Such a terminological confusion tends to mislead a biologist or a physicist just as much as a sociologist or a political economist. With an indiscriminate approach to philosophical generalizations, it becomes, in fact, inessential whether new scientific data are translated into the language of some special science or are given a philosophical interpretation. In both these metaphysical variants, the concrete meaning of the scientific data is reduced to naught. Modern bourgeois philosophy also abounds in the substitutions of special scientific terms for concrete concepts in sociology or political economy. It is true not only of positivism, but also of other philosophical trends which claim to offer alternative solutions. For instance, according to Jürgen Habermas, historical materialism is a one-sided, excessively concrete doctrine badly in need of a generalization, i.e. of a broader, more general, outlook. This generalization, as proposed by Habermas, boils down to replacing Marx's concept of productive forces by a concept of labor or purpose-oriented rational actions covering both the selection of means for given purposes and the selection of purposes themselves out of a multitude of possible variants. The concept of the relations of production is to be eliminated in favor of such concepts as interaction, communicative activity, institutional framework, organizational principle, etc. In Habermas's opinion, labor is the sphere of learning and assimilation of useful technical information, whereas interaction is characterized by the processes of socialization and molding of personality on the basis of the generally recognized system of social norms. Hence, the first sphere corresponds to technical interest, and the second, to practical interest. The Marxist concept of superstructure becomes irrelevant. Some phenomena classified as superstructural, such as culture, social norms, and educational establishments, are to be transferred to the sphere of interaction. Other components of the superstructure, such as power and ideology, are interpreted either as a deviation or a distortion and, consequently, as some secondary phenomenon in the sphere of communicative relations. This kind of interpretation of history, its inner content cannot be accepted, first of all, from the methodological viewpoint, the more so as it claims to restructure the Marxist concept. Habermas seeks to consider classes, power, and ideology from the theoretical informative aspect, qualifying them at that as a distortion of the normal process of human relations. Being restricted to the appearance of things, such an approach is at best superficial. But it is not so harmless as it may seem. Speaking of the distortion in the communicative systems, Habermas completely ignores the real, essential differences between communicative processes in the opposite social systems, capitalism and socialism. Starting with a seemingly modest proposal to amend Marx's concept of the determining role of the mode of production in the historical process and to supplement it with a second dimension, the communicative one, Habermas actually seeks to turn Marx's concrete definition into an empty abstraction and thus deprive it of its scientific value. The interpersonal communicative factor introduced by him by way of supplementing the dialectical understanding of the nature of man immediately calls for a new sacrifice, the generalization of the Marxist understanding of man's nature. The new way of thinking advocated by the Frankfurt School is obviously constrained by the concepts of the mode of production, social relations, and the socio-economic formation, particularly when it comes to the analysis of such concepts as capitalism and socialism, the bourgeoisie, and the working class. The concept of communicative processes is more congenial to this way of thinking if only for the fact that it is abstract. Habermas goes even as far as claiming certain affinity between Marxism and positivism, alleging that they both restrict history to its one dimension, labor and production activity. According to Habermas, the dimension of communication, intersubjectivity and interpersonal relations obvious in Marx's concrete analysis completely disappears in his philosophical and historical generalizations, resolving in the concept of practical actions aimed at nature. This model, according to Habermas, had an adverse effect on Marx's understanding of anthropogenesis. The process of labor and production activity regarded by Marx as the determining factor in the evolution of man from the animal world is confined exclusively to the sphere of instrumental activity characteristic of the animal world. Contrary to Marx, Habermas maintains that the determining factor in the process of anthropogenesis was the emergence of the communicative dimension, i.e. the replacement of the institutional control by the behavioral control effected with the help of norms and linguistic incentives. Thus mankind regarded by Marx as the object of evolution becomes, according to Habermas, its subject. There are absolutely no grounds for regarding Marx's view on anthropogenesis as limited or lopsided. He has developed a consistent theory of man's practical activity directed to the external world as the motive force of anthropogenesis. This activity contributed to the formation of erect gait, the appearance of the first signs of the community of interests and joint labor, as well as to a considerable weakening of the instincts that determined primitive man's behavior. It also accounted for such new phenomena as the deepening process of socialization, the development of consciousness and language, the emergence of a new type of behavioral control, etc. The factors singled out by Habermas were operative either in the first, or in the second group of changes accompanying the process of man's evolution. Neither of them would anyway be regarded by Marx as having an independent value. Habermas's views do not supplement, but distort Marxism. Habermas and other philosophers make a serious error believing that Marx's concept of the essence of man can be supplemented by introducing at least one more feature, the factor of personal intercourse. This insignificant, at first sight, addition turns the Marxist conception of man into an empty abstraction which gives no methodological guidelines for understanding man's nature as the concrete expression of social relations. Yet it would be even more naive to think that the introduction of this abstraction does not do any harm to social sciences. The new concept of man shifts the emphasis and substitutes a secondary feature for an essential one. It can hardly be expected to provide a solid basis for a more profound understanding of social development. What complicates the matter is that such an approach seems to be quite relevant and even necessary from the empirical viewpoint. It ostensibly concentrates on those aspects of the concepts of man and society which have not received sufficient attention and appears therefore scientifically valid. However, for all the seeming empirical soundness and even appropriateness of the proposed amendments, they are basically fallacious. The fault lies with the methodology itself, which presents the empirical material in an entirely wrong light. It would probably be unnecessary to focus attention on such attempts to complement Marx if they were merely aimed at filling up gaps in our concepts of society and man and did not represent a methodology incompatible with Marxism. In point of fact, they remind one of the behavior of a cuckoo trying to lay an egg into another bird's nest. The eggs do look very similar, yet the nestlings are quite different. Since the methodological principles of Marx do not always lie on the surface, one might get an impression that the point at issue is a purely factual one. Let us see if it is really so. Suppose you allow your mind's eye to dwell on an array of well-known personalities, Pushkin and Dantes, Gandhi and Goebbels, Raskolnikov and Peter Zalimoth, Mozart and Salieri. Nothing seems to be simpler than to define the essence of man by passing from one personality to another. Similarities and differences, differences and similarities, the twists of characters, the vicissitudes of life. It may be that we shall succeed in determining the general traits and the specific features of each man's character. Having thus defined man's essence, we may turn our attention to his surroundings and project his behavior in different circumstances in order to reproduce the makeup of every single individual and thus to understand the relations between people. After that we may go even further and try to understand the nature of society as a whole, proceeding again from the obtained definition of man. Such an approach appears to be quite relevant by virtue of its empirical concreteness. Indeed, we are seemingly concerned with concrete individuals, concrete biographies reproducing each man's life story with all its details, both significant and otherwise. One would naturally expect it to be the only correct path that would lead us to the comprehension of a concrete living being. Yet it is precisely this path that leads nowhere. True, the real scientific value of empirical concreteness is not quick to reveal itself. We only find it out after discovering that the single standard needed for comparing the heroes of our scientific drama turns out to be nothing better than just their general biological characteristic. The only catch that the empirical net thus brings us is a lean and meager abstraction indicating that each of our heroes belongs to the species of Homo sapiens. And that is all that remains of the living, thinking, feeling and acting individual. After the empiricist has thus stripped his man of every possible garment, he desperately starts covering him up with interpersonal intercourse, thinking ability, and what not. Then comes the turn of logic. Following its strict rules and proceeding from the obtained definition of man, the empiricist sets about reconstructing society at large. David Hilbert once noted that every man has a definite horizon, and when it narrows down to a point, the man starts talking about his viewpoint. We do not think Hilbert's statement is applicable to the whole of mankind, but in the situation we are dealing with, his joke evidently hits the nail on the head. What can the empiricist see from his viewpoint? Evidently, what appears to Marcuse and what he is horrified by. The biological nature of man, once we decide to start with it in accordance with Marcuse's logic, is, first and foremost, the sphere of instincts and attractions which have always been kept in check, at least till nowadays. Repression, in Marcuse's opinion, marks the entire history of man. Speaking of repression, Marcuse distinguishes basic repression connected with the general conditions of human existence, i.e. with the environmental influences, and the additional repression, resulting from the system of class domination and state power. According to Marcuse, it was the mind or human intellect alone that succeeded in escaping the effect of this omnipotent press. However, representing a pure cognitive ability and being free from the bodily functions of physical enjoyment and satisfaction of natural needs, intellect can be put to the task of practical and technical conquest of the world. The mind, alas, betrayed the pleasure-oriented body. Human sensuality was also seriously affected, though the senses are suppression-resistant too. Their power of resistance derives from the dual nature of the senses. They are the source of knowledge, on the one hand, and the instrument of pleasure and physical satisfaction, on the other. The system of suppression is therefore unable to cope with the senses and keep them in check by restricting their sphere to investigation activities only. As a result of the general distortion of man's sensuality, the cognitive function of the organs of perception was separated from the pleasure-seeking function. The senses were generally distrusted as a source of information, the data provided by them had a limited cognitive value, and they were suppressed by the mind. Above all, the senses could not serve as a basis for technical activity. This withering influence was exercised by civilization on practically all sides of the individual. Suppression was in fact the only, or at least the main feature of socialization. Labor is treated by Marcuse in a similar vein. One of the results of the total suppression of the individual in all extant industrial civilizations was the transformation of man from an instrument of pleasure into an instrument of labor. It was just to prepare man for productive activity that history remolded both his biology and his psyche. The concept of production is brought in by Marcuse for the sole purpose of putting a finishing touch to the somber picture of the suppression of the individual by industrial civilization, which adds yet another set of restrictions to the natural repressive forces. Marcuse's conclusions are based on a conviction that man as a biopsychical system is predestined to live exclusively for pleasure. Later, however, the author has substantially modified this view. Pleasure as understood by Marcuse cannot be derived from productive labor, nor from the extension of man's domination over matter. It must be, first and foremost, a result of the complete satisfaction of man's natural needs and of the free play of the natural forces inherent in the human body. In Marcuse's opinion, dialectics must free itself from the abstract universal forms of objectivity, as well as from the abstract universal forms of thinking. To this end, it should conceive its world as a definite historical whole in which present reality is a result of the historical practice of man. Yet practice is understood by Marcuse in accordance with his productivity principle, i.e. as activity detrimental to man. History thus turns into a continuous process of man's own enslavement, the restructuring of his whole organism aimed at suppressing to a maximum his biological pleasure centers. This process goes side by side with the expansion of the possibilities of using man as an instrument of labor, a working machine and a means for conquering nature. Marcuse comes out with great fervor against industrial civilization, the technological mode of thinking, scientism, etc., and also criticizes positivism, linking it with modern trends toward rationalization. Yet it needs no special insight to perceive that Marcuse's own methodology underlying his criticism is a typical expression of the very rationalization he speaks about with such disfavor. Indeed, his empirical approach, the denial of objective laws in nature and society, the atomized picture of social life, etc. are nothing but the characteristic features of the positivist method. Ironically, despite the premises which are not typically positivist, Marcuse's methodology, reflecting the standard patterns of the technical style of thinking, is indeed eloquent proof of the existence of a powerful ideological press acting on such different people as Eyre and himself. Marcuse's reasoning, like that of all positivists, is traceable to the old empiricist tradition. Roughly speaking, its logic boils down to the following. To form a concept of society, a philosopher takes the features common to every individual and supplements them with other features conditioned by the environment, thus obtaining human nature. Proceeding from this basis, he constructs the ideal model of relations among people, fitting it as close as possible to his abstract concept of man. Then he compares this ideal model with the actual relations interpreted in the light of his theoretical premises and proposes to restructure the actual relations, i.e. society, bringing it in conformity with human nature. The starting point in such concrete analysis is nothing but the abstract inherent in each single individual, i.e. the features common to all people. This approach, seemingly very concrete, is in fact extremely abstract, if only for the fact that the analysis concentrates on the personal qualities of a single individual taken at that outside the process of their formation and development and regarded as something static, immutable, accomplished. If the abstraction of man is to be scientifically valid, it must represent him not as an atom, but as a social being, and take into account both his place in society and the system of social relations. Another essential, though subordinate, characteristic of this abstraction is that it must reflect man's relation to nature. Speaking of man as an individual, we have no right to ignore the general factors determining his personal qualities. This is just a paraphrase in terms of methodology of what Marx wrote almost a century and a half ago: the essence of man is no abstraction inherent in each single individual. In its reality it is the ensemble of the social relations. Taking typical atomized individuals, outstanding or otherwise, for the starting point in the analysis of man's essence is attempting to revive obsolete methodological standards, long since discredited. To be sure, it is not easy to carry out the investigation in such a way as to start from the concept of the system of social relations and, using it then as a premise, proceed to the analysis of man's essence, nor is it easier to start analyzing social relations abstracting them from an individual. To arrive at this starting point in theoretical analysis, this elementary cell of the socium, Marx and Engels had to study all the history and prehistory of human society. It was titanic work indeed. The essential characteristic of Marx's analysis is that it permits revealing not only the general qualities inherent in every individual, but also the necessary features and relationships reflecting the laws of man's historical development. It is the analysis of the sum total, the ensemble of the socio-historical forms of social relations, which reveals the real trend of this development in its concreteness from the theoretical, and not empirical point of view. The universal is not equivalent to the similar represented in each individual object and regarded as their common feature. It is, first and foremost, a law-governed relationship of two or more individuals in which they pose as the moments of one and the same concrete and real, and not only formal, unity. According to Hegel, whose view was also shared by Marx, the form of universality as a law or the principle of connection of details within a whole which is totality. The universal can only be obtained through analysis, and not through abstraction. A single individual is essentially a man only because his unique makeup embodies historical necessity, and not because he possesses certain features, sometimes of secondary importance, common to other individuals. This viewpoint makes it possible to regard an individual as a personality not in the abstract sense, but as an embodiment of the entire history of mankind, of human civilization as a whole. This viewpoint alone provides a basis for understanding every single individual as a human being, since it reveals a core in the totality of his personal traits. This viewpoint, too, will undoubtedly prevent us from placing in the same category Mozart and Salieri, Gandhi and Goebbels, who may appear to be absolutely similar from the viewpoint of abstract logic. The concreteness understood dialectically has nothing to do with the establishment of such similarity of individuals. It represents the unity of all features and qualities of a man in their real connection with one another, in their dependence both on the biological nature of man and on the totality of all social conditions which play the dominant role. This approach alone can give us a theoretically concrete, and not an abstract concept of man. In other words, the theoretical definition of the universal in man is called upon to correct all the fallacies, contradictions, and errors of empirical analysis without denying its role in principle. Attempting in our times to construct a philosophical system or even a concept of man on an empirical basis is very much like starting to advocate the idea of the Earth's flatness. The concrete concept of man can only be developed if we proceed from the dialectical unity and interaction of the diverse forms, of specifically human activity, man's social abilities and social needs. According to the materialistic concept of the essence of man, the universal form of man's existence is represented in labor, in social man's direct transformation of nature with the help of instruments which he himself makes. It is not accidental that Marx was of such a high opinion of Benjamin Franklin's famous definition, man is a tool-making animal. In making tools man does not simply accept nature's demands, but creates a new system of relations. However, these relations on which he depends are out of his control. Such is Marx's viewpoint. The definition of man as a tool-making animal is a characteristic example providing a vivid illustration to the Marxist understanding of the universal as concrete and as related to necessity. The universal understood as concrete is opposed to the multitude of individuals not as an abstraction, but as their own substance, as a concrete form of their interaction. It is only in this capacity that the universal as concrete determination embodies all the richness of the particular and the individual, and this not only as possibility, but also as necessity. The universal therefore cannot be understood as the abstract identity of a multitude of events which serves as a basis for their classification under a single category. It implies additionally the singling out of essential links and relations and becomes, as it were, the substance of law. The universal is thus conceived as divided internally, as the identity of contradictions, i.e. as a living, concrete unity. The universal, as we see, turns out to be concrete only if it reflects the essential features of the objects and phenomena of reality and does not take into account the inessential, accidental features and properties. Thus, we can speak of theoretical concreteness which consists not in direct connection with objective reality, not in the detailed representation of individual aspects and properties, not in direct sensual perception, but in the singling out of the main, the essential, the necessary, the regular. From the empirical viewpoint, theoretical knowledge is indeed abstract in the sense that it is removed from sensual perceptions and its links with the external world are mediated. Yet it is concrete in the sense that it reveals those links and relations which are outside the sphere of empirical knowledge. In point of fact, theoretical concreteness includes empirical concreteness which is preserved in the body of a deeper and more concrete conception, not in the sense that theory is specific and demonstrative in accordance with the requirement of empirical concreteness, but only in the sense that it preserves in most cases more or less direct links with experience, experiment, practice. Without revealing the main, the essential, the necessary, i.e. the substance of scientific law, knowledge would remain quite abstract from the theoretical viewpoint. Lenin wrote, essentially, Hegel is completely right as opposed to Kant. Thought proceeding from the concrete to the abstract, provided it is correct, does not get away from the truth but comes closer to it. The abstraction of matter, of a law of nature, the abstraction of value, etc., in short, all scientific abstractions reflect nature more deeply, truly, and completely. Indeed, without the knowledge of law, individual facts, even a multitude of them, remain abstract. They may be snatched out of the context and their significance may be arbitrarily overemphasized, they may be opposed to all other facts and events. It stands to reason that such knowledge would not be truly scientific. Moreover, one and the same fact or a totality of facts may be interpreted in entirely different ways in the context of different theories. Hence, one and the same empirical basis may be used to construct very different scientific theories. It should also be borne in mind that the significance of various facts, their real scientific value cannot be established if we ignore laws. The thing is that facts characterizing one or another object or event prove, as a rule, contradictory. If we see an apple falling and trust our own eyes, we should expect it to fly upward or sideways on the other side of the planet. Standing on the shore, we can see the ocean retreating and then advancing again. We can observe a bird soaring up or falling or evenly descending. Examples of this kind can be cited ad infinitum, and in any of them the correctness of our observation, the scientific value of our knowledge can only be proved if we reveal the operation of laws behind them, the law of gravitation in the first example, the law of tidal motion in the second, the aerostation law in the third, etc. In other words, in each of the phenomena we observe we must define the internal links which do not lie on the surface. The knowledge of laws, undoubtedly, makes our cognition more concrete, though it is quite obvious that laws are abstract statements. Point 3. Concreteness of Materialist Dialectics. By Igor Naletov. We have been concerned so far with special sciences or, more precisely, with those forms of concreteness which are characteristic of empirical and theoretical investigations in physics, biology, psychology, etc. What about the concreteness of philosophical categories themselves? This is, in fact, the essence of the matter, the more so as the very idea of concreteness of such laws and categories of dialectics as the transformation of quantitative into qualitative changes, the unity and struggle of opposites, the negation of negation, necessity and chance, cause and effect seem to be quite paradoxical at first sight. The question of the concreteness of philosophical knowledge evidently calls for special investigation which goes beyond the scope of this work. Since our object is to compare the basic principles of the philosophy of science and dialectical materialism, we feel justified in confining our analysis to just a few laws and categories. It is not at all accidental that Lenin has taken special note of this idea in Hegel's lectures on the history of philosophy. If the truth is abstract, it must be untrue. Healthy human reason goes out towards what is concrete. Philosophy is what is most antagonistic to abstraction. It leads back to the concrete. To Lenin, this statement has evidently carried profound meaning, as is evidenced not only from his philosophical ideas, but also from numerous economic and political works. As regards Lenin's philosophical works proper, he has always placed special emphasis on the principle of concreteness and pursued it with remarkable consistency. This particular aspect of his philosophical heritage deserves special attention. Do we always realize, for instance, the profoundness of his well-known statement that the contrast between matter and mind is meaningful within the framework of the fundamental question of philosophy only? The assertion of positivist philosophy that the concepts of matter and consciousness are metaphysical and can be replaced by more concrete notions of special sciences, such as physics, mechanics, biology, psychophysiology, neuropsychology, and others results, in the final analysis, from its inability to understand the philosophical concreteness of the concepts of matter and consciousness. At all stages of the evolution of positivism, its adherents have persisted in declaring the concept of matter to be a fruitless abstraction, an absolute and useless symbol, on the grounds that all materials needed for scientific investigation are given to man in the senses, in individual experience. Hence, there is no need, according to positivism, to project something transcendental, something that extends beyond the limits of sensual perceptions. It is significant that the concept of matter or of the physical world proves to be a useless abstraction within the framework of positivist philosophy only. Recognizing formally the existence of this world, none of the adherents of this philosophy goes beyond the abstract, metaphysical understanding of matter. Setting up an impassable barrier between matter and the cognizing subject, positivism, naturally, is unable to provide a concrete solution to the problem of the relationship between the material world and the world of human consciousness. In this field, positivism did not go beyond Kant, and Hegel's assessment of Kant's philosophy is fully applicable to positivist views. The essential inadequacy of the standpoint at which philosophy halts consists in this, that it clings to the abstract thing in itself as an ultimate determination. It opposes reflection, or the determinateness and multiplicity of the properties, to the thing in itself, while in fact the thing in itself essentially has this external reflection in itself, and determines itself as an entity endowed with its proper determinations, or properties, whence it is seen that the abstraction of the thing, which makes it pure thing in itself, is an untrue determination. No one denies that matter is given man in his sensations and that we should resort to a very high degree of abstraction in order to oppose mentally matter to consciousness, sensations, perception. Yet such abstraction is inevitable if we want to have a more concrete understanding of their relationship. Positivism makes a stand for the inseparable connection between matter and consciousness, knowing, in fact, nothing about what is connected with what. By contrast, Marxist scientific analysis is aimed at creating abstractions in order to obtain a concrete understanding of the real, specific forms of the interconnection of matter, the objective world, with consciousness. As is evidenced from the above, the concepts of matter and consciousness are only valid within the framework of the fundamental question of philosophy. In order to get a profound understanding of the relationship between matter and consciousness, it is necessary to reveal all the forms of their interaction, which is not confined to the reflection of objective reality in our consciousness, but also includes the influence of consciousness on the outer world. Of course, Lenin writes, even the antithesis of matter and mind has absolute significance only within the bounds of a very limited field, in this case exclusively within the bounds of the fundamental epistemological problem of what is to be regarded as primary and what as secondary. Beyond these bounds, the relative character of this antithesis is indubitable. The concept of matter is not correlated with the individual forms of the cognition of reality, nor with the concepts of information, code, or something else of this kind. It is correlated with the concept of consciousness only. What is more, this correlation has any sense in connection with the problem of the dependence of consciousness on matter and the historical formation of matter and consciousness. The concept of matter, which is seemingly extremely abstract as it takes no account of all aspects and properties of things except just one, their existence outside and independent of our mind, is in fact epistemologically concrete as it is meaningful in the context of the fundamental question of philosophy only. Outside these bounds, the concept of matter has no independent philosophical meaning, though it can be used as a stylistic substitute for some other, special terms. At the same time, no knowledge in general can be concrete without the abstractions of matter and consciousness as the opposite sides of reality, if only for the fact that without the solution of this fundamental problem it would be impossible to decide which elements of our knowledge can be regarded as true, objective, and independent of man, no matter how far our science may advance, and which elements are connected with consciousness in one way or another, and, hence, are subject to testing and verification in the general context of human experience and available scientific data. As we shall try to show later, distinguishing between the objective and the subjective in our knowledge is absolutely essential for making our knowledge concrete. Consequently, no particular experiment aimed at testing the materialist solution of the fundamental question of philosophy will be of any use if it fails to take into account the epistemological concreteness of the concepts of matter and consciousness. This question can only be solved if we abstract from the interconnection of matter and consciousness. Not many experiments can meet this requirement. Yet if science can provide evidence that consciousness appears as a result of the activity of the brain, that certain functions of consciousness can be exercised by a computer, and that nature existed prior to man, this scientific evidence is sufficient to confirm the soundness of the materialist viewpoint. Conversely, should the reasonable beings who assumed the title of Homo sapiens choose to destroy the abode of their reason, this act, alas, will evidently be the last argument for materialism. Throughout its entire history, positivism has been denouncing, in one or another form and more or less resolutely, the principle of causality as typically metaphysical. Significantly, Marxism and logical positivism rejected this principle and the meaningfulness of the categories cause and effect on the grounds that they could not be tested empirically, i.e. verified or confirmed. The new generation of positivist philosophers armed with Popper's principle of falsification hold the same view yet on different grounds, namely, that this principle cannot be falsified. Since, they reason, it is confirmed by all human experience, without any exception, the categories of causality are applicable always and everywhere and therefore turn into commonplace devoid of any analytical, i.e. scientific significance. Popper does not deny the real scientific value of causal explanations, but presents their logical schema as follows: there is some universal judgment, i.e. a law, and a proposition characterizing the initial conditions in terms of individual events. From these two premises we infer a supposition regarding another individual event. The concepts of cause and effect are eliminated as unnecessary. Popper rejects completely the principle of causality in the general, philosophical sense. For him causality rather has an instrumental meaning as an assertion that any event can be explained in terms of causality, i.e. predicted through deduction, which is the same thing. Depending on the interpretation of the words can be in this assertion, it may prove either an analytical statement or a synthetic statement. If we interpret these words as a logical possibility to construct a causal explanation, this statement is tautological, since for any prediction we can always find a universal proposition and initial conditions so that it can be easily deduced from them. In some situations, however, the words can be are regarded as an indication that the world is governed by strict laws and that every phenomenon is an example of universal regularity or law. In that case the above statement should be regarded as a synthetic one, which is not, however, verifiable. Proceeding from this consideration, Popper concludes, I shall, therefore, neither adopt nor reject the principle of causality, I shall be content simply to exclude it, as metaphysical, from the sphere of science. I shall, however, propose a methodological rule which corresponds so closely to the principle of causality that the latter might be regarded as its metaphysical version. It is the simple rule that we are not to abandon the search for universal laws and for a coherent theoretical system, nor ever give up our attempts to explain causally any kind of event we can describe. Thus causality as something elusive is metaphysically identified with the concept of universal law. The principle of causality is understood in a very trivial manner. It is quite sufficient to know that the phenomenon in interest belongs to a certain class of phenomena in order to draw a conclusion that the effect or, more precisely, the predictable event belongs to just another definite class. Any violation of this necessary relationship indicates that one of the classes has been determined incorrectly and should be either broadened or narrowed. Such a concept of causality is indeed trivial from the methodological viewpoint, as it is aimed primarily at bringing every phenomenon in accord with the universal law or, more precisely, with a universal empirical generalization. As to its objective content, this concept does not postulate anything but the regular sequence or regular concomitance of events belonging to different classes. Oddly enough, such an understanding of causality underlies the entire logic of scientific discovery, though it is quite obvious that this methodological scheme rules out in principle the possibility of any discovery of new phenomena which go beyond the limits of the universal law or, at any rate, sets them in opposition to it. The universal law understood as regularity of events is incompatible with any new phenomenon in principle. Inversely, any new phenomenon, i.e. what Kuhn calls an anomaly in relation to the existing theory, is incompatible with the universal law. Consequently, it is not the principle of causality as such which is metaphysical, but its narrow, instrumentalist interpretation by Popper. His interpretation in fact eliminates causality from real science and reflects the ideal of Laplacian determinism, since Popper identifies causality with logical dependence, logical necessity. It is only natural, therefore, that such a canonized concept of causality and law has practically no appeal to science, particularly modern science. As we see, Popper's own errors lead him to the conclusion that the principle of causality is trivial, unscientific, and metaphysical. The truth is that his interpretation of the concepts of cause and effect are indeed alien to the spirit of real science. The scientists, particularly the natural scientists, never understand causality in such a narrow way as to throw doubt upon it each time an exact prediction proves impossible. Such a prediction requires the knowledge not only of the causal dependence, but also of the specific conditions of cognition. The strictly Laplacian ideal of prediction identified by positivists with causality is generally attainable in such sciences as the mechanics of macroscopic objects, astronomy, and loses its sense when we pass to such fields as hydrodynamics and the theory of elasticity. Despite the universality of the principle of causality, it is by no means simple to establish the true, objective causal relationship separating it from a multitude of intertwined and overlapping events and phenomena. The singling out of causal dependence from other kinds of relations is in itself a difficult problem from the methodological viewpoint. Even if an observer or an experimentalist have good reasons to expect a causal relationship, they have to display sometimes a high degree of ingenuity in order to create appropriate conditions for the identification of causal dependence. Even in those cases when the signs of causality seem to lie on the surface, it proves to be extremely important methodologically to define those abstractions and assumptions which have to be adopted each time the concept of causality is used in scientific cognition. The need for abstractions in cognizing causal relationships has been stressed by Lenin, hence, the human conception of cause and effect always somewhat simplifies the objective connection of the phenomena of nature, reflecting it only approximately, artificially isolating one or another aspect of a single world process. For instance, the kinetic theory of gases explains the chaotic motion of molecules, the distribution of the concentration of molecules in the field of terrestrial attraction, the emission of electrons from heated metal, the viscosity and heat conductivity of gases and other phenomena on the basis of the principle of causality. All these explanations proceeded from the assumption that gas consists of absolutely resilient minute spherical particles, that these particles possess kinetic energy only, that the magnitude of this kinetic energy depends on the absolute temperature of gas only, and that such molecules do not collide with one another. Though such assumptions somewhat distort the objective processes, as there are no gases in nature with the above ideal properties, they nevertheless reflect the conditions under which these processes actually take place. Indeed, under the conditions of moderate temperatures and relatively low pressures, the distortions allowed for numerous gases do not have any appreciable effect either on their qualitative or quantitative characteristics. Hence, the explanations and predictions are based not only on the recognition of causal relations, but also on certain assumptions presupposing the exact knowledge of conditions under which the process in interest takes place. These aspects of scientific investigation are closely connected with one another. Explanations and predictions are impossible without objectively grounded assumptions, whereas the assumptions themselves have any sense only in the context of the above explanations or predictions. Yet in the philosophical analysis of the principle of causality, it is advisable to distinguish these aspects as more or less independent objects of investigation which could be called an explanation, a prediction, and a substantiation of assumptions. The problem of the substantiation of assumptions in the context of an explanation or a prediction is not infrequently left out of account in philosophical investigations, so that the analysis is often confined to the concept of causality and to the solution of various methodological problems arising in natural sciences in connection with explanation and prediction. The study of initial conditions seems a secondary task which is always subordinated to explanation and prediction proper. Yet it is not difficult to show that the exact knowledge of these conditions sometimes turns out to be problem number one, which has to be solved before any explanation or prediction is ever attempted. Besides, if an existing law or theory suggests the existence of a certain causal relationship, the search for conditions under which this relationship can materialize becomes quite an independent research problem and calls for serious creative efforts which may lead to important scientific discoveries. Such investigations often give a powerful impetus to the development of experimental facilities, computers, conceptual and mathematical bodies.